Hello my dear students, welcome you to the Vedanta Karnataka. Nanu nimma maths teacher Rithika Ma'am. So ivattu physical chemistry du complete more chapters in a detail like understand ಮಾಡ್ಕೊಳ್ಳೋಣ. Plus we will see which are the questions which has repeated every time. Okay, so adnella ivat complete ಆಗಿ ನೋಡೋಣ. Before that please confirm me whether I am audible, visible properly to everyone. Even I will check once. Yes, perfect. Yes. That's good then. Okay, then start ಮಾಡೋಣ. So most I think January 2 first exam ಇರೋದು ನಿಮ್ಮದು chemistry ನೇ, right? Good afternoon, audible and visible properly. Thank you, Priyanka. Hi, Shashi. Good afternoon. Yeah, it's still good afternoon itself. Yes, January 2 ನಿಮ್ಮ ಎಕ್ಸಾಮ್ ಇರೋದು, ರೈಟ್? ಸೊ January 2 ಎಕ್ಸಾಮ್ ಇದೆ ಅಂದಮೇಲೆ ನಾವು ಎಲ್ಲರೂ ಪರ್ಫೆಕ್ಟ್ ಆಗಬೇಕಲ್ಲ. ಸೊ ಯಾವ್ಯಾವು ಮೀನ್ಸ್ ರಿಯಾಕ್ಷನ್ ಮೀನ್ಸ್ ಎಕ್ಸಾಂಪಲ್ ಹೇಳಿದೆ ಅಂದರೆ ಯಾವ್ಯಾವ ಪ್ರಾಬ್ಲಮ್ಸ್ ರಿಪೀಟ್ ಆಗಿದೆ ಅಲ್ಲ ಅವನ್ನೆಲ್ಲನೂ ಡಿಸ್ಕಸ್ ಮಾಡೋಣ ಇವತ್ತು. ಓಕೆ, ಡನ್. ಸೊ ನಾನು ಯಾವಾಗ ನಾನು ಹೇಳ್ತಿರ್ತೇನಲ್ಲ ದಿಸ್ ಫಾರ್ಮುಲಾ ಇಸ್ ಇಂಪಾರ್ಟೆಂಟ್, ಈ ಫಾರ್ಮುಲಾ ಮೇಲೆ ಒಂದು ನ್ಯೂಮರಿಕಲ್ ಪ್ರಾಬ್ಲಮ್ ಬೀಳುತ್ತಪ್ಪ ಅಂತ ಹೇಳ್ತಿರ್ತೇನಲ್ಲ, ಆ ಟೈಮ್ದಲ್ಲಿ ಪ್ಲೀಸ್ ನಿಮ್ಮೊಂದು ಬುಕ್ ತಗೊಂಡು ಅದರಲ್ಲಿ ಬರ್ಕೊಂಬಿಡಿ ಯಾವ ಫಾರ್ಮುಲಾ ಎದಕ್ಕೆ ಇಂಪಾರ್ಟೆಂಟು ಅನ್ನೋದು. ಸೊ ದ್ಯಾಟ್ ಈವನ್ ಯು ಪೀಪಲ್ ವಿಲ್ ಹ್ಯಾವ್ ಅ ಐಡಿಯಾ ದಟ್ ಯಾವ ಆ್ಯಕ್ಚುಲಿ ಕ್ವಶನ್ಸ್ ನಾವು ಫೋಕಸ್ ಮಾಡ್ಬೇಕು ಜಾಸ್ತಿ ಅನ್ನೋದು. ಓಕೆ, ಕ್ಲಿಯರ್? ಸೊ ಲೆಟ್ ಸ್ಟಾರ್ಟ್ ದೆನ್. ಮ್ಯಾಮ್ ಪ್ಲೀಸ್ ಡೂ MCQs ಆನ್ QN blank, ma'am, please. Hi, Purnima. KCET videos quickly, Beka. Let's finish the main exams, no? Ma'am, what is the difference between electrode and electrolyte, ma'am? Yes, that also we will learn it today. MCQs on QN bank, please. I didn't understand MCQs on QN bank, please. So clearly I didn't understand it. Please you can ask it once again. Okay, so start ಮಾಡೋಣ. First we'll do with the solution chapter and then with the electrochemistry and then we'll go with the chemical kinetics. Okay, so ಯಾವ್ದು ಬೇಕಾದ್ ನೋಡೋಣ. Let's see, first we'll finish with the solution chapter. So ಅದರ ಮೇಲೆ ಯಾವ್ಯಾವ numerical problems repeat ಆಗಿದೆ ಅಲ್ಲ ಅದನ್ನು ಡಿಸ್ಕಸ್ ಮಾಡೋಣ. As you people know already, model question paper ಇಂದ, okay, model question paper ಇಂದ ಯಾವ ಕ್ವಶನ್ಸು ಹೇಗೆ ಕೇಳಿದಾರೆ ಅನ್ನೋದು ನಿಮಗೊಂದು ಐಡಿಯಾ ಗೊತ್ತಿರಬೇಕು. ಆಲ್ರೆಡಿ ಮಾಡೆಲ್ ಕ್ವಶನ್ ಪೇಪರ್ ಸಾಲ್ವ್ ಮಾಡಿದ್ವಿ, ರೈಟ್? ಸೊ ಅದರಿಂದ ನಿಮಗೆ ಯಾವ ಪಾರ್ಟ್ನಲ್ಲಿ ಯಾವ ಥರ ಕ್ವಶನ್ಸ್ ಕೇಳ್ತಾರೆ ಅನ್ನೋದು ಈಗ ಐಡಿಯಾ ಇರುತ್ತೆ ನಿಮಗೆ, ರೈಟ್? ಸೊ ಈಗ ನ್ಯೂಮರಿಕಲ್ ಪ್ರಾಬ್ಲಮ್ ಪಾರ್ಟ್ ಇ ನಲ್ಲಿರುತ್ತೆ. ಮೀನ್ಸ್ ವಾಟ್ ಯು ನೀಡ್ ಟು ಕಂಪ್ಲೀಟ್ಲಿ ಫೋಕಸ್ ಮೋರ್ ಆನ್ ದ ನ್ಯೂಮರಿಕಲ್ ಪ್ರಾಬ್ಲಮ್ಸ್ ಇಟ್ ಸೆಲ್ಫ್ ಇನ್ ಫಿಸಿಕಲ್ ಕೆಮಿಸ್ಟ್ರಿ ಸ್ಪೆಷಲಿ ಇಫ್ ಐ ಟೆಲ್ ಯು, ಬಿಕಾಸ್ ಅದನ್ನು ಮಾಡ್ಕೊಂಡ್ಬಿಟ್ರೆ ಸಾಕು. ಅದ್ರ ಕಡೆನೇ ಜಾಸ್ತಿ ಕಾನ್ಸಂಟ್ರೇಟ್ ಮಾಡೋಣ ಇವತ್ತಾ. ಓಕೆ, question bank. Okay, plan, please do multiple choice from the question bank. Yes, multiple choice also I have taken it. Multiple choice questions also we have taken it. So we'll focus on that also. Okay. So January 2 ಗೆ exam actually ಎಷ್ಟು ಗಂಟೆಗೆ ಇದೆ ನಿಮ್ಮದು? 10 ಗಂಟೆಗಾ 9 ಗಂಟೆಗಾ ಎಷ್ಟು ಗಂಟೆಗೆ actually exam ಇದೆ? Please confirm me. So I was thinking like I'll give you people a last minute revision before you people go to the preparatory exams. So if you people are ಫೀಲಿಂಗ್ ಇಟ್ ಲೈಕ್ ಯಾವುದಾದ್ರೂ ಕ್ವಶನ್ಸ್ ಬೀಳ್ಬೋದಾ ಇದರಿಂದ ಅಂತ, ಸೊ ಅದಕ್ಕೆ. ಹಾಯ್ ರವಿ. ಓಕೆ ದೆನ್ ಲೆಟ್ ಸ್ಟಾರ್ಟ್ ವಿತ್ ದ ಚಾಪ್ಟರ್. ಫಸ್ಟ್ ವಿಲ್ ಗೋ ವಿತ್ ದ ಸೊಲ್ಯೂಷನ್. ಓಕೆ, ಸೊಲ್ಯೂಷನ್ ಚಾಪ್ಟರಿಂದ ಯಾವ ಥರ ಕ್ವಶನ್ಸ್ ಕೇಳ್ತಾರೆ. ಫಸ್ಟ್ ಥಿಂಗ್ ಈಸ್ ಒನ್ ನ್ಯೂಮರಿಕಲ್ ಪ್ರಾಬ್ಲಮ್ ಮತ್ತು ಶಾರ್ಟು ಸೊಲ್ಯೂಷನ್ ಚಾಪ್ಟರಿಂದ ಎಲ್ಲಿ ಕೇಳ್ತಾರೆ ಅನ್ನೋದು ಹೇಳ್ತೇನೆ. 10 o'clock. ಓಕೆ ದೆನ್ ವಿಲ್ ಟ್ರೈ ಟು ಸ್ಟಾರ್ಟ್ ಮೈ ಕ್ಲಾಸ್ ಅಟ್ 7:30. ಓಕೆ, 7:30 ಸುಮಾರು ಚಾಲು ಮಾಡ್ತೇನೆ. 10 to 1 ಇರುತ್ತಾ ಕ್ಲಾಸು? ಓಕೆ, ಡನ್. ಸೊ ಇಫ್ ಇಟ್ ಇಸ್ 10 to 1 ದೆನ್ ವಿಲ್ ಡೂ ಒನ್ ಥಿಂಗ್, ವಿ ವಿಲ್ ಕೀಪ್ ದ ಕ್ಲಾಸ್ ಅಟ್ 7:30. Is it okay? 7:30, 8 o'clock I'll start the class. 1 hour I'll give you people the all important questions before you go to your class, before you go to your exam na adin questions nodkondrunu saku. Okay. Hi Chinny. Oh hi Chinny, long back. Most important questions to pass. Yes, I will give it passing package anta one video madana. So adralli I'll tell you what type of questions needs to be studied anta. So I will do that also one day. Okay, don't worry about it. ಸೊ ಐ ಹ್ಯಾವ್ ರವಿ ಆ್ಯಕ್ಚುಲಿ ನಾವು 100 ಕ್ವಶನ್ಸ್ ಅಂತ ಒಂದು ವಿಡಿಯೋನೇ ಮಾಡಿದ್ದೇನೆ. ಅದರಲ್ಲಿ ಎಲ್ಲ 10 ಚಾಪ್ಟರ್ದು 100 ಕ್ವಶನ್ಸನ್ನು ತೊಗೊಂಡಿದ್ದೇನೆ ನಾನು. ಅದರಲ್ಲಿ ಎಲ್ಲ ರಿಪೀಟೆಡ್ ಕ್ವಶನ್ಸೇ, PYQಸೇ ಇದಾವೆಲ್ಲ. ಬಟ್ 50 ಮಾರ್ಕ್ಸ್ ನಿಮ್ಗೆ ಸೆಕ್ಯೂರ್ಲಿ 50 ಮಾರ್ಕ್ಸ್ ಬೀಳುವಂಥ ಎಲ್ಲ ಕ್ವಶನ್ಸ್ ತೊಗೊಂಡಿದ್ದೇನೆ ಅದರಲ್ಲಿ. ಸೊ MCQs ತೊಗೊಂಡಿಲ್ಲ. ಸೊ MCQs ಸಪ್ರೇಟಾಗಿ ಒಂದು ಮಾಡೋಣ. ಓಕೆ, ಎಸ್ ಚೆನ್ನಿ, ಸೂನ್ ವಿ ವಿಲ್ ಡೂ ಇಟ್ ಫಾರ್ ದ ಫಸ್ಟ್ PUC ಆಲ್ಸೋ. ಬಟ್ ನೀವು ಫಸ್ಟ್ PUC ಎಕ್ಸಾಮ್ ಯಾವಾಗಿದೆ ನಿಮ್ಮ ಸೊಲ್ಯೂಷನ್ ಅಂದರೆ ಏನು? ಸೊ ಸೊಲ್ಯೂಷನ್ ಮೀನ್ಸ್ ಆ್ಯಕ್ಚುಲಿ ಫಸ್ಟ್ ಥಿಂಗ್ ಯು ಶುಡ್ ರಿಮೆಂಬರ್, ಇಫ್ ಇನ್ ಕೇಸ್ ಯು ಆರ್ ಕಮಿಂಗ್ ಎಲ್ಲಾದರೂ ಒಂದು ಕಡೆ ಏನಾದರೂ ಸೊಲ್ಯೂಷನ್ ಅಂತ ಬಂದುಬಿಟ್ರೆ ನೀವೇನಂತ ನೆನಪಿಟ್ಕೋಬೇಕು ಅನ್ನೋದು ಫಸ್ಟ್ ನಾನು ಹೇಳ್ತೇನೆ. ಇಟ್ ಹ್ಯಾಸ್ 2 ಥಿಂಗ್ಸ್. ಓಕೆ, 2 ಥಿಂಗ್ಸ್ ನೆನಪಿಟ್ಕೋಬೇಕಿಲ್ಲಿ. ಸೊ ಯಾವುದದಪ್ಪ 2? ಸೊಲ್ಯೂಷನ್ನಲ್ಲಿ ಸೊಲ್ಯೂಟ್ ಅಂತ ಒಂದಿರುತ್ತೆ ಆ್ಯಂಡ್ ಸಾಲ್ವೆಂಟ್ ಅಂತ ಒಂದಿರುತ್ತೆ. ಕ್ಲಿಯರಾ? ಸೊ ಸೊಲ್ಯೂಟ್ ಅಂತ ಒಂದಿರುತ್ತೆ ಮತ್ತು ಸಾಲ್ವೆಂಟ್ ಅಂತ ಒಂದು ಇರುತ್ತೆ. ಸೆಕೆಂಡ್ ಇನ್ ದಿ ಪ್ರಿಪ್ರೇಟ್ರಿ ಸೆಕೆಂಡಿಂದಂತೂ ಪ್ರಿಪ್ರೇಟ್ರಿ ಸ್ಟಾರ್ಟ್ ಆಗ್ತಿದೆ. ಆ್ಯಕ್ಚುಲಿ ನಾನು ಕೇಳಿರೋದು ಫಸ್ಟ್ PUCದು. ಓಕೆ, ಸೊಲ್ಯೂಷನು ಸಾಲ್ವೆಂಟ್ ಮತ್ತು ಸೊಲ್ಯೂಟ್ ಇರುತ್ತೆ. ಸೊ ಫಸ್ಟ್ ಥಿಂಗ್ ಸೊಲ್ಯೂಷನ್ ವರ್ಡ್ ಯಾವಾಗಾದರೂ ಬಂದರೆ ಅದರಲ್ಲಿ 2 ಥರ ಇರುತ್ತೆ. ಸೊಲ್ಯೂಷನ್ ಆಗೋದೇನೆ 2 ಎಲಿಮೆಂಟ್ಸ್ ಇಂದ. ಯಾವುದಪ್ಪ? ಸಾಲ್ವೆಂಟ್ ಒಂದು, ಸೊಲ್ಯೂಟ್ ಒಂದು. ಕ್ಲಿಯರ್? ಸೊ ಈಗ ಸಾಲ್ವೆಂಟ್ ಯಾವಾಗಲೂ, ಓಕೆ, ಸಾಲ್ವೆಂಟ್ ವಿಲ್ ಆಲ್ವೇಸ್ ಬಿ ಇನ್ ಮೋರ್ ಕ್ವಾಂಟಿಟಿ. Okay, and solute will be always be in a less quantity. Clear? So example ತಗೊಳ್ಳೋಣ. Let us take few examples related to it. So ಯಾವ ಥರ examples ಬರುತ್ತೆ for solute and for solvent? I'll tell you people. Okay, so ಈಗ solute ಮತ್ತು solvent ನಲ್ಲಿ ಯಾವ ಥರ examples ಅನ್ನ ತಗೋಬಹುದು? So if in case you are taking a solvent, so water ಪ್ಲಸ್ ಸಾಲ್ಟ್ ಅಂತ ತಗೊಂಡೆ. ಓಕೆ, ಸೊ ವಾಟರ್ ಪ್ಲಸ್ ಸಾಲ್ಟ್ನಲ್ಲಿ ದಿಸ್ ವಿಲ್ ಆ್ಯಕ್ಟ್ ಲೈಕ್ ಅ ಸಾಲ್ವೆಂಟ್, ದಿಸ್ ವಿಲ್ ಆ್ಯಕ್ಟ್ ಲೈಕ್ ಅ ಸೊಲ್ಯೂಟ್. ಕ್ಲಿಯರ್? ಈಗ ಇದಕ್ಕಿಂತ ಮುಂಚೆ ವಿ ನೀಡ್ ಟು ನೋ ದ ಐಡಿಯಾ ಇರಬೇಕು ನಮಗೆ. ವಾಟ್ ಇಸ್ ದ ಮೀನಿಂಗ್ ಆಫ್ ಎನ್ ಹೋಮೋಜಿನಿಯಸ್ ಅಂಡ್ ವಾಟ್ ಇಸ್ ದ ಮೀನಿಂಗ್ ಆಫ್ ಎನ್ ಹೆಟ್ರೋಜಿನಿಯಸ್? ಕ್ಲಿಯರ್? ಸೊ ಹೋಮೋಜಿನಿಯಸ್ ಅಂದರೆ ಏನಪ್ಪ? ವಾಟ್ ಇಸ್ ದ ಮೀನಿಂಗ್ ಆಫ್ ಎನ್ ಹೋಮೋಜಿನಿಯಸ್? ಸೊ ವಾಟ್ ಎವರ್ ದ ಸೊಲ್ಯೂಷನ್ ಇಸ್ ದೇರ್ ಇನ್ ದ ಹೋಮೋಜಿನಿಯಸ್, ಇಫ್ ಇಟ್ಸ್ ಕಂಪೋಸಿಷನ್ ಇಸ್ ಯೂನಿಫಾರ್ಮ್ ಥ್ರೂ ಔಟ್ ದ ಬಾಡಿ ಆಫ್ ದ ಸೊಲ್ಯೂಷನ್. ಯೂನಿಫಾರ್ಮ್ ಆಗಿರುತ್ತೆ. ಸೊ ಈಗ ನೀರಿನಲ್ಲಿ ಶುಗರ್ ಆಗಿದೆ, ಸಾಲ್ಟ್ ಹಾಕಿದೆ, ಏನಾದರೂ ಹಾಕಿದರೆ ಕಂಪ್ಲೀಟ್ಲಿ ಮಿಕ್ಸ್ ಆಗುತ್ತೆ. ಇಟ್ ವಿಲ್ ಗೆಟ್ ಮಿಕ್ಸ್ಡ್ ಕಂಪ್ಲೀಟ್ಲಿ ಆ್ಯಂಡ್ ವಿಲ್ ಫಾರ್ಮ್ ಅ ಸೊಲ್ಯೂಷನ್. ಥೀಟಾ? ಸೊ ಇಟ್ ವಿಲ್ ಫಾರ್ಮ್ ಅ ಸೊಲ್ಯೂಷನ್. Can you show that slide most important questions? ಯಾವ slide of most important questions appa? Which most important questions are I have done already. You can just go live session go Vedantu Karnataka hogi live session hogi. Live session nalli 100 questions of mathematics, chemistry and biology you will find it. Okay? Yes, it is a universal solvent. Guru Anna hello ನಾನು ಚಿನ್ನಿ. ಓಕೆ, ಚಿನ್ನಿ ಎಲ್ಲರಿಗೂ ನೆನಪು ಮಾಡಿಸ್ತಿದ್ದಾಳೆ. Where did it say ma'am? I'm reading now chemistry. So you didn't get it. Just open Vedantu and then live session ಅಲ್ಲಿ live session ಇರುತ್ತಲ್ಲ ಆಪ್ಷನ್ನು, ಅದರಲ್ಲಿ ಸ್ವಲ್ಪ ಮೇಲ್ ಸ್ಕ್ರೋಲ್ ಮಾಡ್ಕೊಂಡ್ರೆ you will receive the 100 marks questions. Okay, 100 questions ಅನ್ನ ಸಿಗುತ್ತೆ. 100 questions of chemistry, physics, not physics, maths ಮತ್ತೆ biology ಸಿಗುತ್ತೆ. Clear? Okay, now concentrate properly. Homogeneous solution ಅಂದ್ರೆ ಏನು? Solution of a homogeneous if its composition is uniform throughout the body of the solution. So ಯಾವುದ್ರದ್ದು solution ದು composition ಅಕಸ್ಮಾತ್ ಸೇಮ್ ಆಗಿರುತ್ತೆ, composition will not change. Even the solvent will not composition ಸೇಮ್ ಇರುತ್ತೆ, solute ದು composition ಸೇಮ್ ಆಗಿರುತ್ತೆ. ಅವಕ್ಕೆ ಏನು ಕರೀತಾರೆ? homogeneous mixture ಅಂತ ಕರೀತಾರೆ. Clear? Next comes the heterogeneous. Solution in the heterogeneous when 2 or more phases are present in it. 2 or more phases means ಈಗ ನೀರಿನಲ್ಲಿ ಸಾಯಿಲ್ ಹಾಕಿದ್ರೆ, ಯು ಥಿಂಕ್ ಇಟ್ ಲೈಕ್ ನೀರಿನಲ್ಲಿ ನಾವು ಸ್ಯಾಂಡ್ ಪಾರ್ಟಿಕಲ್ಸ್ ಅನ್ನು ಹಾಕಿದ್ವಿ, ಅದರಲ್ಲಿ ಏನಾಗುತ್ತಪ್ಪ? ದೇ ಬೋತ್ ಆರ್ ಇನ್ ಅ ನಾಟ್ ಸೇಮ್ ಫೇಸ್, ದೇ ಬೋತ್ ಆರ್ ನಾಟ್ ಇನ್ ಅ ಸೇಮ್ ಕಂಪೋಸಿಷನ್, ರೈಟ್? ಸೊ ಅವಕ್ಕೆಲ್ಲ ಏನು ಕರೀತಾರೆ? ಹೆಟ್ರೋಜಿನಿಯಸ್ ಮಿಕ್ಸ್ಚರ್ಸ್ ಅಂತ ಕರೀತಾರೆ. ಕ್ಲಿಯರ್? By this session, how much marks you will receive it? From 3 chapters ಮಾಡ್ತಿದ್ದೇನೆ, ಫಿಸಿಕಲ್ ಕೆಮಿಸ್ಟ್ರಿ 1 ಶಾಟ್ ಮಾಡ್ತಿದ್ದೇನೆ ಅಂದರೆ ಫಿಸಿಕಲ್ ಕೆಮಿಸ್ಟ್ರಿ ಎಷ್ಟಿದೆ ಅಲ್ಲ ಅಷ್ಟು ಸಿಗುತ್ತಪ್ಪ. ಓಕೆ, 20 ಮಾರ್ಕ್ಸ್ ತನಕ ಸಿಗ್ಬೋದು. ಡನ್? Okay, homogeneous and heterogeneous solution. The solution is a heterogeneous mixture whenever the two or more phases are going to be present in it. Now everyone are clarified with the solution ನಲ್ಲಿ ಎರಡು ತರ ಇರುತ್ತೆ family. So one baby is solvent, one more baby is solute. So ಇದರಲ್ಲಿ these are the examples which we can take it for the solute. Means ಜಾಸ್ತಿ amount ಇರುತ್ತೆ, ಯಾವಾಗಲೂ solvent ಇರುತ್ತೆ, solute ಯಾವಾಗಲೂ ಕಡಿಮೆ amount ನಲ್ಲಿ ಇರುತ್ತೆ. Clear? Yes, it's enough for the preparatory. It's enough for the preparatory. Next comes the solvation that is also present in your NCERT. Okay, salvation andre enu. So I have not taken it from the NCERT, but you need to have an idea about what is the definition of it. Okay, and then the process of interaction of the solvent molecule with the solute molecule. Okay, so the preparation means there is an interaction. Okay, interaction andre combine. Okay, interaction between the molecules of a solvent and a soluble particles to form aggregates. Whenever the water is a solvent, the process of the solvation is called as an hydration, or it is also called as an equation. Clear? So in case nimge yavagadru iga solvent ಮತ್ತೆ solute ಎರಡು mix ಆಗ್ತಿದೆ. Okay, so whenever solute and solvent will mix together, they both will mix together. ಯಾವಾಗ ಇವೆರಡು ಮಿಕ್ಸ್ ಆಗ್ತಿದೆ ಅಲ್ಲ, when they are actually getting mixed together, ಆವಾಗ ಆ ಟೈಮ್ದಲ್ಲಿ ಏನ್ ಪ್ರೊಸೀಜರ್ ಆಗುತ್ತೆ? what will happen here? Solvation is gonna happen. Clear? And if in case this solvation is actually happening, okay, ಅಕಸ್ಮಾತ್ ಈ solvation hydrogen, that is water ಜೊತೆ ಆಗ್ತಿದೆ with water, then it actually called as what? It's actually called as what? Hydration or equation. Hydration anta karitare. Clear? Hydration anta karitare. So whenever solute and solvent is getting mixed together, that procedure, okay, that procedure ಏನಂತ ಕರೀತಾರೆ? That procedure is actually called as in salvation. ಆ salvation ಅಕಸ್ಮಾತ್ ನೀರಿನ ಜೊತೆ ಆಗ್ತಿದ್ರೆ ಅದೇನಂತ ಕರೀತಾರೆ? Hydration ಅಂತ ಕರೀತಾರೆ. Clear? Ma'am, please go to the black side. Okay, one second. This one, amma. Maths ma'am did not send the practice paper. Okay, I'll inform her to send you the practice paper. Okay, clear? So next, the extent to which the solute dissolves into the solvent to form a homogeneous solution depends on the nature of the solute or a nature of the solvent. Okay, so it's going to depend on what? Nature of a solute, or it's going to depend on the nature of the solvent. Ignore even extent irutte. Okay, there will be a capacity. There will be a capacity happen it. Okay, ಯಾವ ತರ capacity ಅನ್ನೋದು ಇನ್ನೊಂದ್ಸಲ ಹೇಳ್ತೀನಿ ನೋಡಿ. ಎಕ್ಸಾಂಪಲ್ ಅನ್ನ ತಗೊಳ್ಳೋಣ. Okay, example ತಗೊಳ್ಳೋಣ. I have taken 1 liter of water. And I'm mixing it with 2 kg of salt. So is it possible that both the things are going to get mixed? No, that is not possible itself, right? This thing is only not possible. Why it's not possible? Everything has a limit. So there will be a limit that ಎಷ್ಟು solvent ಗೆ ಎಷ್ಟು solute particles dissolve ಆಗುತ್ತೆ. ಅವಕ್ಕೆಲ್ಲ ಏನು ಕರೀತಾರೆ? So that has the capacity, that has a limit. ಈಗ ನಾನು 1 ಲೀಟರ್ ನೀರು ತಗೋತಿದ್ದೇನೆ, 2 kg ಸಾಲ್ಟ್ ಅನ್ನ ಮಿಕ್ಸ್ ಮಾಡ್ತೇನೆ ಅಂದ್ರೆ ಆಗಲ್ಲ. They won't mix together. Okay, they won't mix together. Yes, I will repeat. ನೋಪ ನಿಮ್ಮ ಸಲಾಗೆ ಬಂದಿದ್ದೇನೆ, ರಿಪೀಟ್ ಮಾಡೋದ್ರೊಳಗೆ ಏನಿದೆ? ಸೊ ಇಂಟ್ರಾಕ್ಷನ್ ಬಿಟ್ವೀನ್ ದ ಸಾಲ್ವೆಂಟ್, ಇಲ್ಲಿ ವೆರಿ ಈಸಿ ಇದೆ. ಇಲ್ಲಿ ನೋಡಿ, ಸೊಲ್ಯೂಟ್ ಮತ್ತೆ ಸಾಲ್ವೆಂಟ್ ಒಂದ್ಸಲ ಹೇಳ್ತಿದ್ದೇನೆ, ಇಲ್ಲಿ ಚೆನ್ನಾಗಿ ಕೇಳಿ. ಸೊಲ್ಯೂಟ್ ಮತ್ತೆ ಸಾಲ್ವೆಂಟು ಯಾವಾಗ ಮಿಕ್ಸ್ ಆಗ್ತಿರ್ತಲ್ಲ, ಆ ಪ್ರೊಸೀಜರ್ಗೆ ಸಾಲ್ವೇಷನ್ ಅಂತ ಕರೀತಾರೆ. ಕ್ಲಿಯರ್? ಸೊ ಈಗ ಸಾಲ್ವೇಷನ್ ಅಕಸ್ಮಾತ್ ನೀರಿನ ಜೊತೆ, ಇದು ಪ್ರೊಸೀಜರ್ ಏನಾಗಿದೆ ಅಲ್ಲ, ಸಾಲ್ವೆಂಟ್ ನಲ್ಲಿ ಅಕಸ್ಮಾತ್ ವಾಟರ್ ಅಂತ ಇದ್ರೆ, ಸೊ ಆ ಪ್ರೊಸೀಜರ್ಗೆ ಹೈಡ್ರೇಷನ್ ಇಲ್ಲದ್ರೆ ಎಕ್ವೇಷನ್ ಅಂತ ಕರೀತಾರೆ. ಅಕ್ವಿಯಸ್ ಮೀಡಿಯಂ ಅಂತ ಅಂತಾರಲ್ಲ ನೀವು, ಆ ತರ ಹೈಡ್ರೇಷನ್ ಆರ್ ಎಕ್ವೇಷನ್ ಅಂತ ಕರೀತಾರೆ. ಕ್ಲಿಯರ್? ಡನ್. ಸೊ ಈಗ ಎಕ್ಸಾಂಪಲ್ ಲಿಮಿಟೇಷನ್ ಇರುತ್ತೆ 1 ಲೀಟರ್ ನೀರಿನಲ್ಲಿ 2 kg ಸಾಲ್ಟ್ ಅನ್ನ ಹಾಕ್ಲಿಕ್ಕೆ ಬರಲ್ಲ. ದೇ ಕ್ಯಾಂಟ್ ಆಡ್ ದ 2 kg ಆಫ್ ಸಾಲ್ಟ್ ಇನ್ ದ 1 ಲೀಟರ್ ಆಫ್ ವಾಟರ್. ಇಟ್ಸ್ ನಾಟ್ ಪಾಸಿಬಲ್ ಇಟ್ ಸೆಲ್ಫ್. ಓಕೆ, ಇದು ಪಾಸಿಬಿಲಿಟಿನೇ ಬರಲ್ಲ. ಕ್ಲಿಯರ್? ಸೊ ಅದ್ರ ಸಲುವಾಗಿ ಯಾವಾಗಲೂ ಎದಕ್ಕೂ ಎಲ್ಲದಕ್ಕೂ ಲಿಮಿಟ್ ಇರುತ್ತೆ. ಎವ್ರಿಥಿಂಗ್ ಹ್ಯಾಸ್ ಅ ಲಿಮಿಟ್. ದ ಎಕ್ಸ್ಟೆಂಟ್ of a solute dissolves in a solvent. The extent, the limit of that solute which is dissolving into the solvent, that is going to be called as nature of the solute, and it is going to depend on the nature of the solute. ಈಗ ನಾನು sugar the nature of the solute is different and salt's nature of the solute is going to be completely different, right? So sugar, it will take time to dissolve. Salt will immediately dissolve it. Okay, so ಎರಡಕ್ಕೂ different type of timings ಇರುತ್ತೆ. Clear? So ಅದಕ್ಕೆ ಹೇಳೋದು nature of the solute is very important. Whether that nature is going to be in liquid state, whether it is going to be in a crystal form, or whether it is going to be in a gaseous form. Clear? Next comes the general rule is like to dissolve like the polar solutes are dissoluble in the polar solvents. Example, NaCl in the water means what? Always remember polar. Polar solutes are soluble in polar solvents. Okay, and while the non-polar solutes are going to be soluble in the non-solute are going to be soluble in the non-polar solvents. Clear? So yavagalu homogeneous mixture nalli, every time in the homogeneous mixture you should make sure that polar and polar only will mix together. Clear? Polar and polar only going to mix together, or non-polar and non-polar is going to mix together. Polar and non-polar will not mix together. Clear? So idinna nenepitkodare ellaru? Everyone will remember it. Always remember polar and polar molecules means what? Polar solutes are soluble in the polar solvents. Polar solutes will always be dissolved in the polar solvents. Okay. Not a non-polar and a polar. Clear? So this you will remember, everyone. Right? Polar, or we can take it as non-polar, polar also. Okay. In case or non-polar solute and non-polar solvent. Done. ತಿಳಿತಿದ್ದೇನಾ ಎಲ್ಲರಿಗೂ? Dissolves like alvana. What is alva? What it will dissolve like? It will not dissolve like alva. I didn't understand about the alva. Okay. So non-polar matte non-polar solute. Clear, everyone? Next we'll go for the types of a solution. So everyone are clear now what is a polar, non-polar, how it is homogeneous, heterogeneous and everything, right? So let's go to the types of a solution now. So what is the types of a solution? It's going to depend on the nature of the solute and the solvent of the solutions, and it is going to be classified according to the solute and solvent itself. So yavaglu yavdu solution ಯಾವುದು ಸೊಲ್ಯೂಷನ್ ಪ್ರಿಪೇರ್ ಮಾಡ್ತಿದಾರಲ್ಲ, ಇಟ್ಸ್ ಆಲ್ವೇಸ್ ಡಿಪೆಂಡ್ಸ್ ಆನ್ ದ ಸೊಲ್ಯೂಟ್ ಆಲ್ಸೋ, ಇಟ್ ಡಿಪೆಂಡ್ಸ್ ಆನ್ ದ ಸಾಲ್ವೆಂಟ್ ಆಲ್ಸೋ. ಸೊ ಎರಡದ್ರ ಮೇಲೂ ಡಿಪೆಂಡ್ ಆಗುತ್ತೆ ಯಾವಾಗಲೂ. Clear? So ಈಗ first thing which we should study is about the solid, about the liquid and about the gaseous. So these are the three states of matters which we are going to learn it. According to that, if in case ನೀವು solid ಅನ್ನ ಅಕಸ್ಮಾತ್ ಗ್ಯಾಸ್ ಜೊತೆ ರಿಯಾಕ್ಟ್ ಮಾಡಿದ್ರೆ, ಲಿಕ್ವಿಡ್ ಅನ್ನ ಗ್ಯಾಸ್ ಜೊತೆ ರಿಯಾಕ್ಟ್ ಮಾಡಿದ್ರೆ, ಆಮೇಲೆ ಗ್ಯಾಸ್ ಅನ್ನ ಗ್ಯಾಸ್ ಜೊತೆ ರಿಯಾಕ್ಟ್ ಮಾಡಿದ್ರೆ, ಇಲ್ಲಾಂದ್ರೆ ಸಾಲಿಡ್ ಅನ್ನ ಲಿಕ್ವಿಡ್ ಜೊತೆ, ಲಿಕ್ವಿಡ್ ಅನ್ನ ಲಿಕ್ವಿಡ್ ಜೊತೆ ಏನಪ್ಪ ಎಕ್ಸಾಂಪಲ್ಸ್ ಬರುತ್ತೆ ಮತ್ತೆ ಹೇಗೆ ಅದನ್ನ ಡಿಸಾಲ್ವ್ ಆಗುತ್ತೆ ಅನ್ನೋದು ಫಾಸ್ಟ್ ಆಗಿ ನೋಡ್ಕೊಂಡ್ಬಿಡೋಣ. ಓಕೆ, ಫಾಸ್ಟ್ ಆಗಿ ನೋಡ್ಕೊಂಡ್ಬಿಡೋಣ. ಮ್ಯಾಮ್ ಅಲ್ವಾ ಓಕೆ, ಕನ್ನಡದಲ್ಲಿ ಹೇಳ್ತಿದ್ದೀನಿ ನಮ್ಮ, ನಾನು ಏನೋ ಬೇರೆನೇ ತಿಳ್ಕೊಂಡ್ಬಿಟ್ಟೆ, ಯಾವುದೋ ಏನೋ ಹೇಳ್ತಿದ್ದೆ ಅಂತ. ಸೊ ಸಾಲಿಡ್ ನಲ್ಲಿ ನೋಡಿ ಗ್ಯಾಸಿಯಸ್ ಸೊಲ್ಯೂಷನ್ ನಲ್ಲಿ ಏನಾಗ್ತಿದೆ, ಲಿಕ್ವಿಡ್ ಸೊಲ್ಯೂಷನ್ ಇಲ್ಲಿ ಏನಾಗ್ತಿದೆ, ಮತ್ತೆ ಗ್ಯಾಸಿಯಸ್ ಸೊಲ್ಯೂಷನ್ ಅಲ್ಲಿ ಏನಾಗುತ್ತೆ. ಕ್ಲಿಯರ್? ಸೊ ಫಸ್ಟ್ ಏನು ನೋಡೋಣ, ಫಸ್ಟ್ ವಿ ವಿಲ್ ಲರ್ನ್ ಇಟ್ ಅಬೌಟ್ ದ ಗ್ಯಾಸಿಯಸ್ ಸೊಲ್ಯೂಷನ್. ಸೊ ಗ್ಯಾಸಿಯಸ್ ಸೊಲ್ಯೂಷನ್ ನಿ ಯಾವಾಗ ನಾವು ಸಾಲಿಡ್ ಅನ್ನ ತಗೊಂಡು, ಓಕೆ, ಸೊ ವೆನ್ ಯು ಆರ್ ಗೋಯಿಂಗ್ ಟು ಟೇಕ್ ಅ ಸಾಲಿಡ್, ಸೊ ನಾವು ಯಾವಾಗ ಸಾಲಿಡ್ ಅನ್ನ ತಗೊಂಡು ಸಾಲಿಡ್ ಅನ್ನ ತಗೊಂಡು ಗ್ಯಾಸ್ ಜೋಡಿ ಅಕಸ್ಮಾತ್ ನಾವು ಮೀನ್ಸ್ ಸಾಲ್ವೆಂಟ್ ಆಕ್ಚುಲಿ ಗ್ಯಾಸ್ ಇದೆ, ಜಾಸ್ತಿ ಅಮೌಂಟ್ ಗ್ಯಾಸ್ ಇದೆ, ಸೊಲ್ಯೂಟ್ ಕಡಿಮೆ ಇದೆ. ಕ್ಲಿಯರ್? ಸೊ ಅಯೋಡಿನ್ ವೇಪರ್ಸ್ ಇನ್ ದ ಏರ್, dust or smoke particles in the air. Clear? Next, liquid and gas. So water vapors in the air, humidity is going to form. Clear? Water vapors in the air, gas and gas is air itself, right? Liquid solution alli enagutte, that is solute, that is solid and liquid. It is going to be salt or a sugar in the water. Okay, salt or a sugar in the water, right? So liquid andre water ide, liquid andre illinu water ide, liquid andre illinu water ane ide. Clear? So gas and liquid, liquid and liquid, gas and liquid. Okay, ಈ ಕೇಳಿದ್ರೂ MCQ ನಲ್ಲಿ ಕೇಳ್ತಾರೆ. ಕ್ಲಿಯರ್? ಸೇಮ್ ಅದೇ ತರ ಸಾಲಿಡ್ದು. ಸೊ ಸಾಲಿಡ್ ಇದ್ರೆ ಅಲಾಯ್ಸ್ ಕಾಪರ್ ಡಿಸಾಲ್ವ್ಡ್ ಇನ್ ದ ಗೋಲ್ಡ್. ಎಸ್, ಈಗ ಎಷ್ಟು ಪ್ರಿಪೇರ್ ಮಾಡ್ತಾರಲ್ಲ ಗೋಲ್ಡ್ ಮೀನ್ಸ್ ಗೋಲ್ಡ್ ಪ್ಲೇಟಿಂಗ್ ಇರುತ್ತೆ. ಲೈಕ್ ಎಕ್ಸಾಂಪಲ್ 1 ಗ್ರಾಮ್ ಗೋಲ್ಡ್ ಪ್ಲೇಟಿಂಗ್ ಇದೆ ಈ ಡಿಸೈನ್, ಈ ಜ್ಯುವೆಲ್ಲರಿ ಮೇಲೆ 2 ಗ್ರಾಮ್ಸ್ ಗೋಲ್ಡ್ ಪ್ಲೇಟಿಂಗ್ ಇದೆ. ಸೊ ಇವೆಲ್ಲ ಮಾಡೋದು ಇದರಿಂದ. ಸೊ ದಿಸ್ ಇಸ್ ಆಲ್ಸೋ ಪ್ರೊಸೀಜರ್ ಆಫ್ ಎಲೆಕ್ಟ್ರೋಲೈಸಿಸ್. ಸೊ ಅದನ್ನ ನೆಕ್ಸ್ಟ್ ಚಾಪ್ಟರ್ನಲ್ಲಿ ಕಲಿಯೋಣ. ಓಕೆ, ಲಿಕ್ವಿಡ್ ಸಾಲಿಡ್ Hg in Ag, gas solid solution of a hydrogen in a palladium. Okay, solution of a hydrogen in palladium. Clear? So ivella which is going to be learnt, ivella enantara types of a solution. These are all types of a solution and it's going to completely depend on what type of a solute you are going to add in the solvent. Clear? So ಅಕಸ್ಮಾತ್ ನಾವು solute ಅನ್ನ ಗ್ಯಾಸ್ ಆಗಿ ತಗೊಂಡ್ರೆ solvent ಅನ್ನ ಏನಪ್ಪ ತಗೋಬೇಕು ಮತ್ತೆ ಏನ್ ಆಕ್ಚುಲಿ ಪ್ರಾಡಕ್ಟ್ ಅನ್ನ ಫಾರ್ಮ್ ಆಗುತ್ತೆ. So that is very important. Okay, ತಿಳಿತಾ? Okay, next comes the expressing the concentration of a solution. Now what is the meaning of expressing the concentration of a solution? Naviga solution na kalitidive andmele what is the meaning of a dilute solution and what is the meaning of a concentrated solution anna understand ಮಾಡ್ಕೊಳ್ಳೋಣ. Okay, so dilute solution ಅಂದ್ರೆ ಏನು? The molecules which are there, they are not volatile. Okay, ಬಹಳ ಸ್ಟ್ರಾಂಗ್ ಇಲ್ಲ, volatile ಇಲ್ಲ. ನಾವು ಅದನ್ನ volatileness ನೇನು ಅದರ angriness ತೆಗಿತಿದ್ದೇವೆ. ಲೈಕ್ ಎಕ್ಸಾಂಪಲ್, ನೀವು ಫುಲ್ ಆಂಗ್ರಿ ಇರ್ತೀರ. ಓಕೆ, ನೀವೆಲ್ಲ ಯಾವಾಗಾದ್ರೂ ಒಮ್ಮೆ ಆಂಗ್ರಿ ಇರ್ತಾರಪ್ಪ, ರೈಟ್? ಸೊ ಏನಾದರೂ ಒಂದು ಆಯ್ತಪ್ಪ ಏನೋ ಆಂಗ್ರಿ ಇರ್ತಾರೆ, someone will come to please you. Okay, someone will come to please you like that. Only in dilute solution water will come to please for the solution. Like ಇರ್ಲಿ ತಗೋ ನನ್ನ ಜೊತೆ ಮಿಕ್ಸ್ ಆಗಿಬಿಡು ಅಂತ ಹೇಳುತ್ತೆ. ಸೊ ಅವಾಗ ಎರಡು ಥರದ್ದು ಮಿಕ್ಸಿಂಗ್ ಆಗಿಬಿಟ್ರೆ ಏನಾಗುತ್ತಪ್ಪ? ಡೈಲ್ಯೂಷನ್ ಆಗುತ್ತೆ. ಅವಾಗ ಏನಾಗುತ್ತೆ? ಡೈಲ್ಯೂಷನ್ ಆಗುತ್ತೆ. ಸೊ ಇನ್ನಾದ್ರೂ ಆ ಮನುಷ್ಯ ಯಾವಾಗ ಸಿಟ್ಟಿರ್ತಾನೆ ಮತ್ತೆ ಇನ್ನೊಂದು ಸಿಟ್ ಮಾಡ್ಲಿಕ್ಕೆ ಹೋದ್ರೆ ಅದು ಕಾನ್ಸಂಟ್ರೇಟೆಡ್ ಆಗಿಬಿಡುತ್ತೆ. ಕ್ಲಿಯರ್? ಸೊ ಸಿಂಪಲ್, ದ ಕಾನ್ಸಂಟ್ರೇಷನ್ ಆಫ್ ದ ಸೊಲ್ಯೂಷನ್ ಇಸ್ ಡಿಫೈನ್ಡ್ as the amount of the solute dissolved in the specific amount of a solvent. So amount of a solute which is dissolved in the specific amount of a solvent is actually called as what? Solution. Then solution is containing the relatively less amount of solute and it is actually called as a dilute solution. Trita? So solutions which is containing relatively less amount of a solute and more amount of a solvent will be present. Obviously, right? Now concentration anna kadame ಮಾಡ್ತಿದ್ದೇವೆ, we are diluting it, right? ಅದಕ್ಕೆ ನಾವು solvent ಅನ್ನ ಜಾಸ್ತಿ ಹಾಕ್ತೇವೆ and solute will be in a lesser amount. But opposite is the concentration. Concentration ನಲ್ಲಿ ಏನಾಗುತ್ತೆ? ಕಾನ್ಸಂಟ್ರೇಷನ್ ನಲ್ಲಿ ಸಾಲ್ವೆಂಟ್ ಜಾಸ್ತಿ ಇರುತ್ತೆ, ಸಾಲ್ವೆಂಟ್ ಕಡಿಮೆ ಇರುತ್ತೆ, ಸೊಲ್ಯೂಟ್ ಜಾಸ್ತಿ ಇರುತ್ತೆ. ಓಕೆ, means I should see this session or 100 questions I should study. You should see the one shots first. Okay, see once first to one shots ana kuntodu, one shots ಆದ ತಕ್ಷಣ you go and see the 100 questions. So 100 questions ಓದಿದ್ರು ನೀ ಆರಾಮಾಗಿ ಪಾಸ್ ಆಗ್ಬೋದು. ನೇಮ್ಡ್ ರಿಯಾಕ್ಷನ್ಸ್ ಅನ್ನ ನೋಡು, ಯಾವ ಪ್ರಾಬ್ಲಮ್ಸ್ ಫಿಕ್ಸ್ಡ್ ಇದೆಯಲ್ಲ ಆ ಕ್ವಶನ್ಸ್ ಅನ್ನ ನೋಡು, ಸಾಕು. ಇಷ್ಟು ಮಾಡಿದ್ರೂ ಸಾಕು, ಆರಾಮಾಗಿ ಪಾಸ್ ಆಗ್ತೀಯ. ಪಾಸ್ ಆಗೋದು ಭಾಳ ಈಸಿ ಇದೆ ಗೈಸ್, ಭಾಳ ಈಸಿ ಆಗಿದೆ ಪಾಸ್ ಆಗಿದೆ ಈಗ. ಸೊ ಏನು ಜಾಸ್ತಿ ಮಾಡೋದಿಲ್ಲ, ನೀವು ಪಾಸ್ ಅಷ್ಟೇ ಆಗೋದಿದೆ ಅಂದರೆ ನಾನೇ ಹೇಳ್ತೀನಿ ನಿಮಗೆ ಏನೇನು ಬರುತ್ತಂತ. ಫಸ್ಟ್ ನೀವು ನೇಮ್ಡ್ ರಿಯಾಕ್ಷನ್ಸನ್ನು ಮಾಡ್ಕೊಂಬಿಡಿ ಪರ್ಫೆಕ್ಟು. ಆ ಒಂದು 10 ನೇಮ್ಡ್ ರಿಯಾಕ್ಷನ್ಸಲ್ಲಿ 5 ರಿಂದ 6 ನೇಮ್ಡ್ ರಿಯಾಕ್ಷನ್ಸ್ 100% ಬಿದ್ದೇ ಬೀಳುತ್ತೆ. ಸೊ ಪ್ರಾಬ್ಲಮ್ಸ್ನಲ್ಲಿ ಅಟೆಂಪ್ಟ್ ಮಾಡೋದು ಯಾವುದ್ರ ಮೇಲೆ ಪ್ರಾಬ್ಲಮ್ಸ್ ಬೀಳುತ್ತಂತ ಆಲ್ರೆಡಿ ಗೊತ್ತಿದೆ. ಸೊ ಅದೊಂದು 5 ಪ್ರಾಬ್ಲಮ್ಸನ್ನು ಫಿಕ್ಸ್ ಮಾಡ್ಕೊಂಬಿಡಿ. ಕ್ಲಿಯರ್? ಆಮೇಲೆ ಕೆಮಿಕಲ್ ಕೈನೆಟಿಕ್ಸಿಂದ ಡೆರಿವೇಷನ್ಸನ್ನು ಮಾಡಿಬಿಡಿ. ಒಂದು ಡೆರಿವೇಷನ್ ಅದರಲ್ಲೇ ಬೀಳುತ್ತೆ, ಆರಾಮಾಗಿ ಇಲ್ಲೇ ಪಾಸ್ ಇದ್ರಲ್ಲ. ಸೊ ನಾಟ್ ನೆಸೆಸರಿ ಓನ್ಲಿ ಆನ್ ಎನಿಥಿಂಗ್ ಎಲ್ಸ್ ಟು ಗೋ ಆ್ಯಂಡ್ ಡಿಪೆಂಡ್, ರೈಟ್? ಸೊ ಪಾಸಿಂಗ್ ಈಸ್ ವೆರಿ ಈಸಿ. ಪಾಸಿಂಗ್ ದ ಯೋಚನೆ ಮಾಡಬೇಡಿ, how to score you think about it. So passing will be like what? We have lots of fixed questions which are going to come. ಅವನಷ್ಟು ಓದಿದ್ರು ನೀವು ಆರಾಮಾಗಿ ಪಾಸ್ ಆಗ್ಬೋದು, ಏನು ಟೆನ್ಷನ್ ತೊಗೊಳೋದು ನೆಸೆಸಿಟಿನೇ ಇಲ್ಲ. ಓಕೆ, Solutions containing relatively less amount of solute are called as dilute solutions, and if it contains relatively more amount of solute, then that is going to be concentrated solution. Clear? That will be what? Concentrated solution. Clear everyone? What is concentrated solution and this solution? I will write it here if you want. Concentrated solution and dilute solution. So, ಇಲ್ಲಿ concentration solution ಅಲ್ಲಿ solute will be more, solvent will be less. Here solute will be less, solvent will be more. This much if you remember, then enough. Okay. Second PUC check. Okay. Done. Now you should be remembering about the name, symbol, formula, definition and effect of temperature. Okay. One by one, nicely we will learn this thing, but it will take time. But whichever necessity is there, that I will explain it properly. Idralli ella important illa. Everything is not important that much here. So we will learn it everything in detail. Okay. First one is percentage by mass. Okay. First one in barattappa. Percentage in mass. Percentage by mass. So what you learn in the percentage by mass? In kalitiya percentage by mass nalli. So always remember the formula will be what? Mass of the solute divided by total mass of a solution. Mass of the solute. Okay. Mass of the solute divided by total mass of the solution. Obviously percentage ide andre into 100 hege maritarappa? We need to know the into 100, no? Right? So ಈಗ ಅಕಸ್ಮಾತ್ ಆಗಿ ಯಾವುದು ಒಂದು ಕಾಂಪೌಂಡ್ ತಗೊಂಡ್ವಿ. Okay, let us take one simple example here. One simple example ತಗೊಳ್ಳೋಣ ಇಲ್ಲಿ. So example, that is water plus sugar. Okay, water we have taken it in the 1 liter. Done. Sugar we have taken it 10 grams. Clear? So again baribodu mass of the solute ಏನು ಬರುತ್ತೆ? Mass of the solute, this is going to be what? Solvent. ಇದೇನಾಗುತ್ತೆ? Solute ಆಗುತ್ತೆ. Clear? ಈಗ solute ಅನ್ನೋದು total ಎಷ್ಟು ಹೇಳಿದ್ದಾರೆ? 100. 10 divided by 1 liter is actually equal to 1000 milli, or else you can take it as you can take it as 1 liter itself into 100. That's it. Understood? Yav solvent to yav solute anta nodkobeku. That's it. Ma'am, you finish how much lesson in this session? I will be finishing 3 lessons amma. Physical chemistry and yav 3 lessons ide amma. Solution, electrochemistry ಮತ್ತೆ chemical kinetics 3 chapters ಅನ್ನ ಈ ಲೆಸನ್ ಈ ಸೆಷನ್ ಅಲ್ಲಿ ಮುಗಿಸ್ತೇನೆ. ಆಯ್ತಾ ಶಶಿ? Okay. So clear everyone? So this is actually called as what? Percentage by mass. Done. So definition ಬರುತ್ತೆ amount of a solute in grams. Amount of a solute in grams present in 100 gram of a solution. Present in 100 gram of a solution. Clear? So ಈ ತರ ನೀವು ಇದನ್ನ ಎಕ್ಸಾಂಪಲ್ ಅನ್ನ ತಗೋಬಹುದು. So ಏನನ್ನ definition ಬರ್ಕೋಬಹುದು? What definition you can write it down? That is amount of solute in grams dissolved in 1 liter ತಗೋಬಹುದು actually, but we will take it as 100 gram of solution of solution. Clear? 100 gram of solution. Okay. So this is not going to depend on the temperature. So this will not depend on the temperature. Clear? So this is not going to depend on the temperature. Done? Understood everyone? What is the meaning of this? Ma'am, D and F block and coordination compounds when, ma'am? I have already done the D and F and coordination compounds, Amma. Next comes the volume percentage. Volume percentage, everything will be same itself. But how we have taken the gram there, we are going to take here as a volume. ಏನಪ್ಪ ತಗೋತೇವೆ ಇಲ್ಲಿ? Volume ತರ ತಗೋಬೇಕು. Clear? Volume percentage is actually equal to what? Mass of solute in ml divided by total mass of solution in ml into 100. Clear? So in definition, what we can write it as a definition here for this. ಏನನ್ನ definition ಆಗಿ ಬರಿಬಹುದು? What will be the definition for this? That is amount of mass of solute in ml dissolved in 100 ml of solution is actually called as a volume percentage. ಏನಂತ ಕರೀತಾರೆ ಅದಕ್ಕೆ? Volume percentage ಅಂತ ಕರೀತಾರೆ. Yes, everything is there in the live session itself. Everything is there in the live session itself. So ಒಂದು idea ಮಾಡಿ ನೀವು, you do one thing everyone. So you go and watch the one puller ಮಾಡಿದ್ದೇನೆ, means one video I have done it in the videos. So ಅದರಲ್ಲೆಲ್ಲ ಮೆನ್ಷನ್ ಮಾಡಿದ್ದೇನೆ ನಾನು 100 ಕ್ವಶನ್ಸ್ ಮೀನ್ಸ್ ನಿಮ್ಮ ಪ್ರಿಪ್ರೇಷನ್ಗೆ ಏನೇನು ಹೆಲ್ಪ್ ಆಗಬೇಕಲ್ಲ ಅವನ್ನೆಲ್ಲ ಮೆನ್ಷನ್ ಮಾಡಿದ್ದೇನೆ. ನೀವು ಹೋಗಿ ನೋಡ್ಬೋದು ಅದನ್ನು. ಫಸ್ಟ್ ಅದನ್ನು ನೋಡಿ ಆಮೇಲೆ ನಿಮಗೆಲ್ಲ ಸಿಗುತ್ತೆ ಎಲ್ಲೆಲ್ಲ ಅಂತ. ಓಕೆ, ಎಲ್ಲ ಇರೋದು ಲೈವ್ ಸೆಷನ್ನಲ್ಲಿ ಮತ್ತು ವಿಡಿಯೋ ಸೆಷನ್ನಲ್ಲಿ. ಜಸ್ಟ್ ಯು ನೀಡ್ ಟು ಚೆಕ್ ಇಟ್. ಆಲ್ರೆಡಿ ಪ್ಲೇ ಲಿಸ್ಟ್ಸ್ ಆರ್ ದೇರ್. So you can go and check in the playlist also. Separately for the preparatory only one playlist is there. So ಯಾವ ನೋಡ್ಕೋಬೇಕು, ಏನೇನು ಓದ್ಕೋಬೇಕು ಪ್ರಿಪರೇಟರಿಗೆ ಅದನ್ನೆಲ್ಲ ಇದೆ. ಓಕೆ, next comes mass by volume percentage. Clear? Next comes what? Mass by volume percentage. Clear? Mass by volume percentage. The next one, mass by volume percentage. One second, guys. Next in mass by volume percentage. So in mass by volume percentage, what you are going to practice? So mass by volume percentage nalli enagutte? Same ella, everything will be same. So everything will be same. That is mass of the solute and then the total volume of the solution. Yes, volume of the solution. Volume andre enu? Liquid. Volume andre enu? Liquid. Clear? That is going to be the mass by volume percentage. Mass of solute divided by total volume of solution into 100. Clear? Into 100. Understanding? ತಿಳಿತಿದೆನಾ? So what comes here definition? Amount of a solute in grams, amount of a solute in grams which is dissolved in 100 ml, amount of a solute in grams. In bharat definition, amount of solute in grams dissolved in volume alla adike ml tagotidene. Okay, in ml, this is also in ml itself. Okay, this is in grams. Actually grams should not be written like this, grams. Okay, 100 ml dissolved in the 100 ml of solution. Tirita, that is called as an mass by volume percentage. Clear? Mass by volume percentage. Done? Done everyone? Yes. Next very important concept is going to come, that is molarity. We are going to learn about the molarity and then about the molality, then mole fraction and then parts per minute. Okay? So, idhan concepts understand madkondre arda solution understand madkondange. Okay? Third one atla, fourth one. Molarity. Okay, so what is actually meaning of an molarity? Niಮಗೆ ಗೊತ್ತಾ ಯಾರಿಗೂ? ಫಾಸ್ಟ್ ಆಗಿ ಹೇಳಿ ನೋಡೋಣ. What is meaning of an molarity? Molarity ಅಂದ್ರೆ ಏನಪ್ಪ? Molarity is actually called as what? Previous slide, it is a volume, not mass. ಎಲ್ಲಿ ಕೊಟ್ಟಮ್ಮ ವಾಲ್ಯೂಮು? Okay, yes, this is not mass, this is volume. That's correct. Very good. ಇಲ್ಲಿ ml ಬರ್ದಿದ್ದೇನಲ್ಲ ಸಾಕು, ನೀವೇ ಚೇಂಜಸ್ ಮಾಡ್ಕೋಬಹುದು. ಓಕೆ, ಡನ್. ತಿಳಿತಾ? ಓಕೆ, ಸಾರಿ. So molarity andre eno? What is the meaning of an molarity? So molarity is actually called as an mass of a solute. Means yadrada mass tagondideve, how much actually the moles of that solute is. Moles of a solute ಎಷ್ಟಪ್ಪ ಇದೆ? We need to find the moles of a solute. Okay, we need to find the moles of a solute while solving the problem. Solution chapter nalli ee questions molarity ಮತ್ತೆ molality ಮೇಲೆ one question ಬೀಳುತ್ತೆ. So that time you need to find the moles of a solute and volume of the solution in the liter. Volume of the solution in the liter. Volume of the solution in a liter. Clear everyone? In liter. Done? Theta? Yes. Next now what is going to come? How you can define it? Very easy to define this also. Very easy to define. So in baribodappa definition itirdu. How you can write the definition? Amount of moles of solute dissolved in, moles of solute which is dissolved in solution in liters. Okay, ಈ ತರನು ಬರ್ಕೋಬಹುದು. ತಿಳಿತಾ? Next comes the molality ಆಯ್ತಲ್ಲ, ಮೊಲಾರಿಟಿನೇ ಆಯ್ತಾನ ಈಗ? ಮೊಲಾಲಿಟಿ ಆಗಿದೆ. Molality, what is the meaning of an molality now? What is a meaning of an molarity? Yes, what is this? Unit is going to be that only. Correct, Amma. Very good. Done? moles of a solute divided by mass of a solvent in kg. Clear? So how can you define this thing now? How can you define this thing? Amount of moles of solute or number of moles of solute antanu tagobodu. Okay, we can take it as number of moles of solute dissolved in 1 kg of solution is called as molality. Done. So now very easy to remember. One thing you should remember here is, see, molality yavaglu idre solid anta nenepitkolli. Okay, and whenever the molarity is there, think it has a liquid. Okay, like this will be in the kg, it will be in the liter. Done? Understood? Very good, Kushal. Very good. Shashi, very good, Shashi. Yes. Mole per kg. Yes. Mole per kg. Very good. Okay, clear? So next comes parts per million. Yalgidvapa, 5th, 6th, ppm. That is also called as an parts per million. Clear? So that is also called as an parts per million. That is also called as an parts per million. So what is the meaning of an parts per million now? So whatever the mass or a volume of the solute you are going to take, okay? Whatever mass or a volume of the solute, that is going to be mass of solute or solvent, okay, mass of, wait, mass or volume of solute divided by mass or volume of solution into 10 raised to 6. So main thing is only here 10 raised to 6. So ये 10 raised to 6 is actually called as what? Million. ಅದಕ್ಕೆ parts per million ಅಂತ ಹೇಳ್ತಾರೆ. So what it is actually called as? Parts per million ಅಂತ ಹೇಳ್ತಾರೆ. Clear everyone? Parts per million. Done. Now last thing we are going to learn, that is mole fraction. Last thing which we are going to learn, that is going to be the mole fraction. Okay, mole fraction is also called as an X. It is also indicated in the form of what? It is also indicated in the form of XA. Okay, it's actually called as what? XA. Clear? XA. ನೀವು ಈಗ ಲಾಸ್ಟ್ ಮೂಮೆಂಟಿಗೆ ಬಂದು ಮ್ಯಾಮ್ ನಾನು ಇದನ್ನ ಮಾಡಿದ್ರೆ ಸಾಕಾ, ಮ್ಯಾಮ್ ನಾ ಅದನ್ನ ಮಾಡಿದ್ರೆ ಸಾಕಾ, ಹಿಂಗೆ ಕೇಳ್ಕೊತ ಕೂತ್ರೆ ನೀವು ಏನಾಗುತ್ತಪ್ಪ? ಸೊ ಅದಕ್ಕೆ ಹೇಳಿದ್ದಲ್ಲ ನಾನು, ಕನ್ಸಿಸ್ಟೆನ್ಸಿ ಮೇಂಟೈನ್ ಮಾಡ್ರಪ್ಪ. ಕನ್ಸಿಸ್ಟೆನ್ಸಿ ಮೇಂಟೈನ್ ಮಾಡಿದ್ರಿ ಅಂದ್ರೆ ಓದ್ಲಿಕ್ಕಾಗುತ್ತಂತ. ನಾವು ಅಟ್ ದ ಲಾಸ್ಟ್ ಮೂಮೆಂಟ್ ಯು ಆರ್ ಕಮಿಂಗ್ ಆ್ಯಂಡ್ ಯು ಪೀಪಲ್ ಆರ್ ಆಸ್ಕಿಂಗ್ ಮೀ ಲೈಕ್ ಮ್ಯಾಮ್ ಇಷ್ಟು ಮಾಡಿದ್ರೆ ಸಾಕಾ, ಅಷ್ಟು ಮಾಡಿದ್ರೆ ಸಾಕಾ. ಪಾಸ್ ಆಗೋದಿದ್ರೆ ಎಲ್ಲರೂ ಪಾಸ್ ಆಗ್ತಾರಪ್ಪ. ಪಾಸಿಂಗ್ ಇಸ್ ವೆರಿ ಈಸಿ, ನಾಟ್ ಅನ್ ಇಶ್ಯೂ ಆಫ್ ಪಾಸಿಂಗ್. ಓಕೆ, ಪಾಸಿಂಗ್ ಇಸ್ ನಾಟ್ ಅ ಪ್ರಾಬ್ಲಮ್, ಯು ಕ್ಯಾನ್ ಈಸಿಲಿ ಪಾಸ್. ಓಕೆ, ಈಸಿಲಿ ಪಾಸ್. ನಾನು ಆಲ್ರೆಡಿ ಹೇಳಿದೆ ಹೆಂಗೆ ಪಾಸ್ ಆಗ್ಬೋದು ಈಸಿ ಅನ್ನೋದು. ನಾನು ಹೇಳಿದೆ ಆಲ್ರೆಡಿ ಹೇಗೆ ಈಸಿಲಿ ಪಾಸ್ ಆಗ್ಬೋದು ಅನ್ನೋದು. ಸೊ ಏನು ಬರುತ್ತೆ ಡೆಫಿನೇಷನು? ರೇಷಿಯೋ ಆಫ್ moles of solute to the total solution of a component or a compound we can take. Clear? Done everyone? Understood? Not Vinay, we are not going to finish all the chapters in one shot. So already you complete, I have done already complete organic and complete inorganic also. So today is a complete physical chemistry, okay? Trita. So hope so you people are hitting the like button. If you have not, please hit it and mark up your attendance, okay? Next comes Henry's law. So on Henry's law, short one question you are going to receive it. Short one question you are going to receive it from the Henry's law. It's fixed, okay? It's going to be fixed question from the Henry's law. That is 2 marks. Okay, 2 marks bidde bidutte Henry's constant mele akasmat alli kelilla andre 1 marks gantu kele keltare. Okay, so 1 marks gantu kele keltare. Clear? So what is the meaning of an Henry's law? According to the Henry's law, the mass of the gas is dissolved in per unit volume of the solvent. Okay, mass of the gas. So hegagade mass of the gas which is present, that is dissolved in the per unit volume of the solvent. Solvent nalli gas anna dissolve madidare, means what? Obviously the gas is acting like a solute there. Okay, at a given temperature is proportional to the pressure of the gas in the equilibrium with the solution. Pressure of the gas in the equilibrium with the solution. Understand? Try to understand here. ಏನು actually ಹೇಳ್ತಿದ್ದಾರೆ ಅವರು? Mass of the gas ಇದೆ. Okay. Mass of the gas ಏನಿದೆ ಅಲ್ಲ, this gas which is present, ಇದನ್ನ ಎದ್ರಲ್ಲಿ ಹಾಕಿದ್ದಾರೆ? Where they have added this mass of the gas, it's actually dissolved in the solvent. ಎದ್ರಲ್ಲಿ dissolve ಆಗಿದೆ ಅದು? Solvent. ಈಗ ಎದ್ರಿಂದ actually mass of the gas is getting dissolved into the solvent? ಹೇಗೆ actually dissolve ಆಗಿದೆ? By a pressure. By applying a pressure. Obviously pressure ಇರಲಿಲ್ಲ ಅಂದ್ರೆ ಹೇಗೆ ಡಿಸಾಲ್ವ್ ಆಗುತ್ತೆ, ರೈಟ್? ಯಾವುದು ಗ್ಯಾಸ್ ಮಾಲಿಕ್ಯೂಲ್ ಲಿಕ್ವಿಡ್ ನಲ್ಲಿ ಡಿಸಾಲ್ವ್ ಮಾಡು, ಸಾಲಿಡ್ ನಲ್ಲಿ ಡಿಸಾಲ್ವ್ ಮಾಡು, ಎದ್ರಲ್ಲೂ ಬೇಕಾದಲ್ಲಿ ಡಿಸಾಲ್ವ್ ಮಾಡು. ಆ ಡಿಸಾಲ್ವ್ ಮಾಡೋ ಸಮಯದಲ್ಲಿ ಪ್ರೆಷರ್ ಅಪ್ಲೈ ಮಾಡಲೇಬೇಕು, right? According to the temperature and pressure only it's going to happen. That's what, in a given temperature and pressure, in a given temperature and a pressure is directly proportional to the, okay, is proportional to the pressure of the gas in the equilibrium with the solution. At a given temperature is directly proportional to the pressure. That is actually called as what? In the given equation. Like example, m is directly proportional to p. M is directly proportional to p. Clear? That proportionality constant you can take it as what? Kh. So this is actually called as a proportionality constant. Done. So where Kh is going to be the proportionality constant, which is actually called as an Henry's constant also. So adike enantanu karibodu, that is also called as an Henry's law constant antanu karibodu. And Kh is going to depend on the nature of the gas. Kh is completely depend on the nature of the gas. Yes. So yav tara nature of the gas, actually we are applying the pressure and yav gas. ಯಾವ ತರ ಗ್ಯಾಸ್ ಅನ್ನ ಪ್ರೆಷರ್ ಅಪ್ಲೈ ಮಾಡಿ ನಾವು ಡಿಸಾಲ್ವ್ ಮಾಡ್ತಿದ್ದೇವೆ, ಅದು ಬಹಳ ಇಂಪಾರ್ಟೆಂಟ್. ಯಾವ್ದು ಬೇಕಾದ ಗ್ಯಾಸ್ ತಗೊಂಡು ಪ್ರೆಷರ್ ಅಪ್ಲೈ ಮಾಡ್ಲಿಕ್ಕೆ ಬರಲ್ಲ. ಎಲ್ಲ ಗ್ಯಾಸ್, ಎವ್ರಿ ಡಿಫ್ರೆಂಟ್ ಗ್ಯಾಸ್ ಹ್ಯಾಸ್ ಅ ಡಿಫ್ರೆಂಟ್ ಪ್ರೆಷರ್ಸ್. ಓಕೆ, ಎವ್ರಿ ಗ್ಯಾಸ್ ಹ್ಯಾಸ್ ಅ ಡಿಫ್ರೆಂಟ್ ಪ್ರೆಷರ್ ಅಂಡ್ ದೇ ವಿಲ್ ಬಿ ಡೂಯಿಂಗ್ ಇಟ್ ಅಕಾರ್ಡಿಂಗ್ ಟು ದಟ್. ಕ್ಲಿಯರ್? Next, nature of the solvent and temperature and a unit of the pressure. Done. Next comes for a mixture of a gaseous in equilibrium with the liquid. The solubility of any gas is experienced in the terms of a mole fraction. Solubility of any gas. Okay. Yavudradu solubility irli. Yavudradu solubility irli. It's going to depend on. Depends on what? Mole fraction. So just now we studied about the mole fraction. Mole fraction is equal to Na divided by Na plus Nb, right? Ma'am, can we take solubility? What is solubility, ma'am? Ma'am, we can take solubility. Yes, you can take solubility. Why can't you take? Solubility of any gas expressed in the terms of what? Mole fraction in the solution. Directly it's proportional to the partial pressure. It's directly proportional to what? Partial pressure. That's what I said you. Right? So partial pressure, partial pressure is actually equal to the KH, that is Henry's constant, into the mole fraction. So it's every time it's going to depend on the solubility, and that is going to depend on the mole fraction. Solubility is actually going to depend on the mole fraction. Easy to understand? Easy to understand, right? Yes, that is actually called as a Raoult's law. Okay, Raoult's law and Henry's law ಎರಡರ ಮೇಲೆ 100% one question ಕೇಳೇ ಕೇಳ್ತಾರೆ. So make sure you people will be practicing them. Okay, Raoult's law ಮತ್ತೆ Henry's law ಎರಡು questions ಒಂದು ಯಾವ್ದಾದ್ರು question ಕೇಳೇ ಕೇಳ್ತಾರೆ. So but you need to be perfect with that. Okay, ಎರಡರ ಮೇಲೆ ಒಂದು question ಬೀಳುತ್ತೆ. Done. Yes. So next we'll start with the vapor pressure of a liquid solution. Vapor pressure of a liquid solution. ಈಗ vapor pressure of a liquid solution ಹೇಗಾಗುತ್ತೆ? Liquid solution ನಲ್ಲಿ ಹೇಗೆ ನಾವು vapors ಅನ್ನು ಯೂಸ್ ಮಾಡಿ ಪ್ರೆಷರೈಸ್ ಮಾಡ್ತೇವೆ. And one more thing you should understand here. Okay, ಯಾವಾಗಲೂ ಯಾವುದು ಅಂತ ತಗೊಳ್ಳಿ. Okay, ಯಾವುದು ಲಿಕ್ವಿಡ್ ತಗೊಳ್ಳಿ, ಸಾಲಿಡ್ ತಗೊಳ್ಳಿ, ನೀವು ಅಕಸ್ಮಾತ್ ಗ್ಯಾಸ್ ಅನ್ನ ಅದರಲ್ಲಿ ನೀವು ಡಿಸಾಲ್ವ್ ಮಾಡ್ತಿದ್ರೆ, ಇಫ್ ಯು ಆರ್ ಡಿಸಾಲ್ವಿಂಗ್ ದ ಗ್ಯಾಸ್ ಇನ್ಸೈಡ್ ಇಟ್, ಓಕೆ, ಏನು ಮಾಡ್ಬೇಕು ನಾವು? ವಿ ನೀಡ್ ಟು ಅಪ್ಲೈ ಅ ಪ್ರೆಷರ್. ಸಿಂಪಲ್ ಎಕ್ಸಾಂಪಲ್ ಡೈಲಿ ಲೈಫ್ನಲ್ಲಿ ಹೇಳ್ತೇನೆ. ಚಾರ್ಕೋಲ್ ಬಿರಿಯಾನಿ ಅಂತ ಕೇಳಬೇಕು ನೀವು. ನನಗೆ ಗೊತ್ತಿಲ್ಲ ಎಷ್ಟು ಮಂದಿ ಬಿರಿಯಾನಿ ತಿಂತೀರಾ, ಬಟ್ ಬಿರಿಯಾನಿನಲ್ಲಿ ಚಾರ್ಕೋಲ್ ಸ್ಮೆಲ್ ಬರುತ್ತಲ್ಲ ಅಂತ ಬಿರಿಯಾನಿಯನ್ನು ಮಾಡ್ತಾರೆ, ದಮ್ ಮಾಡ್ತಾರೆ, ಬಿರಿಯಾನಿ ದಮ್. ಓಕೆ, ಇಫ್ ಎನಿವನ್ ಇಸ್ ಈಟಿಂಗ್ ನಾನ್ ವೆಜ್ ದೇ ವಿಲ್ ಗೆಟ್ ಟು ನೋ. ಸೊ ಇಲ್ಲಿ ಏನು ಮಾಡ್ತಾರೆ ಗೊತ್ತಾ, ಚಾರ್ಕೋಲ್ಸ್ ಅನ್ನ ತೆಳಗಡೆ ಹಾಕ್ತಾರೆ, ಬೋಗಾನಿ ತೆಳಗಡೆ. ಓಕೆ, ಅದ್ರ ಮೇಲೆ ಒಂದು vessel ಇಡ್ತಾರೆ. They'll keep the vessel and they'll apply a pressure on that vessel so that that charcoal smell which is there, it will reach to the biryani. Okay, a charcoal smell ಏನಿದೆಯಲ್ಲ, it will go and reach to the biryani. That is very important, right? So ಅದರಲ್ಲಿ ಏನಾಗ್ತಾರೆ, gas is getting dissolved into the solid. ಗ್ಯಾಸ್ ಅನ್ನ ನಾವು ಪ್ರೆಷರ್ ಕೊಟ್ಟು ಡಿಸಾಲ್ವ್ ಮಾಡ್ತಿದ್ದೇವೆ ಸಾಲಿಡ್ ನಲ್ಲಿ. ಡಿಸಾಲ್ವ್ ಅಂದ್ರೆ ಏನು? ದ ಸ್ಮೆಲ್ ಇಸ್ ಕಮಿಂಗ್. ನಾವು ಯಾವಾಗ ತಿಂತೇವಲ್ಲ ಚಾರ್ಕೋಲ್ ಸ್ಮೆಲ್ ಬರಬೇಕಲ್ಲ, ದಟ್ ಇಸ್ ಆಕ್ಚುಲಿ ಕಾಲ್ಡ್ ಆಸ್ ಅ ಚಾರ್ಕೋಲ್ ಬಿರಿಯಾನಿ, ರೈಟ್? ಅಂದ್ರೆ ಚಾರ್ಕೋಲ್ ಸ್ಮೆಲ್ ಬರಬೇಕು. ಕ್ಲಿಯರ್? ಅಕಸ್ಮಾತ್ ಯಾರಾದರೂ ನಾನ್ ವೆಜ್ ತಿಂತಿದ್ರೆ ದೇ ವಿಲ್ ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್ ದಿಸ್ ಕಾನ್ಸೆಪ್ಟ್ ವೆರಿ ವೆಲ್. ಓಕೆ, ಸೊ ನಾವೀಗ ವೆಜ್ದವ್ರಿಗೆ ಏನು ಎಕ್ಸಾಂಪಲ್ ಸಿಕ್ಕದಾಗ ಹೇಳ್ತೇನೆ. ಓಕೆ, ವೆನ್ ಐ ವಿಲ್ ಗೆಟ್ ದ ಎಕ್ಸಾಂಪಲ್ ಐ ವಿಲ್ ಟೆಲ್ ದಟ್ ಟೈಮ್. ಓಕೆ, now vapor pressure of a liquid solution ನಲ್ಲಿ that we are going to learn about the Raoult's law first here. Raoult's law na kaliyona. What is the meaning of an Raoult's law? Now Raoult's law states that for a solution of a volatile liquid, okay, for a solution of an volatile liquid, what is the meaning of an volatile liquid? ಯಾವುದು ಫುಲ್ ಆಂಗ್ರಿ ಆಗಿರುತ್ತೆ, ಇಟ್ ವಿಲ್ ಬಿ ಆಲ್ವೇಸ್ ಬಿ ಇನ್ ಆಂಗ್ರಿ ಮೋಡ್. ವಾಲಟೈಲ್ ಅಂದರೆ ಯಾವಾಗಲೂ ಇಟ್ ವಿಲ್ ಬಿ ಲಿಟಲ್ ಬಿಟ್ ಕಾನ್ಸಂಟ್ರೇಟೆಡ್, ದ ಮಾಲಿಕ್ಯೂಲ್ಸ್ ವಿಲ್ ಬಿ ಆಲ್ವೇಸ್ ಬಿ ಇನ್ excited mood to go and react with anyone. Okay, so volatile liquids, the partial vapor pressure of the each component of the solution is directly proportional to the mole fraction of the present in the solution. That's what just now I said. That is actually called as what? That's actually called as Raoult's law. Okay, where it went? Done. ಇಲ್ಲಿದೆ ಅಲ್ಲ, clear everyone? Okay. Now this is the definition which you should remember. Okay, ಇದು ಡೆಫಿನೇಷನ್ಗೆ 2 ಮಾರ್ಕ್ಸ್ ಕೇಳ್ತಾರೆ. I will discuss the questions also, what type of questions will be asked from this chapter. Don't worry. Okay, that is P1 is actually equal to P1 naught into 1 and P2 into P naught and 2. Means what? If in case they have taken a 2 components. If in case we have taken a 2 components. 2 components ತಗೊಂಡ್ರೆ it is very simple. P1 is actually equal to if in case we have taken component number 1 and component number 2. Then component number 1 and component number 2. If in case we have taken 1, that is going to be what? XA1 ಅಂತನೂ ತಗೋಬಹುದು, or X1 ಏನು ತಗೋತಾರಲ್ಲ. 1 second guess. Yes, X1A ಅಂತ ಮೀನ್ಸ್ ಯಾವ ಕಂಪೌಂಡ್ ಜೊತೆ ನಾವು ಆಕ್ಚುಲಿ ರಿಯಾಕ್ಟ್ ಮಾಡ್ತೀವಿ ಅದನ್ನು ಬರ್ಕೋಬಹುದು. Then here P2 is equal to KH, that is Henry's constant, X2. Clear? ಈ ಥರನೂ ಬರ್ಕೋಬಹುದು, ಕಂಪೋನೆಂಟ್ 1, ಕಂಪೋನೆಂಟ್ 2. ಹಿಂದಿನಲ್ಲಿ ಕಲಿಸ್ಬೇಕಾ? ಅಯ್ಯೋ, ಯಾವ್ಯಾವ ಲ್ಯಾಂಗ್ವೇಜ್ನಲ್ಲಿ ಕಲಿಸೋದಪ್ಪ ಈಗ? ಓಕೆ, ಡನ್. ನಾವು pressure of the pure component 1 and respectively at the same temperature. So both the things are going to be in the same temperature itself. Here do you have temperature? Both the things, okay? Both the things are going to be in a same temperature. Both the things are going to be in a same temperature. Both the things will be in the same temperature. Clear? Done? Tilita, largo. Okay, so according to the Dalton's law of partial pressure, partial pressure, so P1 plus P2 is actually equal to X1 P1 naught plus X2 P naught 2. So that will be 1 minus, means just we are going to take a common there, 1 minus X1 P1 naught and plus X2 P2 naught. That will be what? P1 and I that is P2 naught minus P1 naught and X2. Okay. If in case Y1 and Y2 are the mole fraction of the components of 1 and 2 respectively in the vapor phase, then it will be P1 is equal to Y1 P total and P2 Y total. Whatever mole fraction we are going to take. If in case we have considered as Y, we will consider as a Y. X kana consider markondre X anna age markobodu. Clear? ಕನ್ನಡವನ್ನು ತಿಳಿಯಲ್ಲ ಓಕೆ ಕ್ಲಿಯರ್ ಎವ್ರಿವನ್ ಹೇಗೆ ತಗೋಬೋದು ಅಂತ ಎಲ್ಲರಿಗೂ ಗೊತ್ತಾ ಹೌ ಟು ಟೇಕ್ ಅಕಾರ್ಡಿಂಗ್ ಟು ದ ಡಾಲ್ಟನ್ಸ್ ಲಾ ಪಾರ್ಷಿಯಲ್ ಪ್ರೆಷರ್ ಅನ್ನು ಹೇಗೆ ತಗೊಳ್ಳೋದು P total is equal to P1 plus P2 that is also X1 P1 naught plus X2 P naught 2 ಓಕೆ ಆಗ ಈಗ ಕಾಮನ್ ತಗೊಳ್ಳೋದು 1 ಮೈನಸ್ X2 ಅನ್ನ ಕಾಮನ್ ತಗೊಂಡ್ವಿ ಅದರಲ್ಲಿಂದ ಪ್ಲಸ್ X2 P2 ನಾಟ್ ಇದು ಹೇಗಿದೆ ಹಂಗೆ ಉಳಿಯುತ್ತೆ ಕ್ಲಿಯರ್ ದಟ್ ವಿಲ್ ಬಿ ವಾಟ್ P1 ನಾಟ್ P1 into P1 naught plus P1 into this is actually going to be this. Means they have skipped one step here, but no problem. I will teach you. I'm here to teach you. P total is actually equal to P1 plus P2. Done. Illadre ille barad bidona. So P1 plus P2 tagondidare. Okay. How they have taken it? Okay, it's okay. I'll write it down here. So in P1 plus P2 anna plus ಮಾಡಬೇಕು P1 is equal to what? KH X1 ಇದೆ ಅಲ್ಲ KH X1 is actually also called as, it is also called as X1 P1 naught. Okay. Clear? Then afterwards, this both the things they have taken it as a common, that is 1 minus X. 1 minus X2 is actually equal to P1 naught. It is actually equal to P1 naught plus X2 P2 naught. Done. So, P1 naught is equal to P1 naught plus into minus minus P1 naught X2 plus X2 P2 naught. So, what is the common thing in both the things it is present? It is going to be present as a X2 on a common togolona, we will take it as P1 naught, X2 on a common togolona, then we will write it as what? P1 naught plus P2 naught. Done? Tilita? Tilita largo? Okay. Next thing is Raoult's law has a special case of Henry's law. So we are going to learn about the Raoult's law special case. That is, according to the Raoult's law of vapor pressure of the volume volatile component in a given solution is proportional to its mole fraction of the solution that we know. That is P1 is equal to P1 naught minus X1 anta gottide namage. But now, according to the Henry's law in the solution of a gas, liquids, the partial pressure of the volatile component is proportional to its mole fraction of the solution. Right? So this is actually, P1 is actually the mole fraction of the solution according to the Henry's law. According to the Henry's law. according to the Henry's law ನಮಗೆ ಗೊತ್ತಿದೆ P1 is directly proportional to x1 ಅಂತ, right? ಈಗ from equation 1 and 2 it has been obvious that Raoult's law is a special case of a Henry's law in which the KH becomes equal to P1 naught. Okay, KH will actually become the equal of P1 naught. Okay, ಅದರ ಸಲುವಾಗಿನೇ ಇಲ್ಲಿ P1 naught, this actually I have taken it for that purpose itself. So ಇಲ್ಲಿ ಏನು ತಗೊಂಡಿದ್ದೇನಲ್ಲ, this both the things what I have taken it, no, this both the things which are there, this both the things which are I have taken it, it's actually KH only. Okay, because this is actually equal to this P1 naught and P2 naught, P1 naught and P2 naught is actually equal to the Henry's and Raoult's law. Clear? It's actually equal to the Henry's and the Raoult's law. Done? ತಿಳಿತಿದೆನಾ? Theta. So that is what we have actually getting discussed. Done. Now, this is clear everyone. Raoult's law according to the special case of Henry's law. How the Raoult's law and Henry's law both are going to be get related. ಹೇಗೆ Raoult's law ಮತ್ತೆ Henry's law ಎರಡು relate ಇದೆ. How they both are actually a best friends we got to know. Next concept comes the vapor pressure of a solution of a solids in liquid. So then after that we will be learning about the Raoult's law for the solution of a non-volatile solute, and then Raoult's law for the solution of a non-volatile solute when it is in a negative form. Okay, when it is in a negative form, then we will study about the ideal and non-ideal solution. Okay, let's be fast. Okay, vapor pressure of a solution of a solid in liquid. Vapor pressure of a solution in a solid in liquid. Okay, solid in the liquid nalli enaguttappa. So vapor pressure of the solution of a non-volatile solute is lower than the pure liquid, that is solvent. For that purpose PS is actually less than the P naught. Okay, this is actually called as what? Lowering. It is actually called as what? Lowering of vapor pressure. So vapor pressure enidella, whatever the vapor pressure is there of the solution is actually in a non-volatile solute nalli ide. Non-volatile vapor pressure which is actually in the non-volatile solute. Done. So that is lower than that of the pure liquid. It's actually lower than that of the pure liquid, that is also called as a solvent. Then for that purpose only PS is actually less than the P naught. PS enidella, it is actually less than the P naught. Clear? Yes, I know Hindi appa. I know Hindi. I know all the languages still. But we can't teach you people in Hindi. Okay, we can't teach you people in the Hindi. So we can't teach you in Hindi. It's a Vedantu Karnataka channel, so I will be teaching it in the Kannada and English. Okay, so delta P is actually equal to P naught minus PS. Means what? PS andre ಏನಪ್ಪಾ solid. Actually it's called as a solid. Clear? So ಯಾವಾಗ vapor pressure ಏನಿದೆಲ್ಲ that will be minus the solid because we are dissolving the gas into the solid, right? Done. Next, so vapor delta P is actually considered the lowering of the vapor pressure. P naught is vapor pressure of the pure liquid, that is also called as an solvent. Okay, that is also called as an solvent. And PS is equal to vapor pressure of a solution. Vapor pressure of a solution, that is solvent plus solute. Then so cause is what? That in the pure liquid the entire surface is occupied by a molecules of a liquid itself. Okay, in a pure liquid the entire surface is actually occupied by the molecules of a liquid. So rate of the evaporation will be proportional to the number of the molecules present in the upper surface, right? So whatever the rate is there, okay, whatever the rate of the evaporation will be, it will be proportional to the number of the molecules which are present at the layer of the liquid. First layer nilli, that liquid nalli ಮೇಲ್ಗಡೆ ಯಾವ ಲೇಯರ್ ಇದೆ ಅಲ್ಲ ಆ ಲೇಯರ್ ಮೇಲೆನೆ ಡಿಪೆಂಡ್ ಆಗೋದು ಎಷ್ಟಪ್ಪ ಸಾಲಿಡ್ ಪಾರ್ಟಿಕಲ್ಸ್ ಇದೆ, ಎಷ್ಟು ಡಿಸಾಲ್ವ್ ಆಗುತ್ತೆ, ಎಷ್ಟು ಇವಾಪರೇಟ್ ಆಗುತ್ತೆ. Clear? That is what? Everything. Okay, ಯಾವುದು solution ಇರಲಿ surface ಮೇಲೆನೆ ಡಿಪೆಂಡ್ ಆಗೋದು when it is getting converted into the gaseous form. Clear? Upper surface itself. Now whenever the whenever a non-volatile solute is being added to a solvent, okay, in case pure liquid nalli ತಿಳಿಯಿತು, in case ನಾವು pure liquid nalli ಯಾವಾಗಲೂ in liquid always remember it depends on the surface of the molecule. ಎಷ್ಟಪ್ಪ surface area ಇದೆ ಅದರ ಮೇಲೆ ಡಿಪೆಂಡ್ ಆಗುತ್ತೆ. how much amount of a number of molecules are actually present in the upper surface of the pure liquid. So ಈಗ ಅಕಸ್ಮಾತಾಗಿ ನಾನ್ volatile solute ಇದ್ರೆ if in case we are adding a solvent to the surface of the molecule, okay, ಏನು ಮಾಡ್ತಿದ್ದೇವೆ ನಾವು, we are adding a solvent to the surface of the molecule of a solute and solute of and solvent both, thus the number of the molecules of a solvent is present in the upper surface is going to be less. Clear? So the number of the molecules of the solvent ಏನಿದೆಯಲ್ಲ present in the upper surface is going to be less in the non-volatile solute. Non-volatile solute ನಲ್ಲಿ ಕಡಿಮೆ ಇರುತ್ತೆ and it will be more in the this. It will be more in this. Clear? Done? Next, the number of the solvent molecule escaping from the surface is being reduced and thus the vapor pressure also starts decreasing. So how the number of the solvent molecules escape from the surface is going to reduce, that time the vapor pressure of that also is going to decrease. ಆಮೇಲೆ ಡಿಕ್ರೀಸ್ ಹಾಕೊಂತ ಹೋಗುತ್ತೆ ಯಾವಾಗ number of the solvent particles surface ಮೇಲೆ ಏನು ಕಡಿಮೆ ಹಾಕೊಂತ ಹೋಗುತ್ತಲ್ಲ ಅದರ ಪ್ರಕಾರನೇ vapor pressure is also going to start decreasing. Vapor pressure decrease ಆಕೊಂತ ಹೋಗುತ್ತೆ. Clear? Next, the decrease in the vapor pressure of the solvent is going to depend on, okay, decrease in the pressure of the solvent is going to depend on the quantity of the non-volatile solute. ಎಷ್ಟು solute ಅನ್ನು ನಾವು non-volatile solute ಅನ್ನು add ಮಾಡ್ತಿದ್ದೇವೆ, ಎಷ್ಟು amount of non-volatile solute ನಾವು ಅದರಲ್ಲಿ add ಮಾಡ್ತಿದ್ದೇವೆ ಅದರ ಮೇಲೇನು ಡಿಪೆಂಡ್ ಆಗುತ್ತೆ, ಅದರ ಮೇಲೇನು surface area ಡಿಪೆಂಡ್ ಆಗುತ್ತೆ, right? On that only surface area is going to depend, right? So that is in respective of the nature except when the association and dissociation of the solute is taking place. So for that purpose, whenever, okay, decrease in the vapor pressure of the 1 mole of a solution of a sucrose and urea in water are same at the same temperature. Is same at the same temperature. Clear? Done? ತಿಳಿತಾ ಇಲ್ಲಿ ತನಕ ಎಲ್ಲರಿಗೂ? Next comes the Raoult's law for the solution of a non-volatile solute. Okay, Raoult's law of non-volatile solute. So ಇಲ್ಲಿ ಏನಾಗುತ್ತೆ non-volatile solute ನಲ್ಲಿ Raoult's law states that for any solution the partial vapor pressure of each volatile component in the solution is directly proportional to its mole fraction. Okay, Raoult's law states that any solution the partial pressure, okay, whatever the partial pressure is there, that is also called as, where it went, partial pressure. Yes. So whatever the partial vapor pressure of the each volatile component is there in the solution is directly proportional to the mole fraction. Partial pressure which is there is directly proportional to the mole fraction. In a solution of a non-volatile solute, the total vapor pressure of a solution is only due to the vapor pressure of the solvent. Yes, it's actually going to depend only on the vapor pressure of a solvent. Vapor pressure of the solvent ಮೇಲೆ ಅಷ್ಟೇ ಡಿಪೆಂಡ್ ಆಗೋದು ಎಲ್ಲಿ non-volatile solute ನಲ್ಲಿ. Clear? Non-volatile solute ನಲ್ಲಿ vapor pressure of the solvent ಮೇಲೆ ಅಷ್ಟೇ ಡಿಪೆಂಡ್ ಆಗೋದು. ಎಷ್ಟು ಆಗುತ್ತಪ್ಪ, ಓಕೆ, solvent ಎಷ್ಟು dissolve ಆಗುತ್ತೆ, it will get converted to the vapors, ಎಷ್ಟು ಆಗುತ್ತೆ ಅದರ ಮೇಲೆ ಡಿಪೆಂಡ್ ಆಗುತ್ತೆ. Clear? Next, that purpose only, that is what I told you PS, that is also partial pressure is directly proportional to x1, or PS actually is also called as x1 into P0. Clear? So where PS is actually going to act like vapor pressure of the solution and P0 is going to act like vapor pressure of a pure solvent. So x1 is going to be the mole fraction of a solvent in the solution. x1 is actually going to be a mole fraction of a solvent in solution. Done? Next comes the Raoult's law for the solution of a non-volatile solute. Raoult's law for the solution of a non-volatile solute. Clear? Non-volatile solute. Solution is little bit no, too much only big it is chapter. Okay, Raoult's law states that for any solution, the partial vapor pressure of the each volatile component in the solution is directly proportional to it. One second, guys. Directly proportional to its mole fraction. So, in a solution of a non-volatile solute, the total vapor pressure of the solution is only due to the vapor pressure of the solvent. This is everyone are clear, right? So, iga adar prakarane, let us check the graph. Let us check the graph according to that. On the graph also one MCQ is fixed. Okay, MCQ on the graph of this is completely fixed. One the question bidde bidate MCQ do. Clear? So graph mele. So make sure you're going to, if anything you're going to find anywhere the MCQ of the graph, then you need to make sure you're going to attempt it. Clear? Illodi, mole fraction of the X1 and vapor pressure of the solution of a PS. So this is vapor pressure of a pure solvent. How it's going to become? If mole fraction increase account hodre, vapor pressure of the pure solvent is also going to increase, right? So solvent ana increase ಮಾಡ್ಕೊಂತ ಹೋದ್ರೆ pressure ಅನ್ನು increase ಮಾಡ್ಕೊಂತ ಹೋಗಬೇಕಾಗುತ್ತೆ. Obviously, solvent increase ಆದ್ರೆ pressure ಅನ್ನು increase ಆಗುತ್ತೆ. Clear? So because of that, vapor pressure of a solution, that is PS, is directly proportional to X1, or PS is actually directly equal to X1 plus P0. Clear? So where PS is a vapor pressure of a solution, P0 is a vapor pressure of a pure solvent, and X1 is mole fraction of a solvent in the solution. So this is how the graph is gonna be forming. Clear? Raoult's law for solution of a non-volatile solute. Now we have one more concept here that we will discuss it while studying the questions. Okay, questions maadu time medalli na discuss madona adna. Yen gotta Raoult's law alli negative deviation ondirutte, positive deviation anta ondirutte. That we will discuss it when I will be studying. We will be learning about the questions. Questions maadu time dalli learn madukolona. Clear? Then next we'll learn about the ideal and non-ideal solution. Ideal and non-ideal solution. So in ideal solution, intermolecular interaction between the component of a solution are same as that of the in between the pure component. Clear? In a non-ideal solution, intermolecular interaction between the component of a solution, one not same as that of between the pure component. About the pure component. Clear? So delta mix is going to be 0 here. Here delta mix is not equal to 0 in the non-ideal solution. Why? Because there is a no change in the volume. There is a no change in the volume. No mixing is going to happen. So there is a no change in the volume on the mixing. Clear? So delta H mixer is going to be 0 and there is no change in the enthalpy of a mixing. Here it is going to be completely opposite, that there is a change in the volume on the mixing. So obviously it will change the volume. Andre obviously delta H is mixture in agtidella, that is going to be different, right? Different agutalla. Next comes the colligative properties of determination of a molar mass. Colligative properties of a determination of a molar mass. That is, colligative properties means what? The properties of the solution which is going to depend only on the number of the solute. It's going to depend only on what? Number of the solute particles, but number of the solute particles, but on the nature of the solute are actually called as an colligative properties. So number of the solute particles ಮೇಲೆ depend ಆಗುತ್ತೆ, the properties of a solution which is going to depend on the number of the solute particles. Okay, colligative properties ಅಂದ್ರೆ ಏನಪ್ಪಾ ಅಂದ್ರೆ so what is meaning of colligative properties is, it is going to depend on the It's going to depend on the number of, solute particles, but not on the number of solute particles but not on the nature of it, okay? But not on the nature of the solute. Done. Colligative properties andre enu? It's going to depend on the number of the solute particles. ಎಷ್ಟು number moles of number ಎಷ್ಟು ತಗೊಂಡಿದ್ದೇವೆ ನಾವು solute particles ಅದರ ಮೇಲೆ ಡಿಪೆಂಡ್ ಆಗುತ್ತೆ ಯಾವ ನೇಚರ್ ಇದೆ, whether it is solid, liquid, gas, ಯಾವುದು ನೇಚರ್ ಅಲ್ಲಿ ಅದರ ಮೇಲೆ ಡಿಪೆಂಡ್ ಆಗಲ್ಲ. So that is actually called as an colligative properties. Clear? ಅದಕ್ಕೆ ಏನು ಕರೀತಾರೆ? Colligative properties ಅಂತ ಕರೀತಾರೆ. Right? Now 4 important colligative properties are present. First one is real. Okay, one second guys. Okay, we'll discuss relative lowering of vapor pressure here. Okay, that is whenever the non-volatile solute is being added to the solvent. Okay, whenever the non-volatile solute is being added to the solvent. Okay, whenever non-volatile solute is being added to the solvent, the vapor pressure of the solution is going to decrease. Clear? So vapor pressure of the it is going to decrease. Relative nalli enagutte? What's going to happen in the relative lowering vapor pressure? RLVP nalli enaguttappa illi? Whenever in a non-volatile solute, if we have added ಏನನ್ನ ಆಡ್ ಮಾಡ್ತಿದ್ದೇವೆ? Okay, so in a non-volatile solute, added solvent, the vapor pressure ಏನಾಗುತ್ತಪ್ಪ? Decrease ಆಗುತ್ತೆ. What will it will become? It will start decreasing. Clear? It will start decreasing. ತಿಳಿತಾ? It will start decreasing. Clear everyone? Vapor pressure will start decreasing. Then after that, for that purpose, P naught A is going to be the vapor pressure of the pure solvent. PA will be the vapor pressure of the solution. So for that purpose, delta PA, that is lowering of vapor pressure. ಹೇಗೆ ತಗೋಬಹುದು ಅದರಿಂದ ನಾವು? Lowering of vapor pressure. How can we take the lowering of vapor pressure here? That is delta PA is actually equal to delta PA. Okay, one second guys. Okay, I should write it here, no? Okay. ಏನಾಗುತ್ತೆ ಅದರ ಸಲುವಾಗಿ? Lowering of vapor pressure is actually equal to delta PA is actually equal to P naught A minus PA. Done. P naught A minus PA. Clear? ತಿಳಿತಿದೆನಾ ಎಲ್ಲರಿಗೂ? P naught A minus PA, right? Now, because of that, PA is going to, PA is actually equal to, according to Raoult's law, PA is actually equal to what? P naught A XA, right? We know already that. We already know that P naught A, P naught A is actually equal to XK. Right, according to the Raoult's law. So, according to the Raoult's law, P naught A is actually equal to XA, right? Now, we are finding the lowering of the vapor pressure, right? So, if in case delta PA is actually equal to P naught A, PA value gottaytu namage. We understood the PA value now. We know already we have a PA value now. Just substitute it, guys. We should substitute it in this. That is delta PA is actually equal to P naught A minus PA value is what? Into XA. Clear? Done? Yes, where here XA is actually mole fraction of a solvent, right? What is XA here? XA is mole fraction of a solvent. Done. So now how we are going to do it? Now just we will separate it. Okay, in common what is actually common in this? That is P naught A is actually common in it, right? So P naught A and a constant separate madona. Okay, we will separate the P naught A. Delta PA is equal to P naught A. We will separate in both the things. XA agate. Am I correct? We have taken the common here. 1 minus XA agate, right? 1 minus XA is actually equal to what? XB, right? It's actually 1 minus XA andre enagate. 1 minus XA andre enagate. It's actually XB, right? 1 minus XA is actually XB. So just substitute this thing. Idana substitute madona. Clear? So once we substitute this thing here, that is delta PA is equal to P naught A. This is actually called as an XB. Done. This is how you are going to get the reaction. Clear? Clear, everyone? Derivation barate amma electrochemistry chapter mele derivation barate. Derivation on first order, 0 order, half order, second order. Adar mele short one derivation barate. Okay, one derivation is short, you are going to receive it. First order, second order, half order mele one derivation barate. We will discuss that also. Okay, clear everyone? With relative lowering vapor pressure, that is also called as an RLVP. Next comes the elevation in boiling point. So what is happening in the elevation of boiling point? The boiling point of a liquid is a temperature at which the vapor pressure becomes equal to the atmospheric pressure. Clear? So boiling point of a liquid in the temperature. Boiling point of the liquid is actually called as what? Temperature. It's actually a temperature, that is boiling point of liquid temperature at which the vapor pressure is going to become. Okay, our temperature mele vapor pressure is actually becoming equal to the atmospheric pressure. Mele depend agide. Clear? Atmospheric pressure mele depend agide by the addition of a non-volatile solute. Non-volatile solute, vapor pressure is going to start decreasing. So, ಏನಾಗುತ್ತಿಲ್ಲಿ actually elevation in boiling point ನಲ್ಲಿ elevation in boiling point ನಲ್ಲಿ ಏನಾಗುತ್ತಪ್ಪ, in this what is gonna happen now? Elevation in the boiling point ನಲ್ಲಿ ಏನಾಗುತ್ತೆ, first what you are going to do, boiling point of a liquid is a temperature at which, okay, okay, at a temperature where you are going to add a vapor pressure at which the vapor pressure becomes equal to, in this, clear? After that we are going to do the addition, okay, we are going to add what? At equal temperature, addition of a non-volatile solute, addition of an non-volatile solute, what will happen here? Vapor pressure is going to decrease. It's going to decrease. Clear? ಏನಾಗುತ್ತೆ vapor pressure ಗೆ? Hello, hi Shashik, Jyotik. Who are you? Oh my God. Vapor pressure is going to decrease. Clear? Vapor pressure is going to decrease. Now this decrease in vapor pressure is going to increase its boiling point. So it's going to increase its boiling point. So ಈ vapor pressure ಏನು decrease ಆಗಿದೆಯಲ್ಲ, ಇದರಿಂದ there will be a increase in boiling point. There will be a increase in the boiling point. Clear? Okay, all are human only. I was only not knowing it. Clear everyone? Boiling point. Thus the addition of a non-volatile solute in the boiling point is going to increase. Clear? So ನೀವು ಯಾವಾಗ addition, if you are adding a non-volatile solute, if you are adding any here I'll write. If you are adding non-volatile solute in a solution, boiling point is going to increase. Boiling point is going to increase. Clear everyone? Okay, this is not gonna fit here, so I will draw this. Okay, done. Largo. Hi Jyoti, hi Shashi. Whom your people are telling hi? I don't know. Understood everyone? Clear with this? Next we are going to, if in case delta TB is going to be the boiling point of a pure solvent, if in case delta TB is going to be the boiling point of a pure solvent and delta B will be the boiling point of a solution, then the elevation in boiling point is going to be what? Delta TB, that will be TB minus delta T naught. Okay? What you want to say? Simply hiing. ಯಾರಿಗಪ್ಪ hi ಮಾಡ್ತಿದ್ದೀರಾ? Whom you people are telling hi and bye. Whom you people are telling hi and bye. Delta naught B is actually equal to what? Boiling point of a pure solvent. Done. So delta TB naught is going to be what? Boiling point of, it's actually going to be the boiling point of pure solvent. Done. And delta TB is actually the boiling point of solution. Done everyone, boiling point of a solution. Then what happens with the elevation? That is delta TB enagutte. What will happen with the delta TB? Delta TB is actually equal to delta TB. It's visible, no, properly? Yes. Delta TB is actually equal to TB minus T naught B. Done. TB minus T naught B. Am I correct? Am I correct? Delta TB is equal to minus delta naught B, right? It has been found that delta TB is actually directly proportional to M. So that is molarity of the solution mele depend agutte. Okay, what is that? Delta TB is actually directly proportional to M. Done. That is also called as an molality. Molality mele depend agutte molality of the solution mele. Okay. So delta TB is directly proportional to M, then delta TB is actually equal to what? KBM, right? It's going to be what? KBM. Am I correct? KBM agutte, right? Then afterwards KB into 1000, KB into 1000, what will be that value? So we know already, that is delta TB is actually equal to what? Delta TB is actually equal to KBM, right? According to what? According to the molar elevation constant. According to the molar elevation constant. So adar salvagi KB into 1000 into W it will be, right? Divided by, it will be divided by W into M. Tilita? So here W is going to be the weight of the solute. Small w is going to act like a weight of the solute. Then, and capital W is going to be considered as what? Capital W is going to be what? Weight of the solvent. Weight of solvent in grams, or you can take it in the gram or a kg. Clear? So now we'll take it as in the form of a grams. Clear? So M will be what? Molar mass of the solute. Okay? M will be then what is left? KB is left. That is molar elevation point. Shrita, done. So for that purpose, KB will be related to the enthalpy. If in case if it's related to the enthalpy of vaporization, it will be KB is equal to M RT TB naught and delta H vapor into 100. Where R is going to consider as a gas constant. R in consider markobodu, gas constant consider markobodu, M we are going to consider as molar mass of the solvent. Enanta consider markobodu, molar mass of the solvent. Done. Parikshit channel is oh sorry, how can you people tell this? Okay Jyoti, if you're feeling it that better, then you can go and watch the classes there, no problem. Yes, 2 lessons are there. Yes Shashi, we need to be very fast, no? Trita Largo, done. Next comes depression in the freezing point. Okay, depression in freezing point is very easy. Depression in freezing point is very easy. That is, freezing point of a substance is dissolved, defined as a temperature at which the vapor pressure vapor pressure of its liquid is going to be equal to the vapor pressure of the corresponding solid. Vapor pressure of the corresponding solid. Clear? So for that purpose, depression in freezing point, whatever the depression in the freezing point is decreasing in the freezing point. So whenever akasmat ನಾವು non-volatile solute na ತಗೊಂಡಿದ್ದೇವೆ, okay, non-volatile solute na ತಗೊಂಡಿದ್ದೇವೆ, that non-volatile solute is going to be added in the solvent. ಯಾವಾಗ ನಾವು solute ಅನ್ನು solvent ನಲ್ಲಿ add ಮಾಡ್ತೇವೆ, that addition of a non-volatile, okay, that is addition of a non-volatile solute will lowers the vapor pressure of the solvent. Vapor pressure of the solvent will ಕಡಿಮೆ ಆಕೊಂತ ಹೋಗುತ್ತೆ. It will lower. We have already learned this, right? ಕಡಿಮೆ ಮಾಡ್ಕೊಂತ ಹೋಗುತ್ತೆ. When we are going to add a non-volatile solute into the solution, ಥೀಟಾ non-volatile solute ಅನ್ನು solution ಅಲ್ಲಿ ಹಾಕಿದ ತಕ್ಷಣ ಅದು lower ಮಾಡ್ಕೊಂತ ಹೋಗುತ್ತೆ. Okay, lower ಮಾಡ್ಕೊಂತ ಹೋಗುತ್ತೆ. Hence the solid forms the separate out at the lower temperature. This is how it's going to happen. Okay, so ನೀವು ಯಾವಾಗ ಅಕಸ್ಮಾತಾಗಿ if you people are adding up the solid here, okay, solid solvent ಇದು, so ಆಮೇಲೆ liquid solvent theta, so how temperature according to the temperature, first TF is there, okay, ಏನಾಗುತ್ತೆ solid solvent ಅನ್ನು ಹಾಕಿದ ತಕ್ಷಣ ಈ ತರ ಆಗುತ್ತೆ vapor pressure, right? Solid solvent ಅನ್ನು ಹಾಕಿದ ತಕ್ಷಣ vapor pressure will increase and then it will start decreasing, and then it will start decreasing. Clear? Clear? Next comes in freezing point of a solvent, that is also called as a delta naught F, that is also called as a delta naught F, and freezing point of a solution is going to be the TF, delta naught of F, and freezing point is going to be the solution of TF, solution of a TF. So delta naught same ಇದೆ ತರ ನಾವು ಹೇಗೀಗ ಪ್ರೆಷರ್ ಫೈಂಡ್ ಮಾಡಿದ್ವಿ ಅಲ್ಲ, ಸೇಮ್ ಅದೇ ತರ ಫ್ರೀಸಿಂಗ್ ಪಾಯಿಂಟ್ ಫೈಂಡ್ ಮಾಡಬೇಕು. ಕ್ಲಿಯರ್? ಫ್ರೀಸಿಂಗ್ ಪಾಯಿಂಟ್ ಇದು ಸೇಮ್ ಅದೇ ತರ ನೀವು ಫೈಂಡ್ ಮಾಡಬೇಕು. ಸೊ ಐ ವಿಲ್ ನಾಟ್ ರಿಪೀಟ್ ಇಟ್ ಅಗೇನ್. ಫ್ರೀಸಿಂಗ್ ಪಾಯಿಂಟ್ ಇದು ನಾನು ರಿಪೀಟ್ ಮಾಡಲ್ಲ ಅಗೇನು. Clear? Freezing points I will not repeat it again. Clear? ತಿಳಿತಿದೆನಾ? No amma, derivations are not important. Derivations are not important. If they, in case they will ask also, no, ಏನು ಕೇಳ್ತಾರೆ ಗೊತ್ತಾ, ಜಾಸ್ತಿ ಆದ್ರೂ ಕೇಳಿದ್ರೂ ಸೊ ಜಾಸ್ತಿ ಆಗಿ ಕೇಳಿದ್ರೂ ಹೇಗೆ ಕೇಳ್ತಾರೆ, ನ್ಯೂಮರಿಕಲ್ ಪ್ರಾಬ್ಲಮ್ಸ್ ಹೇಳ್ತೇನಮ್ಮ, ನಾವು ವಿಲ್ ಡಿಸ್ಕಸ್ ನ್ಯೂಮರಿಕಲ್ ಪ್ರಾಬ್ಲಮ್ಸ್ ಅನ್ನೋನು. ಸೊ ಕ್ವಶನ್ ಕೇಳಿದ್ರೂ ಯಾವ ಥರ ಕೇಳ್ತಾರೆ ಗೊತ್ತಾ, yes, please tell the define the colligative properties and determine, they will tell important colligative properties ಅನ್ನ explain ಮಾಡಿ ಅಂತ ಹೇಳ್ತಾರೆ. ಓಕೆ, ಸೊ ಆವಾಗ ನೀವು relative pressure, elevation in boiling point, then you people can take depression in freezing point, then afterwards you can take it as ಓಕೆ ದ್ಯಾಟ್ ಮಚ್ ಓನ್ಲಿ 4 ಇದೆ. ಸೊ 4 ಎಕ್ಸ್ಪ್ಲೇನ್ ಮಾಡ್ಕೋಬಹುದು. ಕ್ಲಿಯರ್? ಸೊ ಈಗ ಹೇಗೆ ಪ್ರೆಷರ್ ಫೈಂಡ್ ಮಾಡಿದ್ವಿಲ್ಲ, ಫ್ರೀಸಿಂಗ್ ಪಾಯಿಂಟ್ ಇದನ್ನು ಸೇಮೇ ಆಗುತ್ತೆ. ಐ ವೋಂಟ್ ರಿಪೀಟ್ ಇಟ್ ಒನ್ಸ್ ಅಗೇನ್. ಸೊ ಫ್ರೀಸಿಂಗ್ ಪಾಯಿಂಟು ಮತ್ತು ಪ್ರೆಷರ್ ಸೇಮ್ ಇರುತ್ತೆ, ಜಸ್ಟ್ ಫ್ರೀಸಿಂಗ್ ಪಾಯಿಂಟ್ ಅಂತ ಹಾಕಿ ಅಲ್ಲಿ ಇದನ್ನಂತ ಹಾಕಿ. ಕ್ಲಿಯರಾ? ಸೊ ಲೆಟ್ಸ್ ಗೋ ಟು ದ ವೆರಿ ಇಂಪಾರ್ಟೆಂಟ್ ಕಾನ್ಸೆಪ್ಟ್, ಫಿಕ್ಸ್ಡ್ ಕ್ವಶನ್ ಫ್ರಮ್ ಆಸ್ಮೋಸಿಸ್. ಇನ್ ಸೊಲ್ಯೂಷನ್ ಚಾಪ್ಟರ್ನಲ್ಲಿ ಆಸ್ಮೋಸಿಸ್ ಆ್ಯಂಡ್ ಆಸ್ಮಾಟಿಕ್ ಪ್ರೆಷರ್ ಮೇಲೆ ಒಂದು ಫಿಕ್ಸ್ಡ್ 2 ಮಾರ್ಕ್ಸ್ ಕ್ವಶನ್ ಇರುತ್ತೆ. ದಟ್ ಇಸ್ ಡಿಫೈನ್ ಆಸ್ಮಾಟಿಕ್ ಪ್ರೆಷರ್. ದೇ ವಿಲ್ ಟೆಲ್ ಯು ಪೀಪಲ್, ದೇ ವಿಲ್ ಆಸ್ಕ್ ದ ಕ್ವಶನ್ ಇನ್ ದಿಸ್ ವೇ ಇಟ್ ಸೆಲ್ಫ್. ಸೊ ನಾನು ಒಂದು ಶಾರ್ಟು ಮಾಡಿದ್ದೆ, you might have seen my shorts in the Vedantu Karnataka, important questions from the solution chapter. So I important questions from the solution chapter ನಲ್ಲಿ you might have seen it, ನೀವು ನೋಡಿರಬೇಕಲ್ಲಿ. ಆಸ್ಮಾಟಿಕ್ ಪ್ರೆಷರ್ ಒಂದು ಕ್ವಶನ್ ಇದೆ, ಮೀನ್ಸ್ 2 ಮಾರ್ಕ್ಸ್ ಶಾರ್ಟ್ ಆಗಿ 1 ಮಾರ್ಕ್ಸ್ ಕೇಳ್ತಾರೆ, ಇಲ್ಲ 2 ಮಾರ್ಕ್ಸ್ ಗಂತೂ ಶಾರ್ಟ್ ಆಗಿ ಕೇಳ್ತಾರೆ. 1 ಮಾರ್ಕ್ಸ್ ಕೇಳಿದ್ರೆ ಯಾವಾಗ ಕೇಳ್ತಾರೆ ಅಂದ್ರೆ 5 ಮಾರ್ಕ್ಸ್ ನಲ್ಲಿ 1 ಮಾರ್ಕ್ಸ್ ನ ಇನ್ಕ್ಲೂಡ್ ಮಾಡ್ಕೋಬಹುದು, ಬಟ್ 5 ಮಾರ್ಕ್ಸ್ ನಲ್ಲಿ ಯೂಶುವಲಿ ಸೊಲ್ಯೂಷನ್ ಚಾಪ್ಟರ್ ಕೇಳಲ್ಲ. ವೈ? ಬಿಕಾಸ್ ದೇ ವಿಲ್ ಆಸ್ಕ್ ದ ಪ್ರಾಬ್ಲಮ್ಸ್, ಫಿಸಿಕಲ್ ಕೆಮಿಸ್ಟ್ರಿ ದ ಪ್ರಾಬ್ಲಮ್ಸ್ ಕೇಳ್ತಾರಲ್ಲ. ಸೊ ಟು ಬ್ಯಾಲೆನ್ಸ್ ಇಟ್ ಔಟ್ 5 ಮಾರ್ಕ್ಸ್ ನಲ್ಲಿ ಕೇಳಿದ್ರೆ ಜಾಸ್ತಿ ಇನ್ಆರ್ಗ್ಯಾನಿಕ್ ಮತ್ತೆ ಆರ್ಗ್ಯಾನಿಕ್ ಕೇಳ್ತಾರೆ. ಕ್ಲಿಯರ್? ಇನ್ಆರ್ಗ್ಯಾನಿಕ್ ಮತ್ತೆ ಆರ್ಗ್ಯಾನಿಕ್ ಅನ್ನ ಕ್ವಶನ್ಸ್ ಬರುತ್ತೆ ಜಾಸ್ತಿ. ಮ್ಯಾಮ್ ನ್ಯೂಮರಿಕಲ್ ಹೇಳಿ, ಇನ್ ದ ಫಸ್ಟ್ ಚಾಪ್ಟರ್ ಸೊಲ್ಯೂಷನ್ ಹೌ ಮಚ್ ಕ್ವಶನ್ ವಿಲ್ ಕಮ್, ಹೌ ಮೆನಿ ಕ್ವಶನ್ಸ್ ವಿಲ್ ಕಮ್? ಆರಾಮ್ಸೆ ವಿಲ್ ರಿಸೀವ್ 4 to 5 ಕ್ವಶನ್ಸ್ ಅಪ್ಪ. 4 to 5 questions you will receive it. 1 numerical problem ಇರುತ್ತೆ, 1 MCQ ಇರುತ್ತೆ, 2 marks question ಒಂದಿರುತ್ತೆ, 3 marks question ಒಂದಿರುತ್ತೆ. Clear? 4 to 5 is fixed. So osmosis, and because it is the highest weightage chapter, solution is the highest weightage chapter, so from this a lot of ಅದಕ್ಕೆ slowly ಕಲಿಸ್ತಿದೆ ನಿಮಗೆ. ಕ್ಲಿಯರಾ? ಸೊ osmosis and osmotic pressure, that is osmosis is spontaneous movement. Osmosis is the spontaneous movement of a solvent molecule from a less concentrated solution to the more concentrated solution. Enappa adu? Osmosis is actually a spontaneous movement where solvent molecule from less concentration solution to the more concentration solution through a semi-permeable membrane. Through what? Through a semi-permeable membrane. That osmotic pressure is actually equilibrium hydrostatic pressure. Osmotic pressure is the equilibrium hydrostatic pressure of the column setup of a result going to be osmosis. Clear? So simple define madidre, the minimum external pressure applied to the solution in order to prevent the osmosis. The minimum external pressure, external ಹೊರಗಿಂದ pressure ಅನ್ನು apply ಮಾಡ್ತಾರೆ on the solution. Solution ಮೇಲೆ ಹೊರಗಿಂದ osmotic pressure ಅನ್ನು apply ಮಾಡ್ತಾರೆ on the solution to prevent the osmosis. ಎದಕ್ಕೆ apply ಮಾಡ್ತಾರೆ solution ಮೇಲೆ pressure? To prevent it from getting it osmosis. To get it osmosis, it's going to depend. Okay. In the first order solution, how much questions will come? First, okay, sorry, ma'am, in the solution chapter, there is no 2 marks question. So, 2 marks question, ನಾನು ಹೇಳ್ದಲ್ಲಮ್ಮ 2 marks question ಕೇಳಲ್ಲ 5 marks ನಲ್ಲಿ 2 marks question ಅನ್ನ ಕೇಳ್ತಾರೆ. Okay, see, listen carefully. ಈಗ 5 marks ಇದೆ ಅಲ್ಲ 5 marks ನಲ್ಲಿ A ಮತ್ತೆ B ಈ ತರ ಕೇಳ್ತಾರೆ. ಇದರಿಂದ 2 marks question ಒಂದು ಬರುತ್ತೆ. ಕ್ಲಿಯರ್? ಇನ್ನೊಂದು 3 marks ಅಂತ ಇರುತ್ತೆ. ತಿಳಿತಿದೆನಾ? ತಿಳಿತಾ? ಕೆಮಿಸ್ಟ್ರಿ ನಲ್ಲಿ 5 ಮಾರ್ಕ್ಸ್ ಅಂತ ನಿಮ್ಗೆ ಹೆಂಗೆ ಈಗ ಮ್ಯಾಥಮೆಟಿಕ್ಸ್ ನಲ್ಲಿ 6 ಮಾರ್ಕ್ಸ್ 5 ಮಾರ್ಕ್ಸ್ ಕ್ವಶನ್ಸ್ ಬೀಳುತ್ತಲ್ಲ ದೊಡ್ಡ ಡೆರಿವೇಶನ್ ಸಾಲ್ವ್ ಮಾಡಬೇಕು ಪ್ರಾಬ್ಲಮ್ ಸಾಲ್ವ್ ಮಾಡಬೇಕಂತ ಹಂಗೆ ಕೆಮಿಸ್ಟ್ರಿ ನಲ್ಲಿ ಇರಲ್ಲ. ಓಕೆ, ದಟ್ ವಿಲ್ ನಾಟ್ ಬಿ ಪ್ರೆಸೆಂಟ್ ಇನ್ ದ ಕೆಮಿಸ್ಟ್ರಿ ನಲ್ಲಿ 5 ಮಾರ್ಕ್ಸ್ ನಲ್ಲಿ ಮತ್ತೆ ಡಿವೈಡ್ ಮಾಡ್ತಾರೆ ABC ಇಲ್ಲದ್ರೆ AB ಅಂತ ಡಿವೈಡ್ ಮಾಡ್ತಾರೆ. ಅದರಲ್ಲಿ ಒಂದು ಕ್ವಶನ್ ಬೀಳುತ್ತೆ 2 ಮಾರ್ಕ್ಸ್ಗೆ. ಕ್ಲಿಯರ್? 5 marks only organic. Yes, most probably they will ask 5 marks organic. But if in case they are asking the physical chemistry ನಲ್ಲಿ ಬೀಳುತ್ತಂದ್ರೆ 2 marks ಯಾವುದಾದ್ರೂ ಹಾಕಬಹುದು ಅದರಲ್ಲಿ. ಓಕೆ, that's what I told you Shashi. Organic ಮತ್ತೆ ನಾನು ಆಲ್ರೆಡಿ ಮೆನ್ಷನ್ ಮಾಡಿದ್ದೇನೆ ನಿನಗೆ. ಸೊಲ್ಯೂಷನ್ ಎಲೆಕ್ಟ್ರೋಕೆಮಿಸ್ಟ್ರಿ ಮತ್ತೆ ಕೆಮಿಕಲ್ ಕೈನೆಟಿಕ್ಸ್ ಇಂದ ಮೋಸ್ಟ್ ಪ್ರಾಬಬಲಿ ನ್ಯೂಮರಿಕಲ್ ಪ್ರಾಬ್ಲಮ್ಸ್ ಬರುತ್ತೆ ಪಾರ್ಟ್ ಇ ನಲ್ಲಿ. ಓಕೆ, ಪಾರ್ಟ್ ಇ ನಲ್ಲಿ. ಕ್ಲಿಯರ್? ಸೊ ಅದರ ಪ್ರಕಾರನೇ ಓಕೆ ಪಾರ್ಟ್ ಇ ನಲ್ಲಿ ಕೇಳ್ತಾರೆ ಆ್ಯಂಡ್ ವಾಟ್ ಎವರ್ ದ ಕ್ವಶನ್ಸ್ ಆರ್ ದೇರ್. ಓಕೆ, ಯಾವ್ಯಾವ 5 marks ಕ್ವಶನ್ಸ್ ಇದೆ ಅಲ್ಲ ಫಿಸಿಕಲ್ ಕೆಮಿಸ್ಟ್ರಿದಿಂದ ಅದರಿಂದ 2 marks ಕ್ವಶನ್ಸ್ ಕೇಳ್ಬೋದು. ಅದು ಹೀಗೆ ಓಕೆ A B ಆಗಿ ಇದನ್ನು ಮಾಡ್ತಾರೆ, ಚೇಂಜ್ ಮಾಡ್ತಾರೆ. A ಅಂತ ಕಂಪ್ಲೀಟ್ ಒಂದು ಡೆಫಿನೇಷನು, B ಅಂತ ಇನ್ನೊಂದು ಡೆಫಿನೇಷನ್ ಈ ಥರ ಕೇಳಬಹುದು ಫಿಸಿಕಲ್ ಕೆಮಿಸ್ಟ್ರಿಯಿಂದ. ಓಕೆ, ಡೋಂಟ್ ಡಿಕ್ಲೇರ್ ದ್ಯಾಟ್ ಏನು ಕೇಳೋದೇ ಇಲ್ಲ ಅಂತ ಡಿಕ್ಲೇರ್ ಮಾಡಬೇಡಿ. ದೇ ಹ್ಯಾವ್ ಆಲ್ರೆಡಿ ಆಸ್ಡ್ ಇನ್ ದ ಮಾಡೆಲ್ ಕ್ವಶನ್ ಪೇಪರ್ಸ್ ಆಲ್ಸೋ. ಓಕೆ, how to attempt the give reason. ಹೇಗೆ attempt ಮಾಡಬೇಕು give reasons ಅನ್ನ? Give reasons most probably it will be from D and F block elements. Okay, D and F block elements ಇಂದಾನೆ ಜಾಸ್ತಿ ಕೇಳ್ತಾರೆ. So you should be make sure that D and F block elements give reasons ಅನ್ನ perfect ಮಾಡ್ಕೋಬೇಕು. Okay, next comes the want Hoff's equation of the osmotic pressure. So is osmosis. Okay, CRT, where pi is going to have a osmotic pressure. Okay, pi ಏನಂತ ಆಗ್ಬೋದು? osmotic pressure ಆಗಿ ಆಗ್ಬೋದು. Clear? So concentrate properly everyone. Your osmotic pressure ಮೇಲೆ 2 marks question short ಇಲ್ಲಿ ಬರೆದು ಬಿಡ್ತೇನೆ so that you will have a idea. So ಈ 2 marks ಎಲ್ಲಿಂದ ಬೀಳುತ್ತೆ? ಇಲ್ಲಾದ್ರೆ 1 marks ಗೂ ಬೀಳಬಹುದು. This can be asked in for 1 marks also. Okay, so define ಆಗಿದ್ದ minimum external pressure ಅನ್ನು ನಾವು ಅಪ್ಲೈ ಮಾಡ್ತಿದ್ದೇವೆ ಸೊಲ್ಯೂಷನ್ ಮೇಲೆ. We are applying the osmotic pressure on the solution. Okay, in order to prevent the osmosis. Prevent ಮಾಡ್ತಿವೆ osmosis ಅನ್ನ. Clear? Osmosis ಅನ್ನ prevent ಮಾಡ್ತಿದ್ದೇವೆ. Now concentrate properly. So want Hoff's factor equation of osmotic pressure is going to declared as pi is equal to CRT. Okay, pi is equal to CRT where pi is osmotic pressure clear. Pi is going to be considered as a osmotic pressure. Clear? Theta, and C will be the concentration of the solutions. Clear? Oh, sorry. C will be the clear, and R will be what? Gas constant. R will be what? Gas constant. ಸೊ ಈಗ ಗ್ಯಾಸ್ ಕಾನ್ಸ್ಟೆಂಟ್ ವ್ಯಾಲ್ಯೂನು ಇರುತ್ತೆ. ಒನ್ ಗ್ಯಾಸ್ ಕಾನ್ಸ್ಟೆಂಟ್ ವ್ಯಾಲ್ಯೂ ವಿಲ್ ಬಿ ದೇರ್, ದಟ್ ಇಸ್ 0.0821. ಇಟ್ ವಿಲ್ ಬಿ ಹೌ ಮಚ್? 0.0821 ಲೀಟರ್ per ATM. Liter ATM, or it is also called as, ಇದನ್ನು ಬರಿಬಹುದು mole, yes, more kilo ಬರಿಬಹುದು. Okay, hope so it is correct, I am not remembering. Liter ATM ಅಂತಾನು ಬರಬಹುದು, mole K ನು ಬರಿಬಹುದು. Okay, R is actually equal to gas constant, C is going to be the concentration of the solution, and T will be the absolute temperature in K. Okay, clear? So that is the very important, idne question keltaranta nan helidde nimage. Clear? So here pi is equal to n by VRT. Yav tara barutte n by VRT? Because C is equal to, pi is also equal to because C is equal to n by V. Because C is equal to n by V. Don't want in this, so I'll write it in bracket. Because C is equal to n by V. Clear? So now concentrate properly. So ಇಲ್ಲಿ ಏನಾಗುತ್ತೆ? Pi is equal to W divided by mv. n ಅಂದ್ರೆ ಏನಾಗುತ್ತೆ? n ಅಂದ್ರೆ n is value going to be what? W divided by m, right? n will be W divided by m. n will be W divided by m VRT. MVRT, where n is equal to moles of the solute and V will be the volume of the solution. Okay, means number of the moles. Okay, number of the moles of a solute it is. And what will be the m? What will be act like a V? Volume of the solution. Clear everyone? Tilita? Ma'am, chemistry annual paper easy irutta. Yes, it will be easy, but don't worry, don't take tension, it will be easy. Okay, done. So based upon the osmotic pressure, solution can also be divided into the following three categories. First one is isotonic solution and hypertonic solution. So idar mele 1 marks question keltare, 1 marks question alli kelbodu. Okay, that is isotonic solution, or it is also called as an hypertonic solution. That is, if two solutions of a different substances have a same osmotic pressure at the same temperature, isotonic solution anta karitare. Isotonic ಅಂದ್ರೆ ಏನು? Two solutions, ಎರಡು solutions ಇದೆ of a different substances, two solutions of a different substances at the same temperature, at the same temperature. Next comes the hypertonic solution. Hypertonic solution ಅಂದ್ರೆ ಏನು? If the solution has a higher osmotic pressure, if the solution has a higher osmotic pressure ಇದೆ ಅದರದ್ದು, then the other solution is going to act like an hypertonic solution. Clear? And the hypotonic solution andre ಏನಪ್ಪಾ? What is the meaning of an hypotonic solution? If the solution has a lower osmotic pressure than the other solution, lower osmotic pressure than the other solution. Clear? Next comes the reverse osmosis. If the pressure is higher than the osmotic pressure, whatever the pressure you have added, okay, what pressure we add, pressure, whatever the pressure is there is higher than the osmotic pressure, then the osmotic pressure is applied on the solution. Osmotic pressure on solution, the solvent will flow from the solution into the pure solvent through a semi permeable membrane. Clear? So ಈಗ solution ಯಾವುದು ಒಂದಿದೆ, clear? Pressure ಏನಾಗಿದಲ್ಲ, pressure will start increasing, pressure is going to be higher, then the pressure is going to be higher, osmotic pressure on solution, the solvent will flow. Okay, ಇಲ್ಲಿ ಏನಾಗುತ್ತೆ ಅಂದ್ರೆ solvent will start flowing from the pure solvent through a semi-permeable membrane. Okay, ಎದರಿಂದ ಇದನ್ನಾಗುತ್ತೆ semi-permeable membrane ಇಂದ ಇದು ಪಾಸ್ ಆಗ್ಲಿಕ್ಕೆ ಸ್ಟಾರ್ಟ್ ಆಗುತ್ತೆ. Then semi-permeable membrane ಇಂದ ಯಾವಾಗ ಸ್ಟಾರ್ಟ್ ಆಗುತ್ತಲ್ಲ, when from the semi-permeable membrane it will start passing, semi-permeable membrane ಇಂದ ಪಾಸ್ ಆಗುತ್ತಲ್ಲ, and the process is actually called as what? Reverse osmosis. ಅದಕ್ಕೆ ಏನಂತ ಕರೀತಾರೆ? Reverse osmosis ಅಂತ ಕರೀತಾರೆ. Very simple to understand. Concentrate properly. So whenever if the pressure is higher than the osmotic pressure, pressure is higher than the osmotic pressure, that time what happens? ಯಾವಾಗ ಏನಾಗುತ್ತೆ? ಆವಾಗ the solvent will flow from the solution. ಎದರಿಂದ? Through semi-permeable, membrane, through the help of semi-permeable membrane, and that process, from that process, pure solvent, okay, solvent will flow from the solution. Okay, that procedure is going to be, that process is actually called as, what? Reverse osmosis. Oh, thank you so much. Thank you so much. Hey, where it is still 10K? What is azeotropes? Okay, I'll tell what is azeotropes. So determination of that molecular mass using that colligative property is going to be what? P naught A minus PA divided by P naught A is going to be XB is equal to WB. XB is equal to WB MA divided by WA MB, that is molecular weight of the solute and a substitute madide. This is what we are going to get it. Clear? From the elevation in boiling point, we have discussed it. From the osmosis, what is going to happen. Next comes the abnormal molar mass, that is want Hoff's factor I. Okay, want Hoff's factor I, which is there, that is experimental colligative property divided by normal colligative property. Experiment agi ಏನು ಮಾಡಿದೇವಲ್ಲ ಅದರದು and the normal colligative property is actually going to be what? 1 minus alpha plus x alpha plus y alpha, that is normal molecular weight divided by experimental molecular weight, right? So this is also, formula is very important, guys. So this is also important, this thing. Okay, we have a star, no? Why should I use this? Yes. Theta. Next, want Hoff's factor and degree of dissociation is remaining. Yes, only the last topic of the solution chapter. Last topic of the solution chapter. Okay, want Hoff's factor and degree of dissociation, that is association of a solute particle in the solvent is going to it's going to declare, means it's going to decrease in the number of the particles, so thereby they showing the decrease in the experimental values of the colligative properties. So the experimental molecular weight is going to increase with the normal molecular weight. That solute will show the solution of Na is actually equal to An. If in case before association then 1 and 0, after association then 1 minus alpha and alpha minus N is going to, you can take it. Okay, so therefore the total number of particles after the association, how much it will be? 1 minus alpha plus alpha N, that is alpha is going to be the degree of dissociation. Clear? So want of factor I is equal to what? Experimental colligative property divided by normal colligative property. That is 1 minus alpha plus alpha divided by N, that is experimental molecular weight divided by normal molecular weight. Okay, so this is how it's going to come. Term back slide. This amma, want of factor you are telling me? Is it correct, Shashi? Okay, write down. Ida. ಮತ್ತೆ ಯಾವ್ದಮ್ಮ? Okay, now I am just going to show you the important questions na ತೋರಿಸ್ತೇನೆ ನಿಮಗೆ. Okay, I'll show you people all the important questions from the solution chapter quickly in 5-10 minutes because we have discussed those questions. No, so ನಿಂಗೆ ಯಾವ type of questions ಬೀಳುತ್ತೆ ಅಂತ ತೋರಿಸ್ತೇನೆ. If you want, you can take a screenshot or else actually the PDF will be available afterwards. Immediate ಬೇಕಂದ್ರೆ screenshot ತಗೋಬಹುದು. Okay, what type of questions will be asked from this chapter? Okay, solution chapter in the first is what is the effect of a temperature on the solubility of a solid in a liquid. According to the Le-Chatelier's principle, if the dissociation is an endothermic process, then the increase in the temperature is going to happen because endothermic andre it's going to observe heat from outside there again. So adha salagi temperature matte increase agutte. Clear? Exothermic idre temperature decrease agutte because heat release madutte. Okay, heat already bala heat agirutte, adಕ್ಕೆ it will release it. Okay, that type of a question will be asked. Next is state the Henry's law. I told you people, state the Henry's law is fixed question. Ad bidde bidutte 1 marks ge, 1 marks ge. Write its mathematical equation anta helidare. That is, it states that the partial pressure of the gas of the vapor phase is directly proportional to its mole fraction of the solution phase. Mole fraction of the solution phase. Clear? That is P directly proportional to X, that is P is also equal to KHX, where KH is going to act like an Henry's law constant. ಇದಕ್ಕೆ ಏನು ಕರೀತಾರೆ? KH is actually equal to Henry's law constant. Clear? Henry's law constant ಅಂತ ಕರೀತಾರೆ. One second. Okay, Henry's law constant anta ಕರೀತಾರೆ. Next question is Raoult's law, that is P1 is directly proportional to X1. So ಇಲ್ಲಿ ಏನಾಗುತ್ತೆ? Solution of a two volatile liquids, partial pressure of the each component is directly proportional to the mole fraction of that component. Clear? Mole fraction of that solution. Partial pressure of one component, each component ಅಂದ್ರೆ ಎಷ್ಟು component ತಗೋಬಹುದು? We can get 2, 3, 4 any components. How much components possible? So ಆ component ದು ಯಾವ component ತಗೊಂಡಿದ್ದೇವಲ್ಲ ಆ component solution ದು mole mole fraction. Okay, it's proportional to the mole fraction of that component's solution. Clear? That is called Raoult's law. Next comes the ideal solution and non-ideal solution difference between. That is obeys the Raoult's law and it will not obey the Raoult's law. So delta H mixture is going to be 0. Here delta H mixture is going to be 0 here. Same, ಎರಡು side same ಇರುತ್ತೆ. Okay, non-ideal, sorry. Then intermolecular forces of the solution is equal to solute in solvent, and intermolecular forces of solution is not equal to in solute and in non-solvent. Okay. Hi Subhash, please, ma'am, please respond to the comment, sir, whether board question paper are going to be same as a model paper given by boards. They will follow the same blueprint, whether they are true, Yes, according to the blueprint only the question paper is going to be created. Okay, aim blueprint ಕೊಟ್ಟಿದಾರಲ್ಲ ಅದರ ಪ್ರಕಾರನೇ question paper ಅನ್ನು prepare ಮಾಡ್ತಾರೆ. And model question paper is actually like a model. Okay, ನಿಮ್ಗೆ ಈಗ model question paper ಅಂದ್ರೆ ಏನು ಹೇಳ explain ಮಾಡ್ತೀನಿ ಕೇಳಿ ಇಲ್ಲಿ. Model question paper is only helpful for you people to understand how the questions will be asked. ಓಕೆ ಅವೇ ಕ್ವಶನ್ಸ್ ಬರುತ್ತಪ್ಪ ಅಂತ ಹೇಳಿಲ್ಲ ಗೌರ್ಮೆಂಟ್ದವರು. ಅವ್ರು ನಿಮಗೆ ಪ್ರಿಪರೇಟರಿ ಎಕ್ಸಾಮ್ ಬರೆಯೋಕ್ಕಿಂತ ಮುಂಚೆ ಹೇಗೆ ಪ್ರಿಪರೇಟರಿ ಎಕ್ಸಾಮ್ ಕ್ವಶನ್ ಪೇಪರ್ ಬರುತ್ತಪ್ಪ, ಯಾವ ಪ್ಯಾಟರ್ನಲ್ಲಿ ಬರುತ್ತೆ, ಯಾವ ಮಾಡರ್ನಲ್ಲಿ ಬರುತ್ತೆ, ಅದನ್ನು ತೋರಿಸ್ಲಿಕ್ಕೆ ಮಾಡೆಲ್ ಪೇಪರ್ಸನ್ನು ರಿಲೀಸ್ ಮಾಡಿರ್ತಾರೆ. ಕ್ಲಿಯರ್? ಸೊ ಮಾಡೆಲ್ ಪೇಪರಿಂದ ನಿಮಗೊಂದು ಐಡಿಯಾ ಗೊತ್ತಾಗಬೇಕು ಪ್ರಿಪರೇಟರಿ ಎಕ್ಸಾಮಿಗೆ ಹೇಗೆ ಪ್ರಿಪೇರ್ ಆಗ್ಬೇಕು ನೀವು ಅನ್ನೋದು. ಓಕೆ, ಎಷ್ಟು ಪಾರ್ಟ್ಸ್ ಇರುತ್ತೆ, ಎಷ್ಟು 1 ಮಾರ್ಕ್ಸ್ ಕ್ವಶನ್ಸ್ ಕೇಳ್ತಾರಪ್ಪ. ಇವನ್ ದೋ ಸಮ್ ಪೀಪಲ್ ಏನಿರುತ್ತೆ ಗೊತ್ತಾ, ಸಮ್ ಪೀಪಲ್ ಪ್ರಿಫರ್ ಮಾಡಲ್ಲ, ಬ್ಲೂ ಪ್ರಿಂಟನ್ನು ರೆಫರ್ ಮಾಡಲ್ಲ. ಸ್ವಲ್ಪ ಮಂದಿ ಹುಡುಗರು ಏನ್ ಮಾಡ್ತಾರೆ ಗೊತ್ತಾ, ಅವರು ಬ್ಲೂ ಪ್ರಿಂಟ್ ಬಿಡ್ತಾರೆ, ಮಾಡೆಲ್ ಕ್ವಶನ್ ಪೇಪರ್ ಅನ್ನ ಸ್ವಲ್ಪ ಮಂದಿ ನೋಡ್ತಾರೆ. ಸೊ ಅಟ್ ಲೀಸ್ಟ್ ಒಂದು ಐಡಿಯಾ ಗೊತ್ತಾಗಬೇಕಲ್ಲ ಹುಡುಗರಿಗೆ ಪ್ರಿಪರೇಟರಿ ಬರೆಯೋಕ್ಕಿಂತ ಮುಂಚೆ ಹೇಗಪ್ಪ ಕ್ವಶನ್ಸ್ ಕೇಳ್ತಾರೆ ಅಂತ. ಅದೇ ಸಲುವಾಗಿ ಮಾಡೆಲ್ ಕ್ವಶನ್ ಪೇಪರ್ ಅಂತ ಪ್ರಿಪೇರ್ ಮಾಡಿ ಅವ್ರನ್ನ ಅಪ್ಲೋಡ್ ಮಾಡ್ತಾರೆ KCEB ನಲ್ಲಿ. ಬಟ್ ನೀವೇನು ತಿಳ್ಕೊತೀರಾ, ಮಾಡೆಲ್ ಕ್ವಶನ್ ಪೇಪರ್ ಸೇಮ್ ಎಕ್ಸಾಕ್ಟ್ಲಿ ಪ್ರಿಪರೇಟರಿನಲ್ಲಿ ಕೊಡ್ತಾರೆ ಅಂತ ತಿಳ್ಕೊಬೇಡಿ. ನೋ, ಮೈಟ್ ರಿಪೀಟ್ ಒನ್ ಆರ್ ದ ಅದರ್ ಕ್ವಶನ್ಸ್ ವಿಲ್ ರಿಪೀಟ್ ಓನ್ಲಿ ಬಿಕಾಸ್ ವಿ ನೋ. ಓಕೆ, ಎಲ್ಲರಿಗೂ ಗೊತ್ತಿದೆ ನೇಮ್ಡ್ ರಿಯಾಕ್ಷನ್ಸು, ಒಂದು ಸ್ವಲ್ಪ ಪ್ರಾಬ್ಲಮ್ಸು, ಡೆಫಿನೇಷನ್ಸು, ಲೈಕ್ ಈಗ ಎಕ್ಸಾಂಪಲ್ ನಾವು ಡಿಸ್ಕಸ್ ಮಾಡಿದ್ವಲ್ಲ ಹೆನ್ರೀಸ್ ಲಾ, ರಾಲ್ಟ್ಸ್ ಲಾ, ಅವೆಲ್ಲ ಕಾಮನ್. ಓಕೆ, ಅವಂತೂ ಬಿದ್ದೇ ಬೀಳುತ್ತೆ. ಅವ್ನು ಬಿಟ್ಟು ನೀವು ಅಕಸ್ಮಾತ್ ನೀವು ಎಕ್ಸಾಕ್ಟಾಗಿ ಮಾಡೆಲ್ ಪೇಪರ್ ಥರನೇ ಬೀಳುತ್ತಂತ ಪ್ಲೀಸ್ ಅದನ್ನ ತಲೆಯಿಂದ ತೆಗೆದು ಬಿಡಿ. ಆ ಥರ ಹಾಗೆ ಕೇಳಲ್ಲ. ಸೊ ಇಟ್ಸ್ ಜಸ್ಟ್ ಫಾರ್ ಯುವರ್ ಪ್ರಿಪ್ರೇಷನ್ ಪರ್ಪಸ್ ಸಲುವಾಗಿ ಅಂತ ಹೇಳಿರ್ತಾರೆ ಅದನ್ನು. ಕ್ಲಿಯರ್? ಆತ್ಪ ಕ್ಲಾರಿಫಿಕೇಶನು ಇಷ್ಟು ದೊಡ್ಡ ಮೆಸೇಜ್ ಹಾಕಿದೀಯಾ, ಕ್ಲಾರಿಫಿಕೇಶನ್ ಆಯ್ತಾ? Next question, what is reverse osmosis mentioned its application? So reversing the direction of the osmosis by applying the pressure higher than the osmotic pressure. Applying the pressure higher than the osmotic pressure, that is going to called as reverse osmosis. Okay. Yes, they will follow the blueprint. They will follow the blueprint. Okay. Next problem comes. Problems nodi yav tara problems keltare. I think almost we have 2, 3, 4. Okay, we have 3 problems which has been repeated a lot of times guys. ಈ ರಿಪೀಟ್ ಆಗಿದೆ ಬಹಳ ಸಲ ಇದು. ಸೊ ಕಾನ್ಸಂಟ್ರೇಟ್ ಮಾಡಿ ಏನು ಆಕ್ಚುಲಿ ಹೇಳಿದ್ದಾರೆ ಅನ್ನೋದು. ಓಕೆ, ಸೊ ವೇಪರ್ ಪ್ರೆಷರ್ ಆಫ್ ದ ಕ್ಲೋರೋಫಾರ್ಮ್ ದಟ್ ಇಸ್ CHCl3 and dichloro CHCl3 and CH2Cl2. Okay, at 298 Kelvin are 200 mmHg, are 200 mmHg, and one more is 415 mmHg. Clear? And both are at the temperature of 298 Kelvin. Clear? Done? And then calculate the vapor pressure of the solution. They have told us to calculate the vapor pressure of the solution is question mark, and it containing a 0.5 moles of CHCl3. Okay, XA means Na antanu consider ಮಾಡ್ಕೋಬಹುದು ಇದನ್ನ. Na is actually equal to what? Of CHCl3 ಇದು 0.5 mole, and NB that is CHCl3 ಇದು CH2Cl2 ಎಷ್ಟು ಕೊಟ್ಟಿದ್ದಾರಪ್ಪ? 0.75 ಮೋಲ್ ಕೊಟ್ಟಿದ್ದಾರೆ. ಕ್ಲಿಯರಾ? ಡನ್? ಓಕೆ, ಎಲ್ಲ ಎರಡರದ್ದು ಟೆಂಪರೇಚರ್ ಎಷ್ಟಿದೆ? ಬೋತ್ ದ ಟೆಂಪರೇಚರ್ಸ್ ಆರ್ ಹೌ ಮೆನಿ? ಹಾಯ್ ರೂಪಾ. ಎಸ್ ರೂಪಾ, ಯು ಐ ರಿಮೆಂಬರ್ ಯು. ನೋ ಪ್ರಾಬ್ಲಮ್ ಸುಭಾಷ್, ನೋ ಪ್ರಾಬ್ಲಮ್. ರೂಪಾ ಎಲ್ಲಿ ಕೇಳಿದ್ದೇನೆ ಹೆಸರು. Okay, XH ಈಗ mole fraction find ಮಾಡ್ಲಿಕ್ಕೆ ಹೇಳಿದ್ದಾರೆ. Let us find the mole fraction first. Total mole fraction ಅನ್ನು find ಮಾಡ್ಕೊಳ್ಳೋಣ. ಅದಾದ ತಕ್ಷಣ we are going to find the vapor pressure. Done. So first is about the mole fraction, that is XH mole fraction of CHCl3, that is chloroformed mole fraction, is actually equal to whatever the moles of a solute divided by total mass of a solute and a solvent, right? So total mass is 0.4 ಬರುತ್ತೆ. Done. So XCH2Cl2 is actually equal to what? ಈಗ ನಮಗೆ XCHCl3 ಸಿಕ್ಕಿದೆ, ರೈಟ್? ಈಗ ನಮಗೆ ವ್ಯಾಲ್ಯೂ ಬೇಕೇನು? CH2Cl2 ಬೇಕು. ಓಕೆ, ವಿ ನೀಡ್ ದ ವ್ಯಾಲ್ಯೂ ಆಫ್ CH2Cl2, ರೈಟ್? ಇದನ್ನು ಫೈಂಡ್ ಮಾಡಬೇಕಂದ್ರೆ ವಿ ನೀಡ್ ಟು ಡೂ ಇಟ್ ದಿಸ್ ಒನ್, ರೈಟ್? ಸೊ 1 minus XCHCl3 is going to be 1 minus 0.4, that will be how much? 0.06, right? So afterwards, now we got total mole, means we have found out the XA now. Okay, XA find ಮಾಡಿದ್ವಿ ನಾವೀಗ. ಈಗ ಅದನ್ನ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡ್ಕೋಬೇಕು. We just need to substitute it now. Okay, you have asked, Rupa, go and learn the maths class now. I have asked you one doubt. Shashi, where is your doubt? Ma'am, on 2nd January paper will be easy. ಸೆಕೆಂಡ್ ಪೇಪರ್ ಈಸಿ ಅಂತ ನನಗೆ ಹೆಂಗೆ ಗೊತ್ತಮ್ಮ, ನಾನಂತೂ ಪೇಪರ್ ಪ್ರಿಪೇರ್ ಮಾಡ್ತಿಲ್ಲ. ಬಟ್ ವಿಲ್ ಟ್ರೈ ಟು ಸಪೋರ್ಟ್ ಯು ಪೀಪಲ್. ಓಕೆ, ನೋಡೋಣ, ಬಂದರೆ ಈಸಿ ಆಗುತ್ತೆ. ಓಕೆ, ಐ ಆಮ್ ಸೋ ಸಾರಿ ಶಶಿ, ಐ ಜಸ್ಟ್ ರೆಸ್ಪಾಂಡೆಡ್ ಯು. ಓಕೆ, ರೆಸ್ಪಾಂಡ್ ಮಾಡಿದೆ ನಾನು. ನನಗೆ ಹೆಂಗೆ ಗೊತ್ತಮ್ಮ January 2 ಎಕ್ಸಾಮ್ ಹೆಂಗೆ ಬರುತ್ತೆ ನನ್ನ. ಹೋಪ್ ಸೊ ಇಟ್ ವಿಲ್ ಬಿ ಈಸಿ. ನನಗೂ ಒಂದು ಸ್ವಲ್ಪ ಖುಷಿ ಆಗುತ್ತೆ ಈಸಿಯಾಗಿ ಬಂದರೆ ಪೇಪರು. ಓಕೆ, ಈಸಿಯಾಗಿ ಬಂದರೆ ಪೇಪರ್ ನನಗೂ ಸ್ವಲ್ಪ ಖುಷಿ. ಓಕೆ, PT is equal to P naught XCHCl3 into XHCHCl3. ಸೊ ಅದೇ ಥರ ಮೋಲ್ ಫ್ರಾಕ್ಷನ್ ಎರಡು ಥರದ್ದು ಫೈಂಡ್ ಮಾಡೋದು. ಸೊ ದೇ ಹ್ಯಾವ್ ಆಲ್ರೆಡಿ ಗಿವನ್ ದ ಪಾರ್ಷಿಯಲ್ ಪ್ರೆಷರ್ ಫಾರ್ ಅಸ್ 200 and one more is 450. I have written it here only. ವೇಪರ್ ಪ್ರೆಷರ್ ಅನ್ನು ಎರಡು ಥರದ್ದು ಬರ್ದಿದ್ದೇನೆ. ಸೊ ದಿಸ್ ಆರ್ ದ ಮೋಲ್ ಫ್ರಾಕ್ಷನ್ಸ್ ವಿಚ್ ದೇ ಹ್ಯಾವ್ ಗಿವನ್ ಇಟ್. ಸೊ ವಾಟ್ ವಿಲ್ ಬಿ ದ ಟೋಟಲ್? ದಟ್ ವಿಲ್ ಬಿ 329 ATM. ಏನಾಗುತ್ತಪ್ಪ? 329 ATM. ಕ್ಲಿಯರ್? Responding Allah, responding. Okay, thank you so much for teaching English. Okay, next 1 gram of a non-volatile solute. So ಇಲ್ಲಿ ಏನಾಗಿದೆ? 1 gram of a non-volatile solute ಅನ್ನು ತಗೊಂಡಿದ್ದಾರೆ. solute ಅನ್ನು dissolved in a 50 gram of a benzene. ಇದರಲ್ಲಿ 50 gram of benzene ನಲ್ಲಿ dissolve ಮಾಡಿದ್ದಾರೆ. Concentrate here. What all they have given us actually. So 1 gram of a non-electrolyte solute is being dissolved in. It has been dissolved in 50 gram, it is being dissolved in the 50 gram of benzene. They have dissolved in the 50 gram of benzene. So W1 is equal to what? 50 grams. Then now lowered, they have given W2 also, that is 1 gram. They have told 1 gram of a non-electrolyte solute. Solute is being dissolved in this solvent. Clear? Clear? 1 gram of solute has been dissolved in the 50 gram of benzene, that is also called as a solvent, right? Ma'am, next lesson is electrochemistry, ma. Electrochemistry I'll teach, okay? W2 done. Then freezing point of a benzene by 0.40 K. So they have told 0.40 K freezing point. It means what? Delta TF ಕೊಟ್ಟಿದ್ದಾರೆ. Delta TF they have given us, that is 0.4 ಕೊಟ್ಟಿದ್ದಾರೆ, right? 0.40 K. Then the freezing point depression constant of a benzene is going to be, freezing point of a benzene is going to be how much? 5.12 KF freezing point. ಏನು ಕೇಳಿದ್ದಾರೆ? freezing depression point ಕೇಳಿದ್ದಾರೆ. That is KF is equal to 5.12 K. Clear? Find the molar mass of the solute. They have told us to find the molar mass of the solute, right? They have told us to find the molar mass of the solute. Done? Okay. This is all the given things they have given us. Ella given things ana kottidare. What formula we know already according to the freezing point. Delta TF is equal to KF, that is depression point, into W2, that is mass of the solute, into 1000 divided by M2, that is they have told us to find the molar mass. Okay, idu molar mass. M2 is actually the molar mass ಅನ್ನ find ಮಾಡ್ಲಿಕ್ಕೆ ಹೇಳಿದ್ದಾರೆ ನಮಗೆ and W1 is actually called as a solvent, right? So ನಾವೀಗ M2 ಅನ್ನ find ಮಾಡ್ಬೇಕಂದ್ರೆ M2 we will take it aside, right? M2 ನ ಸೈಡ್ ತಗೊಳ್ಳೋಣ. So M2 is equal to M2 ಇಲ್ಲಿ ಹೋಗಿತ್ತಂದ್ರೆ ಏನಾಗುತ್ತಪ್ಪ ಡೆಲ್ಟಾ TF ತೆಳಗಡೆ ಬರುತ್ತೆ ಅಷ್ಟೇ. This will come here, this will go here. Done. That's it. Okay. So ಎಲ್ಲ substitute ಮಾಡೋಣ. KF ಅಂದ್ರೆ already ಗೊತ್ತಿದೆ 512, 5.12. Okay. W2 ಅಂದ್ರೆ ಗೊತ್ತಿದೆ 1 gram into 1 into 1000. Delta TF ಅಂದ್ರೆ 0.40 into W1 ಅಂದ್ರೆ ಏನಪ್ಪ? What is the W1? That is 50 grams, 50. So first you're going to multiply all the things and then you're going to divide it with the 0.4 into 50. You will get 256 grams per mole. ಏನು ಸಿಗುತ್ತೆ? 256 grams per mole. If you write the given, okay, if in case it is given things ಅನ್ನ ಬರ್ದ್ಬಿಟ್ರೆ ಈಸಿಯಾಗಿ ಆನ್ಸರ್ಸ್ ಅನ್ನ ಫೈಂಡ್ ಮಾಡ್ಕೋಬಹುದು. ಕ್ಲಿಯರ್? Next, determine the amount in grams of CaCl2I. See, this is of want-Hoff's factor. One problem is on want-Hoff's factor. Want-Hoff's factor in the ಕೇಳ್ತಿದ್ದಾರೆ. That is I is equal to, they have given us the value 2.47. Clear? And it is dissolved in the 2.5 liters of water. Okay, 2.5 liters of water ನಲ್ಲಿ dissolve ಮಾಡಿದ್ದಾರೆ. 2.5 liters of water ದಲ್ಲಿ dissolve ಮಾಡಿದ್ದಾರೆ. Clear? And such that osmotic pressure is 0.75 atm. Okay, osmotic pressure ಅನ್ನು ಕೊಟ್ಟಿದ್ದಾರೆ. That is 0.75 atm. Clear? And they have given us the temperature also. That is 27 degrees Celsius. So you just need to add it. And 27 degrees Celsius ಅನ್ನು Kelvin ನಲ್ಲಿ convert ಮಾಡಿ. Fast ಆಗಿ ಹೇಳಿ Kelvin ಅನ್ನು convert ಮಾಡ್ಕೊಂಡು. Kelvin ನಲ್ಲಿ convert ಮಾಡ್ಕೊಂಡು fast ಆಗಿ ಹೇಳಿ. 273 plus 27. Done? So ಆಗುತ್ತೆ. Okay, everything is given. R value no ಆಯ್ತು. What is the R value? R is also given 0.0821 liter atm. Okay, they have given all the things. Now just W2 is equal to osmotic pressure M2V divided by IRT. So W2 is equal to, they have given osmotic pressure, that is 0.75. Then afterwards M2, we need to find the M2 here. Molar mass anna find ಮಾಡಬೇಕು. ಎತ್ತರದ molar mass CaCl2 molar mass find ಮಾಡಬೇಕು. Okay, molar mass of, that is M2 of CaCl2 of CaCl2. Fast again ನೋಡೋಣ. Ma'am, start next lesson. Yes, I will start the next lesson. ನಿಮಗೆ numerical problems ಬೇಕಿತ್ತು, so I am solving it. You people only wanted numerical problems, ಅದಕ್ಕೆ ಸಾಲ್ವ್ ಮಾಡ್ತಿದ್ದೇನೆ ನಾನಮ್ಮ. ನಿಮಗೆ ಬೇಕಂತೀರಾ, ನೀವೇ ಬ್ಯಾಡ್ ಅಂತೀರಾ, ಏನು ಹೇಳೋದು ನಿಮಗೆ? 40 plus 40 plus 35.5 into 2, it will be 111. So that's what we have substituted here. Substitute ಮಾಡೋಣ. Then we'll get what W2 will be 3.42 gram. 3.42 gram. Clear everyone? ತಿಳಿತಾ? Okay, next, some students was, one of the students was actually asking isotopes andre enappa. So this is what isotopes is. So some binary solutions at a specific concentration, binary solution at a specific concentration have same composition in the liquid and vapor phase, same composition in the liquid also and in the vapor phase also. Clear? At a constant temperature dalli. Okay, binary solutions at a specific concentration and composition in liquids and vapor phase at boiling at a constant temperature is going to called as an isotope. Example, ethanol and water mixture. 95% is ethanol by volume and remaining 5% is going to be the water. Clear? So this is called as an isotope. This is also very important. ಬಹಳ ಸಲ repeat ಆಗಿದೆ. So ಯಾರೋ ಕೇಳ್ತಿದ್ರು ನನಗೆ isotope definition ಅಂತ, ನಾನು ಇದೇ ನೋಡಿ isotope definition. Okay. So example for a minimum boiling isotope ಕೇಳಿದ್ದಾರೆ. Non-ideal solution with a large positive deviation from the minimum boiling isotopes at a specific concentration. So non-ideal solution with a positive deviation. With a positive deviation. Clear? Okay. Next, we'll start with the electrochemistry chapter. Electrochemistry chapter start ಮಾಡೋಕ್ಕಿಂತ ಮುಂಚೆ I will give you people 10 minutes break. After 10 minutes, I'm going to start with the electrochemistry chapter. So everyone, you people also can go and have a tea and come. Even I will have tea and come. Then I will continue with the break. Illa. Yak illa. Then I will start with the electrochemistry. Okay? 10 minutes, I will be back. Who needs to come first? Who needs to come faster? Mama. Is this live? Yes, it is live only. Okay, let's start. Oh, thank you so much. If it is helpful to you people, then it's good, right? Okay, start on electrochemistry. We'll start with the electrochemistry. What is my name? Yeah. Rithika Ma, Rithika. My name is Rithika. So, gotta Rithika yaru? Shall we start? Okay, fast ಆಗಿ ಮುಗಿಸೋಣ electrochemistry. Okay, electrochemistry is not a big chapter. I mean, solution was actually very big chapter. Solution ಅಲ್ಲಿ ಬಹಳ ಕಾನ್ಸೆಪ್ಟ್ಸ್ ಇದೆ, ಅದಕ್ಕೆ ಸ್ವಲ್ಪ ಟೈಮ್ ಬೀಯಿಂಗ್ ತಗೊಳುತ್ತೆ. electrochemistry ಇಂಪಾರ್ಟೆಂಟ್ ಕಾನ್ಸೆಪ್ಟ್ಸ್ ನ ಡಿಸ್ಕಸ್ ಮಾಡಿ ಕೆಮಿಕಲ್ ಕೈನೆಟಿಕ್ಸ್ ಹೋಗೋಣ. ಓಕೆ, ಕೆಮಿಕಲ್ ಕೈನೆಟಿಕ್ಸ್ ಇಸ್ ಅ ವೆರಿ ಸ್ಮಾಲ್ ಚಾಪ್ಟರ್. ಓಕೆ, ಕೆಮಿಕಲ್ ಕೈನೆಟಿಕ್ಸ್ ಬಹಳ ಚಿಕ್ಕ ಚಾಪ್ಟರ್ ಇದೆ. ಮ್ಯಾಮ್ ಲೈವ್ ಇಸ್ ಸ್ಟಕ್ಕಿಂಗ್. 1 second ಗೈಸ್. ಎಲ್ಲಿ ಸ್ಟಕ್ ಆಗ್ತಿದೆಯಪ್ಪ? ಇದೇನಲ್ಲ ಇಲ್ಲೇ. ಏನಾದರೂ ಸ್ಟಾಪ್ ಆದರೆ ಹೇಳಿ. ಇಫ್ ದ ಲೈವ್ ವಿಲ್ ಸ್ಟಾಪ್ ದೆನ್ ಟೆಲ್ ಮೀ. Okay, everything is perfect. So let's start now electrochemistry. Hi, principal. Okay, hi. So electrochemistry start ಮಾಡೋಣ. Electrochemistry is a study of relationship between electrical energy and the chemical energy. Clear? So it's a difference between what? It's actually a study of relationship between the electrical energy and the chemical changes. Whatever the electrical energy and chemical changes are happening, that is actually called as an electrochemistry. ಅದಕ್ಕೆ ಏನಂತ ಕರೀತಾರೆ? electrochemistry ಅಂತ ಕರೀತಾರೆ. Clear? electrochemistry ಅಂತ ಕರೀತಾರೆ. Done. And what are the two main types of a cells? Okay, ಎರಡು type of cells ಇರುತ್ತೆ ಅದರಲ್ಲಿ. ಯಾವುದಪ್ಪ ಅದು? First one is electrolytic cell, next one is galvanic cell. Okay, ಎರಡು type of cells ಇರುತ್ತೆ ಅದರಲ್ಲಿ. So ಯಾವ cells ಇರುತ್ತೆ? First one is electrolytic cell and next one is galvanic cell. Clear? So galvanic cell ಮತ್ತೆ electrolytic cell. So ಈಗ what you people need to understand in electrochemistry. So So in electrochemistry, you should be knowing first thing is, okay, first thing ಏನು ಗೊತ್ತಿರಬೇಕಪ್ಪ? electrochemistry ಅಂದರೆ ಏನು? electrochemistry ಅಂದರೆ ಏನಪ್ಪ? electrical energy ಮತ್ತು chemical energy ಏನು ಕರೀತಾರೆ? The study of the electrical energy. Electrochemistry is the study of the relationship between the electrical energy ಮತ್ತು chemical energy. Okay, electrical energy Okay, study of electrochemistry andre enu? Study of electrical energy and chemical energy is actually called as an energy. Now, iga idaralli two types ide. We are having a two types in it. Okay, first one is what and second one is what. I'll tell you people. Okay, first one in baratappa. What is the first one? First one is going to be what? Electrolytic cell and galvanic cell. Okay, electrolytic cell, electrolytic cell and galvanic cell. Clear? So electrolytic cell matte galvanic cell. Electrolytic cell matte galvanic cell anta karitare. Clear? Iga electrolytic cell andre enagutte? What is actually meaning of an electrolytic cell? What is actually the meaning of an electrolytic cell? That we will understand it. Okay, electrolytic cell andre ಏನಪ್ಪ ಏನಂತ ಕರೀತಾರೆ ಅನ್ನೋದು ನೋಡೋಣ. Electrolytic cell ನಲ್ಲಿ ಏನಾಗ್ತಿದೆ? What is actually happening in the electrolytic cell? Hi. ಏನು stuck ಆಗ್ತಿಲ್ಲ ಅಲ್ಲ? Hope so nothing is getting stuck, guys. So nothing is getting stuck anta tilkondu naditidene. Okay, electrical cell alli enagtide? 1 second guys, just give me 1 second. Okay, so electrical cell alli enagtide? Actually electrical cell means electrical energy is getting converted into the chemical energy. Electrical energy is getting converted into the chemical energy electrolytic cell nalli. Okay, electric energy is converting to chemical. It is converting to chemical energy. Illi enagutte? Chemical energy to the electrical energy. Okay, chemical energy to electric energy ಏನು ಕರೀತಾರೆ? galvanic cell ಅಂತ ಕರೀತಾರೆ. ಕ್ಲಿಯರ್? ಅದಕ್ಕೆ ಏನಂತ ಕರೀತಾರೆ? galvanic cell ಅಂತ ಕರೀತಾರೆ. ಕ್ಲಿಯರ್? ಡನ್? Yes ma'am, all is fine. That's good that everything is going fine from you people. Okay, next comes the electrochemical cell. Okay, next kaliyodu electrochemical cell, that is also called as an electrolytic cell anna understand madakolana. Okay, devices in which the redox reaction is going to occur the involvement of the electricity. Okay, in a redox reaction andre enu? Oxidation ಮತ್ತೆ reduction ಎರಡು ತರ ಆಗ್ತಿದೆ ಇಲ್ಲಿ. Clear? So that is devices in which the redox reaction is going to occur, that is involvement of the electricity is been happening. Okay, involvement of the electricity is been happening. In that we have a two types. Okay, we have a two types, that is galvanic, that is also called as voltaic cell antanu karitare, which will produce the electricity from the spontaneous reaction. Means chemical reaction in the produce ಮಾಡುತ್ತೆ. From the chemical reaction it's going to produce. Electrolytic cell andre ಏನು? Consumes the electricity to drive the non-spontaneous reaction. ಏನು ಮಾಡುತ್ತೆ ಇಲ್ಲಿ? It will drive the non-spontaneous reaction. It will drive the non-spontaneous reaction. Done? Next, we will study in detail regarding the galvanic cell. Okay, we'll study in detail regarding the galvanic cell. So, before galvanic cell, what is the meaning of an electrolysis? That we were going to learn it. Okay, adarkinta munche, let us learn what is the meaning of an electrolysis. What is the meaning of an electrolysis? Yes, I am live only, no? I'm live only, right? Okay, perfect. Yes. So, ಈಗ electrolysis ಅಂದ್ರೆ ಏನಪ್ಪ? What is the meaning of an electrolysis? Electrolysis do ಏನ್ part ಇದೆ and what actually it will participate here? ಏನಪ್ಪ participate ಮಾಡುತ್ತೆ? Electrolysis. So, electrolysis means what? ಏನದು? The process by using the direct current. By process by which we are using the direct current, which we are going to drive it from non-spontaneous chemical reaction. Direct current ಅನ್ನ use ಮಾಡುತ್ತೆ. DC current ಅನ್ನ use ಮಾಡುತ್ತೆ. That is non-spontaneous. That is going to be the what? Non-spontaneous chemical reaction. Typically it is going to break down into an ionic compound, that is electrolyte. Okay, non-spontaneous chemical reaction will typically breaks. ಏನಾಗುತ್ತದು? It will typically break to form a electrolyte. ತಿಳಿತಿದೆನಾ ಎಲ್ಲರಿಗೂ? Electrolyte. So that is also called as simpler substances also, like splitting the water into the hydrogen and oxygen, or separating the elements from the O's. That is also called as that. Okay, means it is a setup actually where the substances will split, that is electrodes. That is also called as the conductors, and the DC power is going to be the sources. Okay, substances will split in a bracket. Simple agi barkobodu illi. Substances will break. Clear? ತಿಳಿದಿದೆನಾ? ಏನ್ ಡೌಟ್ ಕೇಳಿದೀಯಮ್ಮ? Ravi, I have already discussed about the important questions, appa. I have already discussed about the important questions to you people. Ravi, ನೀನು ಯಾವಾಗ important questions discuss ಮಾಡ್ತೀನಲ್ಲ ನೀ ಗಾಯಬ್ ಆಗಿಬಿಟ್ಟಿರ್ತೀಯ. ಅದ್ರ ಸಲುವಾಗಿ ನಿನಗೆ ಇಂಪಾರ್ಟೆಂಟ್ ಕ್ವಶನ್ಸ್ ಗೊತ್ತಾಗಲಿಲ್ಲ. ಆ್ಯಂಡ್ ನಂಬರಿಕಲ್ ಪ್ರಾಬ್ಲಮ್ಸನ್ನು ಆಲ್ರೆಡಿ ಸೊಲ್ಯೂಷನ್ ಚಾಪ್ಟರ್ ಸಾಲ್ವ್ ಮಾಡಿದೆ ನಾನು. ನನಗೆ ಗೊತ್ತಿಲ್ಲ ನೀನು ಎಲ್ಲಿ ಹೋಗಿದ್ದೆ ಆ ಟೈಮ್ದಲ್ಲಿ. ಸೊ ಯು ಕ್ಯಾನ್ ಜಸ್ಟ್ go and just reverse the class and you can just check it. Okay, ಏನಮ್ಮ ಕ್ವಶನ್ ಕೇಳಿದೀಯಾ? ಶಶಿ ಎಲ್ಲಿದೆ ಕ್ವಶನ್? ಮ್ಯಾಮ್ ರೆಸ್ಪಾನ್ಸ್. ಮ್ಯಾಮ್ ಇಟ್ ವಿಲ್ ಆಲ್ಸೋ ಡಿಫೈನ್ as a chemical energy into electrical energy. Yes ಶಶಿ, ಕರೆಕ್ಟ್ ಶಶಿ, ಕರೆಕ್ಟ್. ಕಲಿಸೋ ಟೈಮ್ದಲ್ಲಿ ಬರೇ ಮೆಸೇಜ್ ಓದ್ಲಿಕ್ಕೆ ಆಗಲ್ಲ, ಅದ್ರ ಸಲುವಾಗಿ. ಓಕೆ, ಡನ್? ತಿಳಿತಾ? Done? Now, let us learn about the galvanic cell. Galvanic cell andre enu? The galvanic cell, or is also called as volatile cell, is an electrochemical device that converts the chemical energy into the electrical energy. Okay, ಏನು ಮಾಡುತ್ತೆ ಇಲ್ಲಿ? It will convert what? What is the work of a galvanic cell? Galvanic cell. So galvanic cell the kelsa eno? What it will actually do? It will convert the chemical energy into the electrical energy. Okay, it will convert the chemical to electrical. Okay, it will convert from the chemical to electrical through a spontaneous redox reaction. Through what? Through a spontaneous reaction. Clear? One second. Okay, through a spontaneous reaction, redox reaction is actually called as a galvanic cell, right? But it consists of two electrodes present irutte. Clear? Two electrodes present irutte idralli. Yav type of two electrodes present irutte? Ig nodi, yav type of electrodes present irutte? It contains two types of electrodes are present in it. So first is electrode is going to be the anode. Here the oxidation is happening. Clear? Illenagatte cathode. Here the reduction is happening. Okay? Illenagtide reduction anna ಆಗ್ತಿದೆ. I was there. I responded, no Shashi. How many times I will tell Amma? From that time you are learning very good, Ravi. I was there. I did not went somewhere. Asked most important questions. I am struggling to learning. Can't understand. It's okay, Appa. No problem. Shashi, I have already responded your question, Amma. Okay. Go. So, anode and cathode is anode is actually called as an oxidation, cathode is actually called as a reduction. So, each is going to be placed in the electrolytic solution. Clear? And a salt bridge has been connected. Clear? So, actually where it will be present? Where it will be present? So, this both the things which are present. Electrolysis means it will be dipped. This both the things are going to be dipped into what? It is dipped into electrolyte solution nalli dip ಮಾಡಿರ್ತಾರೆ. Clear? So ಈ ತರ ಎಲ್ಲೋತು ನಮ್ಮದು reaction. Yes, ee tara galvanic cell anna dip ಮಾಡಿರ್ತಾರೆ. Clear? And it is connected to the salt bridge also. It is got connected to the salt bridge also. Krita? So it's even got connected to the salt bridge also. So now we will learn about what is actually the meaning of a salt bridge and what is actually the work of a salt bridge. Okay? We will learn both the things now. Okay? Okay, now stop discussing that things. Okay? Stop discussing that things. So now what we were studying about that is anode nalli Zn plus 2 is happening. I told you already anode nalli ಏನು ಆಗ್ತಿದೆ? Anode nalli oxidation ಆಗ್ತಿದೆ. Here and ಇದರಲ್ಲಿ reduction ಆಗ್ತಿದೆ. Clear? So ಇದರಲ್ಲಿ oxidation ಆಗ್ತಿದೆ. ಆಮೇಲೆ ಇದರಲ್ಲಿ reduction ಅನ್ನ ಆಗ್ತಿದೆ. Right? It has been connected to the salt bridge. Clear everyone? Understanding? So next, within a galvanic cell, oxidation occurs at the anode, which is the loss of the electrons are going to happen. So loss of the electrons are going to happen there. Clear? So and reduction occurs at the cathode, that is gain of the electrons are happening. So electrons flows from the anode to the cathode through the external wire generating the electrical current. Okay. So always remember anode to the cathode anna move agutte. Always remember it's going to move from anode to cathode. Clear? Illa bardbidana. It will always move from anode to cathode. Clear? Anode to cathode. Done. It will move always from anode to cathode, generating the electrical current. Okay. Now the diennial cell is going to be the classical example, and overall cell reaction will be this. So this reaction is going to be a spontaneous and release of energy which is harnessed as an electrical work. So yav release energy aguttalla adana electrical work agi harness ಮಾಡ್ತೇವೆ. Clear? Harness ಮಾಡ್ತೇವೆ electrical ಇದರಾಗಿ. Okay? Yes, Srishti, it is a cathode. Done? Ega. Next thing what you should understand about the diagram is, okay? ನೀವು ಏನು ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್ ಮಾಡ್ಕೋಬೇಕು ಡಯಾಗ್ರಾಮ್ದು. ಸೊ ಇಲ್ಲಿ ನೋಡ್ಬೋದು ನೀವು what is actually happening here. anode is present, cathode is present. Done. So anode in the cathode ge salt bridge na connect madidare, and what is the work of salt bridge? I'll tell you people. So oxidation ಆಗ್ತಿದೆ means what? There is a loss of the electrons. ಇಲ್ಲಿ ಏನಾಗ್ತಿದೆ? Loss of the electrons is happening and it will go and move here. Means reduction ಆಗ್ತಿದೆ ಇಲ್ಲಿ. It is gaining the electron. It's actually gaining the electron. It's actually gaining the electron. Clear? And what is actually the meaning of a salt bridge? So meaning of a salt bridge ಏನಪ್ಪ? So ಈಗ ಕೆಲಸ ಏನು ಮಾಡ್ತಿದೆ salt bridge? What is the work of the salt bridge? Everyone are clear what is the meaning of an anode, cathode ಎಲ್ಲ ತಿಳಿತಲ್ಲ? Anode ಇಂದ cathode ಗೆ ಟ್ರಾನ್ಸ್ಫರ್ ಆಗುತ್ತೆ, anode ಇಂದ cathode ಗೆ ಟ್ರಾನ್ಸ್ಫರ್ ಆಗುತ್ತೆ ಎಲ್ಲ electrons. So anode ಜಾಗದಲ್ಲಿ oxidation ಆಗ್ತಿದೆ, that is loss of the electrons are happening there. At the cathode there is going to be the gain of the electrons, that is reduction is going to happen. Clear? So ಈಗ ಅದ್ರ ನಡುವೆ ಒಂದು salt bridge ಅಂತ ಇದೆ. So now what is the meaning of a salt bridge? Why it has been salt bridge is present, ಅದರ ಕೆಲಸ ಏನು, and why it is in the U shape. Okay, you can just check it out, it is in the U shape, right? So salt bridge ಮೇಲೇನು ಕ್ವಶನ್ ಕೇಳ್ತಾರೆ, so I'm just telling you. Okay, salt bridge ಅಂದ್ರೆ ಏನು? First point about the salt bridge, it's actually U shaped. It's U shaped. Clear? Next coins comes what? Salt bridge are actually U-shaped. Salt bridge is actually U-shaped. Right? Then a tube filled with the gel or a solution of an inert electrolyte. U-shaped. Filled with gel or solution of inert gas. It's been filled with the solution or a gel of an inert gas like KCl or KNO3. Like KNO3 or inert gas of KCl3. Okay, but it is connected to the oxidation and reduction half cell in a galvanic cell. Half ಇದರಿದೆ. Okay, half ಆಗಿದೆ. It's ಇಲ್ಲಿ ಅರ್ಧ. Okay, it's getting connected from, ಇಲ್ಲಿ ಬರಿಬಹುದು ನಾವು, connected from oxidation to reduction, half filled. Okay, half dipped ಅಂತ ಬರಿಬಹುದು. Half dipped. Done. Half dipped. Ma'am, agar jella. Yes, agar jella ಅಲ್ಲ, KCl ಮತ್ತೆ KNO3 gel. Okay. Half cell in a galvanic cell. Clear? ಈಗ ಏನು ಫಂಕ್ಷನ್ ಇದೆ? What is actually the function of it? Okay. It completes the circuit by allowing ion flow between the half cell. Ion flow between the half cell. Its work is what? Ion flow. Ion flow so its work is what it actually works. Okay, first is what? Ion flow agutte. Ion flow nalli help madutte, that is it completes the circuit by allowing the ion flow, completes the circuit by so ion flow from the half filled. Okay, ion flow between the half cells. Okay, between half cell. Clear? Done. This is function. Okay, this function now. I'm discussing about the functions now. Clear? I'm discussing about the functions now. It avoids the chances of diffusion of solution between the half cell. Very good, Shashi. Correct. And it even maintains the electrical neutrality by balancing the charge build-up. It will maintain the electrical neutrality also. What it does? Maintains the electrical utility Okay, it maintains the electrical utility, neutrality by balancing the charge buildup. Okay, neutrality by balancing the charge buildup. Clear? So next point in here, let's see. Yes, you can use it as a gel, ma'am. NH4NO3 no, yaudu inert gas irlappa use madkobodu. So inert electrolyte irbekadu. Inert electrolyte irbeko. Clear? Yes, ln 2 half cell. Very good, Shashi. Chemically, if it's in case it is a chemically inert, then you can use it. Okay. Now it prevents the mixing of a different solution. Okay. It even prevents. Its work is also what? Prevents from different solution to mix with that. Okay. Prevents from solution, and it allows the continuous electron flow. Continuous electron flow allow ಮಾಡುತ್ತೆ by the external circuit. Continuous electron flow with external, means externally it help ಮಾಡುತ್ತೆ. Continuously it will help for the electrons to flow by external circuit. Okay, by external circuit means what? It's acting like a different type of a circuit itself. Okay, even circuit tarane actually act ಮಾಡ್ತಿದೆ. Clear? So that is what they have told. Salt bridge ಏನೇನು importance ಅನ್ನೋದು ಗೊತ್ತಾಯ್ತಾ ಎಲ್ಲರಿಗೂ? Understood everyone? What is the salt bridge importance? ತಿಳಿತಾ? Okay, hope so understood. Next comes the electrode potential. Okay. Next comes the electrode potential. Electrode potential andre enu? Electrode potential is the tendency of an electrode to lose or gain the electron when it is contact with the ion solution. Electrode potential andre enappa? What is the meaning of an electrode potential? Electrode potential is actually a tendency of an electron to lose. Tendency to lose or gain electrons when contact with the ion solution. Or clear? With the ion solution. So idralli ಎರಡು ತರ ಇರುತ್ತೆ. Oxidation potential ಒಂದು, reduction potential ಒಂದು. Okay. So we have two things in this. So ಎರಡು ತರ types ಇದೆ ಇದ್ರಲ್ಲಿ. What are those two types? So ಎರಡು ತರ types ಇದೆ ಇದ್ರಲ್ಲಿ. Which are those two types? First is actually oxidation. Oxidation potential. One is oxidation potential. It is tendency to lose the electrons. Okay. It is tendency to lose the electrons. Oxidation potential ಏನಾಗುತ್ತೆ? Okay. ಇಲ್ಲಿ ಏನಾಗುತ್ತೆ? Reduction potential. So reduction potential ಏನಾಗುತ್ತೆ? It is tendency to gain the electron. It's actually tendency to gain the electron. Clear? It's actually tendency to gain the electron. Clear? Done. Next comes the standard potential. It is measured on the relative to the standard hydrogen electrolyte, that is also called as an SHE, okay, which is actually assignment a potential of 0 volt. So it will be a 0 volt. Tomorrow's zoology class we put it as 5. Oh, so sorry, we can't put it. It is a potential difference set up between metal and in its. Very good, Shashi, that's correct. It was there in because complete geology ಮಾಡಬೇಕಲ್ಲ ಅದಕ್ಕೆ. Okay, we need time, no? ನೀನು ಆಮೇಲೆ ನೋಡಪ್ಪ, okay? You see it afterwards, no problem. Next comes, okay, next comes what? SHE, okay? What is a meaning of an SHE? ಏನಪ್ಪ SHE means what? What is the meaning of an SHE? So it is SHE is also considered as E0. So SHE andra E0 antanu consider ಮಾಡ್ಕೋಬಹುದು. So E0 antanu consider ಮಾಡ್ಕೋಬಹುದು. So it is measured. It is going to be a measured relative to the standard hydrogen electrode. Standard electrode, okay, standard hydrogen electrode, okay, which is assigned a potential of 0 volt, okay. Potential of how much? 0 degree volt. Clear? This is very important, okay, 0 volt, okay. Clear? Yes, perfect, perfect. Ma'am, whether Daniel cell is asked? Yes, Daniel cell is asked, appa. Why? Obviously, they will ask the Daniel cell, okay? They will ask the Daniel cell. Clear? Next comes the, there is a cell potential. How you are going to calculate the cell potential? He calculate madira cell potential and it's going to be calculated on the basis of means E0 cell. E0 cell is equal to E0 cathode minus E0 anode. E0 cathode versus E0 anode. Clear? Tirita, yes ma'am. Is this diagram and experiment explanation for how many marks they will ask or what? So diagram explanation, I'll tell you people what type of questions will be asked. Don't worry. So now only if you want I'll ask. Sorry, now only if you want I'll see what type of questions will be asked actually. Nernst equation, problems keltare, and then yes, ee tara question ಕೇಳಬಹುದು ನೋಡಿ, okay. That is, name the factors which conductivity of an electrolyte conductors or ionic conductors. On what factors conductance of a solution is going to depend, like nature of the electrolyte, temperature, nature of the solvent and viscosity, concentration of the ions in the solution, the size of the ions and the solution. If in case ಇತರದೇ ಅಕಸ್ಮಾತ್ ಆಗಿ ಎಕ್ಸ್ಪ್ಲನೇಷನ್ ಮಾಡಕ್ಕೆ ಹೇಳಿದ್ರೆ, okay, ಇತರದೇ ಎಕ್ಸ್ಪ್ಲನೇಷನ್ ಮಾಡ್ಲಿಕ್ಕೆ ಹೇಳಿದ್ರೆ they will ask this for 3 marks. So most probably they will be asking the numerical problems only from the electrochemistry also. So most probably electrochemistry diagram, electrochemistry na keltare, okay. What is this your name amma? Shashi, ಒಂದು ನಿಮಿಷ ಧೀರ ಹಿಡಿಬೇಕು, ಆನ್ಸರ್ ಮಾಡುತ್ತಾನ, ರಿಪ್ಲೈ ಮಾಡುತ್ತಾನ, ಓಕೆ. ತಿಳಿತಮ್ಮ ಅಮ್ಮ, ಬಿಡ್ತಿದ್ದೆ ನಾನೀಗ ಮತ್ತೆ. ಓಕೆ, ವೇರ್ ವಿ, ಓಕೆ, okay. Next comes the representation of an electrochemical cell. That is, electrochemical cell is going to be represented using the cell notation, which shows the flow from anode to cathode. Always remember the flow, electron flow will be from the anode to the cathode. Anode is actually called as an oxidation and cathode is actually called as an reduction. Clear? Anode is called as an oxidation and cathode is going to called as an reduction. Clear? Done? ಈಗ ನೆಕ್ಸ್ಟ್ ಕಾನ್ಸಂಟ್ರೇಟ್ ಮಾಡಿ ಇಲ್ಲಿ ಜನರಲ್ ಫಾರ್ಮ್ಯಾಟ್ ಅನ್ನ. ಸೊ ದಟ್ ಇಸ್ ಆನೋಡ್ is actually give us the anode electrolyte and cathode. Clear? Heg baritev now? Representation means representation of an electrochemical cell. How to represent? So how you need to represent it now? So first, what is a general formula? Okay, I will give you people the general formula first. How you are going to represent general formula? First anode baratte, amel anode electrolyte anna martara. Okay, first you are going to write the anode. Anode nalli en reaction ide adu. This is actually called as a bar. Okay, idu on bar. Clear? So anode, then anode electrolyte. And oxidize agide alla adu anode electrolyte. So salt bridge, this is double bar means salt bridge it is going to be. Okay, ಆಮೇಲೆ ಏನು ಆಕ್ಸಿಡೈಸ್ ಆಗಿದಿಲ್ಲ ಅದನ್ನ ಬರಿಬೇಕು. ಈ ಆಕ್ಸಿಡೈಸ್ ಆದ ತಕ್ಷಣ ಏನಾಗುತ್ತೆ actually cathode electrolyte ಆಗುತ್ತೆ, right? So that is what I am writing it here, cathode electrolyte, and one again bar, and it is going to be a cathode. Clear? Then it will be a cathode. Tirita? Till I finish the classes, I will be there, Amma. Okay? Till I finish all the topics, class will be there. Okay? So, ಈಗ single vertical line ಗೆ ಏನಂತಾರೆ phase boundary ಅಂತ ಕರೀತಾರೆ. Clear? So, single ಅಂದ್ರೆ ಏನು ಕರೀತಾರೆ? Single vertical line. ಇದಕ್ಕೆ this thing is called as actually what? It's actually called as a phase boundary. Clear? And this is actually called as what? It's actually called as a salt bridge. Done? Okay. Now everything is clear with the representation. How to do the representation? We'll see the problems also on the representation later on. First, you people will discuss about some numerical problems also. Come on, try to answer this question. Let's see. How many of you can answer this question? Let's see. Ma'am, fast. Ellaru answer ಮಾಡಬೇಕು. ಗಾಯಬ ಆಗಿಬಿಡ್ತಾರಲ್ಲ ಏನಾದ್ರು ಮಲ್ಟಿಪಲ್ ಚಾಯ್ಸ್ ಕ್ವೆಶ್ಚನ್ ಕೇಳಿದ್ರೆ. Fast try ಮಾಡಿ answer ಮಾಡಲಿಕ್ಕೆ. What is the question they have asked it here? The study of an electrochemistry is mainly dependent on the concept of endothermic, exothermic, redox reaction and double displacement. We have used this word already. Fast answer ಮಾಡಿ. I'll give you people the 10 seconds. 10 seconds. Live is going on, no? Okay, try to answer this question. Let's see. See. Redox reaction, ah? ಅಯ್ಯೋ ಯಾರೋ ಲಾವಣ್ಯ ಬಂದಿದ್ದಾರೆ. Okay, redox reaction will be the answer. Okay, because electrochemistry is the only study of. Electrochemistry is the only study of. It's actually a study of what? Oxidation and reduction. It's a study of oxidation and reduction. Both together, if it's happening, then actually it is called as what? Redox reaction anta karitare adakke. Right? It's actually called as a redox reaction. Hi, Kirtana. Very good. Shashi, very good. Subhash, very good. Okay, next question try ಮಾಡಿ ನೋಡೋಣ. Which of, because yes, anode and cathode. Very good. Anode and cathode ಎರಡು participate ಮಾಡುತ್ತೆ. Anode ಅಂದ್ರೆ oxidation and cathode ಅಂದ್ರೆ reduction. Clear? Next question try ಮಾಡಿ. Which of the following is true about the electrochemical cell ಅಂತ ಹೇಳಿದ್ದಾರೆ. Oxidation occurs at the cathode. Okay. Oxidation is occurring at the cathode, which is true. Okay. Reduction is occurring at the anode. Okay. Electrons flow from anode to cathode and electrons flow from cathode to anode. First. Very good, Subhash. Ashok is telling A. How come it will be A, re? How come it will be A? ಹೆಂಗೆ ಆಕ್ಸಿಡೇಷನ್ ಇಸ್ ಆಕರಿಂಗ್ ಎಟ್ ಕ್ಯಾಥೋಡ್ ಇಟ್ಟೋದನ್ನ 20 ಸಲ ಹೇಳಿದೆ 20 ಸಲ ಹೇಳಿದೆ ಏನನ್ನೋದು ಬಿನಾ ಹೌ ಇಟ್ ವಿಲ್ ಬಿ ಬಿ ರಿಡಕ್ಷನ್ ಇಸ್ ಆಕರಿಂಗ್ ಎಟ್ ದ ಆನೋಡ್ ಆನೋಡ್ನಲ್ಲಿ ರಿಡಕ್ಷನ್ ಆಗ್ತಿದೆನಾ ಯಾಕ್ರೋ ಹಿಂಗ್ಯಾಕೆ ಮಾಡ್ತೀರಾ 3 yes lava is correct. That is electron is flowing from anode to cathode. ಎಷ್ಟು ಸಲ ಹೇಳ್ರಿ ಎಷ್ಟು ಸಲ ಹೇಳೋದು ನಿಮಗ ಆನೋಡ್ ನಲ್ಲಿ ಆಕ್ಸಿಡೇಷನ್ ಆಗ್ತಿದೆ ಕ್ಯಾಥೋಡ್ ನಲ್ಲಿ ರಿಡಕ್ಷನ್ ಆಗ್ತಿದೆ theta and electrons will flow from anode to cathode. Yes, electrons will flow from anode to cathode. So the option C will be the correct answer. That is 3. Okay. Next question, what is the main function of a salt bridge? Function of a salt bridge. Full channagi explain madidene. What is the function? Faster answer madi. What is actually the function of a salt bridge? What is the function of a salt bridge? Fast, what is the function of the salt bridge? AADD11, what is this? First one, to allow the ions to go from one cell to another. Yes, is it true? Ions anna help ಮಾಡ್ತಿದೆ ions ಗೆ from one cell to the another cell. Yes, it's correct. It is helping for the ions, the electrons to move from anode to the cathode. Run. Now to provide the link between the two half cell and to keep the EMF of the cell positive and to maintain the electrical neutrality of the solution in the two half cell. Come on. ಹೇಳ್ರಿ ನಾನು ಇದನ್ನ ಕೊಟ್ಟೆ. What is this? Hint ಕೊಟ್ಟೆ. ಹಿಂಟ್ ಕೊಟ್ಟಿದ್ದೇನೆ ಫಾಸ್ಟಾಗಿ ಆನ್ಸರ್ ಮಾಡಿ ನೋಡೋಣ ಹಿಂಟ್ ಕೊಟ್ಟಿದ್ದೇನೆ ಈಗ ಫಾಸ್ಟಾಗಿ ಆನ್ಸರ್ ಮಾಡಿ ಹಿಂಟ್ ಕೊಟ್ಟಿದ್ದೇನೆ ಈಗ it will Subhash is correct to maintain the electrical neutrality of the solution in two half cells. Okay, in two half cell to maintain its neutrality. Sariyagi electron anode inda cathode hoglappa stop agbardu en electron transfer ಆಗ್ತಿದೆ ಅಲ್ಲ where the oxidation is happening, no oxidation stop ಆಗಬಾರ್ದಂತ it will maintain. Salt bridge ಕೆಲಸ ಏನು, it will maintain. Clear? Option D is not correct because yes, tell Subhash. ಎದಕ್ಕಪ್ಪ ಕರೆಕ್ಟ್ ಇಲ್ಲ ಅನ್ನೋದು ಹೇಳಿ ನೋಡೋಣ. Option 1 is correct it seems. Okay, Subhash will tell me that why option 1 is correct and why option 4 is not correct. It allows the ions to go from one cell to another. That is true. The ions will not be. Okay, ions ಮಾಡಲ್ಲ ಅದು ಏನಾಗ್ತಿದೆ actually. They have given two half cell. Yes, two half cell ene iruttappa. two half cell only it will be present. Why? Because it is from anode to cathode. No, anode dinda cathode girutte, so it will be two half cells only. Okay, so it will allow to go from cell to yes, that is correct. Okay, it's allow ಮಾಡ್ತಿದೆ electrons, but other the main function adillalla. The main function is to maintain the neutrality of anode and cathode, right? That's what, this is what you people will get confused here, and you people will answer something else. Okay, ಇದನ್ನ mistakes ಅನ್ನ ಮಾಡಬೇಡಿ. Don't do this mistakes please. Okay, ನಾನು ಹೀಗೆ ಹೇಳ್ತಿದ್ದೇನೆ, don't do the silly mistakes. So ಏನು actually primary ಏನು ಹೇಳಿದಾರೆ main function ಕಾನ್ಸಂಟ್ರೇಟ್ ಮಾಡಿ ಇಲ್ಲಿ ಕ್ವಶನ್ ನಲ್ಲಿ ಏನು ಕೇಳಿದ್ದಾರೆ, ಮೇನ್ ಫಂಕ್ಷನ್ ಆಫ್ ಅ ಸಾಲ್ಟ್ ಬ್ರಿಡ್ಜ್ ಅಂತ ಕೇಳಿದ್ದಾರೆ. ಸೊ ಯು ನೀಡ್ ಟು ಸಿ ದ ಕ್ವಶನ್ಸ್ ಪ್ರಾಪರ್ಲಿ, ರೀಡ್ ದ ಕ್ವಶನ್ ಪ್ರಾಪರ್ಲಿ. ಓಕೆ, ಆಮೇಲೆ ಯು ಪೀಪಲ್ ನೀಡ್ ಟು ಆನ್ಸರ್ ಇಟ್. ಕ್ಲಿಯರ್? ಎಸ್ ಶಶಿ, ಯು ಆಲ್ಸೋ ಆನ್ಸರ್ಡ್ ಇಟ್. ಐ ಸಾ ದ ಶಶಿ, ನೋಡಿದೆ ಅಮ್ಮ, ನಾನು ನೋಡಿದೆ. Okay, next question. Try this everyone. The potential difference between the metal electrode and solution, metal electrode and a solution around it under equilibrium condition is actually called as an standard reduction potential, standard oxidation potential, redox potential and electrode potential. This is easy, no? Potential difference between the metal electrode and a solution under the equilibrium constant. Under the equilibrium constant. Idin try ಮಾಡಿ ಆನ್ಸರ್ ಮಾಡಲಿಕ್ಕೆ 10 seconds again. I'll give you 10 seconds again. Fast ಆಗಿ ಆನ್ಸರ್ ಮಾಡಿ, ಟ್ರೈ ಮಾಡಿ. We need to go fast. So it's taking too much time. Chemical kinetics jaldi ಮುಗಿಯುತ್ತೆ. Fast. ಏನಾಗುತ್ತೆ ಇಲ್ಲಿ? Okay, Subhash is telling option D. Okay, Shashi is telling option AE now. What is AE? Yes, that is correct, Subhash. That is electrode potential. The potential difference between the metal electrode and the solution. Metal electrode means potential difference ಇರ್ತದೆ. Okay, potential difference between the metal electrode ಮತ್ತೆ solution. Okay, metal electrode ಮತ್ತೆ solution under the equilibrium. ಎರಡು ಎದರಲ್ಲಿ ಹೋಗ್ತಿದೆ? Under the equilibrium. ಸೊ ಅವಕ್ಕೆ ಏನು ಕರೀತಾರೆ? ಎಲೆಕ್ಟ್ರೋಡ್ ಪೊಟೆನ್ಷಿಯಲ್ ಅಂತ ಕರೀತಾರೆ. ಕ್ಲಿಯರ್? It will be called as what? Electrode potential. Okay. Done everyone? Let's move to the next part now, that is galvanic cell. Okay, let's start with the galvanic cell now. So ಈಗ galvanic cell ಕೆಲಸ ಏನು? Okay, what is the work of the galvanic cell now? So it converts the chemical energy into the electrical energy. Galvanic cell ಕೆಲಸ ಏನು? It will convert the chemical energy into the electrical energy. What is the work of galvanic cell? Galvanic cell ಕೆಲಸ ಏನು? It's actually converts the chemical energy into the electrical energy. Chemical energy na electrical energy ge convert ಮಾಡುತ್ತೆ. Clear? Chemical to electrical ge. Yes, Subhash gave the first answer. Yes, physics sir came, Umma. Physics sir came and he will start the class very soon. Saturday physics class idella nimage. Saturday physics class is there, no? He will take it, okay? He will take the physics class. Hope so. Okay, let's start with the galvanic cell. So setup will be what? Two half cells will be connected by a salt bridge again. Anode is a site of oxidation, cathode is a site of a reduction again. So electrons will flow from anode to cathode and salt bridge will maintain the charge balance. And how the cell notation will be there? How the cell notation will be there? Simple cell notation ಹೇಳ್ತೀನಿ ನಿಮಗೆ about this. So how the salt notation. So cell notation ಹೇಗಿರುತ್ತೆ ಅಂತ Zn, yes, Zn plus 2 Cu plus 2 Cu. Okay, it is Cu plus 2 Cu. This will be the cell notation, and EMF is also equal to E naught cathode minus E naught anode. Clear? E naught is actually equal to E naught. Okay, 1 second. EMF in the work. EMF is actually equal to what? E naught cell or E naught cathode minus E naught anode. Clear? E naught cathode minus E naught anode. Theta. Okay, cool. Next comes some PU board questions which how they can ask you people. ಹೇಗದನ್ನ PU board questions ಅನ್ನ ಕೇಳಬಹುದು ಅನ್ನೋದು ಹೇಳ್ತೇನೆ ನಿಮಗೆ ನಾನು. How they will ask these questions. Very good, Shabash. Got a video now. Yes, ma'am. You got a video now. Okay. Others hangya. Avaginta kain questions try ಮಾಡಿ ನೋಡೋಣ. Try these questions, everyone. Okay, first question is a galvanic cell. The anode is the electrode where? In a galvanic cell, anode is the electrode where? Come on, try this question. Question try ಮಾಡಿ fast ಆಗಿ. Try it out, everyone. Fast answer ಹೇಳ್ಬೇಕು ಎಲ್ಲರೂ ಇದ್ರದ್ದು. Oxidation is going to occur. Yes, in a galvanic cell. The anode is going to be an electrode. Anode is going to be a electrode here. In a galvanic cell, anode is going to act like a electrode here. And that anode is going to act like a oxidation is going to occur. Anode means what? Anode means oxidation. Anode andre enappa? Oxidation. Clear? Next question. Okay, I have already ticked this question. That is in galvanic cell, electrons flow from anode to cathode. That was easy one. Okay. Next comes the reference electrode. Let's learn about the reference electrode now. That is, reference electrodes are used to measure the potential of the other electrodes. That is SHE setup will be there, where the platinum platinum electrode will be present, and H2 gas at a 1 atm pressure it will be acting. Okay, H2 gas at a 1 atm pressure it will be acting, and 1 mH plus solution will be present, and it is assigned as E0 is equal to 0 volt. E0 is going to act like an 0 volt. Clear? Next, SHE can also act as an both anode and a cathode. It's going to depend on the cell. It's going to depend on the cell. Clear? And other reference electrodes going to include in a calomel, that is also called as an Ag or AgCl. Ag or AgCl. Clear? Next, PU board questions. What type of questions will be actually asked? Okay, try this question everyone. The standard hydrogen electrode has a potential of SHE, that is SHE, standard electrode potential, SHE, E standard electrode potential nalli ಎಷ್ಟಪ್ಪ potential irutte. How much the potential will be present in this? Come on, try this. Try, fast. SHE, it will be having how much? We have discussed this. SHE is actually in how much volt? SHE actually is in the how much volt? Yes, very good. That is option C will be the correct answer. That will be at 0 volt. Eshtiruttappa 0 volt ge irutte. Clear? Next question. Which of the following is used as a reference electrode? Reference electrode hagi yavadana use ಮಾಡ್ತೇವೆ? Come on, just now our words na use ಮಾಡಿದ್ವಿ. Just now we have used that words. Come on, tell me, try. Fast try ಮಾಡಿ ನೋಡೋಣ. Which will be that? Platinum is a inert. What means platinum inert andre ಎದರಲ್ಲಿ use ಮಾಡ್ತಿದ್ಯಪ್ಪ ನೀನು? Where you are using it? ಜಿಂಕ್ ಎಲೆಕ್ಟ್ರೋಡಾ? ಈಗರ ಜಸ್ಟ್ ರೆಫರೆನ್ಸ್ ಎಲೆಕ್ಟ್ರೋಡ್ ಕಲ್ಸಿದೇನ್ರೋ ಮತ್ತೆ ಬಿ ಅಂತಾರಲ್ಲ. ಜಸ್ಟ್ ನಾವ್ ಐ ಹ್ಯಾವ್ ಟಾಟ್ ಇಟ್. ಎಲ್ಲ ಅಕ್ಷರ ಇರ್ತೈತೆ ನಿಮ್ಮದು. ಈಗ ಜಸ್ಟ್ ಹೇಳಿದೆನಲ್ಲ ರೆಫರೆನ್ಸ್ ಎಲೆಕ್ಟ್ರೋಡ್ ವಿಚ್ ಇಸ್ ಗೋಯಿಂಗ್ ಟು ಬಿ ಮೆಜರ್ಡ್ ಅಂಡ್ ಇಟ್ ಇಸ್ ಆಲ್ಸೋ ಕಾಲ್ಡ್ ಆಸ್ ವಾಟ್? ಕ್ಯಾಲಮೆಲ್. ದಟ್ ಇಸ್ ಆಲ್ಸೋ AG ಆರ್ AgCl. ಇಲ್ಲೇ ಇದೆಲ್ಲ ಆಪ್ಷನ್. ಕ್ಯಾಲಮೆಲ್ ಎಲೆಕ್ಟ್ರೋಡ್. ಹೌ ಇಟ್ ವಿಲ್ ಬಿ B? Yes, it is an inert catalyst. Platinum is an inert catalyst. Next question. Okay. Next we are going to start with the Nernst equation. Okay. Nernst equation I start madana. Then we have some questions of Nernst equation also. Let's be perfect with the Nernst equation now. So how to calculate, how to score 65 plus in chemistry, ma'am? Nan already video madidene hege score madkobeku 65 plus. So you can go and check that video in Vedantu Karnataka. Okay, Ravi? Naniga adin helalla. Will learn. First odona. ಆಮೇಲೆ ಹೇಗೆ 65 ಪ್ಲಸ್ ಸ್ಕೋರ್ ಮಾಡೋಣ ಅನ್ನೋದು ನೋಡೋಣ. ಇನ್ ಕೇಸ್ ನಿಂಗೆ ಅಷ್ಟು ಅರ್ಜೆಂಟ್ ಇದ್ರೆ ಈಗ ಹೋಗಿ ವಿಡಿಯೋನ ನೋಡ್ಬೋದು. ಓಕೆ, Nernst equation ಹೆಂಗೆ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡೋದು? ದಟ್ ಇಸ್ ಕ್ಯಾಲ್ಕುಲೇಟ್ಸ್ ಎಲೆಕ್ಟ್ರೋಡ್ ಪೊಟೆನ್ಷಿಯಲ್ ಅಂಡರ್ ದ ನಾನ್ ಸ್ಟ್ಯಾಂಡರ್ಡ್ ಕಂಡೀಷನ್ಸ್. ಫಾರ್ಮುಲಾ ಇಸ್ ಗೋಯಿಂಗ್ ಟು ಡಿಪೆಂಡ್ ಆನ್ ದ ಟೆಂಪರೇಚರ್, ಕಾನ್ಸಂಟ್ರೇಷನ್ ಅಂಡ್ ದ ನಂಬರ್ ಆಫ್ ದ ಎಲೆಕ್ಟ್ರೋಡ್ಸ್. ಇಟ್ ಈಸ್ ಯೂಸ್ಡ್. ಏನತ್ರದ ಯೂಸು? ಇಟ್ಸ್ ಆಕ್ಚುಲಿ ಯೂಸ್ಡ್ ಟು ಕ್ಯಾಲ್ಕುಲೇಟ್ ದ EMF of the cell at any condition. Clear? So it's going to depend on what? Temperature, concentration and number of the electrodes. Concentration, it is going to depend on concentration, temperature and number of electrodes. It's also going to depend on number of electrodes. Clear? Tirita? Yes. Now how you need to consider the Nernst equation? ಹೇಗನ್ನ Nernst equation ಅನ್ನ ಕನ್ಸಿಡರ್ ಮಾಡ್ಕೊಳ್ಳೋದು ಅನ್ನೋದು ಕಲಿಯೋಣ. ಓಕೆ, So Nernst equation, okay. So what is the meaning of a Nernst equation? We will learn it. The formula, because idr mele 100% one formula bidutte. You are going to receive one formula from this. Okay, one problem, numerical problem bidutte. So, yadappa the numerical problem. Nernst equation is actually helping us to calculate the electrochemical cell potential, right? That is also called as an E cell. E cell is actually called as what? Electrochemical cell potential. E cell is actually called as what? Cell potential, right? E naught cell andre enu? E naught cell andre enappa? E naught cell is actually called as what? Standard cell potential, right? So now how you are going to define the Nernst equation? That is E cell is equal to E cell is equal to E cell is equal to E naught cell minus E naught cell minus RT divided by NF, RT divided by NF, RT divided by substitute ಮಾಡ್ತೀನಿ ಹೇಳ್ತೇನೆ ಏನು ಆರು ಏನು ಇಲ್ಲತ್ತ ln Q, okay? Now idantu ತಿಳಿತು, right? So, ಈಗ we can even consider E cell is equal to E naught cell is equal to RT divided by NF as ln Q, or also we can write it in this. Okay, ಇದನ್ನ ಹೇಗಂತನೂ ಬರ್ಕೋಬಹುದು. We can even write it in, or we can even write it in E cell is equal to E naught cell minus 0.0591 0.059, yes, it is going to be how much? 0.0592 divided by n ln of q andre enu? Ln of q andre ಏನು ತಗೋಬಹುದು? log of 10q, okay? log of 10q ಅಂತನೂ ತಗೋಬಹುದು, okay? log of 10q, that is also at how much temperature? At 25 degrees Celsius nalli, or 298 Kelvin, okay? Or 298 Kelvin, clear? Subhash, is cathode, E naught cell is, okay, that is correct, okay? So E cell is going to be the cell potential, then standard cell potential, R is going to be the ideal gas. Iga 0.059 ಹೇಗೆ ಬತ್ ಮ್ಯಾಮ್? ಹೇಗೆ ಬಂತು 0.059? This has come. ಇದು ಹೇಗೆ ಬಂತು? How it got to know? Now RT divided by F. RT divided by F is actually equal to 0.0592. Okay, because why? R andre enappa? R we have a constant. R is actually a gas constant. We know already the gas constant value, right? That is 8.314, right? 8.314 into 298, or also we can take it as 25 degrees Celsius. 25 degrees Celsius, but most probably you should convert it only. Divided by F. F is actually called as what? Faraday's constant. F andre enu? Faraday's constant. 96,485. 96,485 coulomb. F is actually called as what? Illalla baradbidla. I'll write it down here. It's visible, no? R is called as an gas constant. T is called as an temperature. F is called as an Faraday's. It is actually called as an Faraday's constant. Okay. Oh, so sorry. I'm writing everywhere as contact. ಏನ್ರು ಒಂದು ಸಲಾನು ಹೇಳಿಲ್ಲ. F is equal to 96,500 ತಗೋಬಹುದು ಕಾನ್ಸ್ಟೆಂಟ್ ಅಂತ. ಕ್ಲಿಯರ್? ಹೇಗ್ ಬಂತಂತ ಗೊತ್ತಾಯ್ತಾ ಎಲ್ಲರಿಗೂ? ಓಕೆ, ತಿಳಿತಲ್ಲ? Now equilibrium ಹೇಗೆ ತಗೊಳ್ಳೋದು? Okay, how to take a equilibrium now? How we are going to consider the equilibrium? Means we need to understand about the equilibrium now. Okay, ಏನಪ್ಪ equilibrium? Equilibrium will show us the at what equilibrium it's actually happening. Means Q is equal to K, E naught cell, E cell is equal to 0 ತಗೊಂಡ್ರೆ. Okay, if in case equilibrium ನಲ್ಲಿ ಈ ಸೆಲ್ ಅನ್ನ ಏನ್ ತಗೋತೀರಾ? ತಿಳಿತಿದ್ದೇನಾ? Q ಅನ್ನ K ತಗೊಳ್ಳೋಣ. ಓಕೆ, ಜಸ್ಟ್ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಿ. Q ಜಾಗದಲ್ಲಿ ಯು ಆರ್ ಗೋಯಿಂಗ್ ಟು ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್. Q has a K. Q has a K and E naught cell has a 0. Okay, ಅದಕ್ಕೆ ಏನಾಗುತ್ತೆ? E naught cell 0 ಆದರೆ ಏನಾಗುತ್ತೆ? 0 is equal to, where is our formula? Okay, 0 is equal to E naught cell minus 0.0592 divided by n log of Q ಅಂದರೆ K ಅಂತ ಹಾಕಬೇಕು. log of 10 of K. Okay, log of 10 of K ಆಯಿತು. Done. Or it is also called as log 10 is also called as a ln 10 ಅಂತಾನು ಬರ್ಕೋಬಹುದು. We'll make it as a short ln K ಅಂತಾನು ಬರ್ಕೊಂಡ್ವಿ. Done. ಈಗ we know already that it is a 0. then E naught cell ಅನ್ನ ಈ ಕಡೆ ತಗೊಂಡ್ಬಿಡೋಣ. Right? E naught cell is equal to, E naught cell is actually equal to RT or 0.0592 divided by n ln K. Okay. Clear? ತಿಳಿತಾ equilibrium ದು? Hi Bhuvan. Understood everyone this much? Now next thing what you will do is question. Try to attempt this question now everyone. That is the Nernst equation is used to calculate. Nernst equation is actually used to calculate. First is pH of the solution, electrode potential under the non-standard condition, boiling point of the solution, conductivity of the electrolyte. Conductivity of the electrolyte. Come on. Answer. Let's see. How many of you will answer it? Try to answer this question fast. So the Nernst equation is actually used to calculate what? Yes, very good. That is electrode potential under a non-standard condition. Clear? So electrolyte Nernst equation ಅನ್ನ ಎದಕ್ಕೆ ಯೂಸ್ ಮಾಡ್ತೇವೆ? Okay, Nernst equation ಅನ್ನ ಎದಕ್ಕೆ ಯೂಸ್ ಮಾಡ್ತೇವೆ? We are using the Nernst equation because electrode potential under non-standard condition alli calculate ಮಾಡಬೇಕು. Okay? Electrode potential ಅನ್ನ calculate ಮಾಡಲಿಕ್ಕೆ ಯೂಸ್ ಮಾಡ್ತೇವೆ under what? Under non-standard condition. Under non-standard condition. Fast. Okay. Fast ಮಾಡೋಣ. Which of the following affects the electrode potential in the Nernst equation? ಯಾವುದು affect ಆಗುತ್ತೆ electrode potential in the Nernst equation? First is temperature, concentration of the ions, number of the electrons transferred, all of the above. Fast ನೀವು ಮಾಡ್ಬೇಕಲ್ಲ ಈಗ. ಹೇಳ್ರೋ fast ಆನ್ಸರ್ ಹೇಳಿ. Answer now, fast. Fast. answer ಮಾಡಬೇಕೀಗ. Temperature, concentration of ions, number of the electrons transferred, fast. Electrode potential in the Nernst equation. D. Very good. What is the answer? Option all of the above will be the correct. When it started, ma'am? It started very long back. Okay. See, what is that? All of the above. So, Nernst equation of electrode potential of the Nernst equation is going to depend on. It will depend on. ಎದ್ರ ಮೇಲೆ ಡಿಪೆಂಡ್ ಆಗುತ್ತೆ? It will depend on temperature, it will depend on concentration of ions, okay, and it will depend on number of electrons transferred. Clear? I'm telling fast only, no ma'am. Yes, Shashi, you all are telling me fast. Okay. Next comes the electrochemical series. So let's learn about the electrochemical series now. Electrochemical series andre enappa? So that is going to be arranged by a standard reduction potential that is also called as an E0 value. Now we just Nernst equation E0 kaltvalla, that is standard potential difference. That, okay, electrochemical series that is going to be arranged on the basis of standard reduction, that is also E0 value. E0 value will depend agutte. So what is actually the E0 value? That is standard value eniruttalla electrode potential do adar mele depend. Okay. Oh, bye, Subhash, I am also answering. Yes, Subhash, Shashi, you are also answering. Amma, ನೀನು answer ಮಾಡ್ತಿದ್ಯಾ. ನಾನು ನೋಡ್ತಿದ್ದೇನಲ್ಲ, ಬೇರೆದವ್ರು ನೋಡ್ಲಿ ಬಿಡ್ಲಿ, ನಾನು ನೋಡ್ತಿದ್ದೇನಲ್ಲ ಸಾಕು. Okay. Next, higher E0 is going to be a stronger oxidizing agent. ಅಕಸ್ಮಾತ್ E0 value ಜಾಸ್ತಿ ಇದ್ರೆ ಏನಾಗುತ್ತೆ? E0 value ಅಕಸ್ಮಾತ್ ಜಾಸ್ತಿ ಇದ್ರೆ ಏನಾಗುತ್ತೆ? The stronger will be the oxidizing agent. Clear? So if in case lower will be the E0, then stronger reducing agent it will be. Okay, it will be a stronger reducing agent. Clear? And use it to predict the redox feasibility and reactivity. So these are the from some series, okay, reaction oxidation from the some series are present, and they have given the E0 values also there. Okay, they have given the E0 values also there. You can see it here. All the E0 or V values are present. Okay, now try this question. Okay, once again I need to explain still the electrochemical series only for you people. Okay. So E naught cell ಏನಾಗುತ್ತೆ 3 ಎಲ್ಲರಿಗೂ use it to predict the before we go for the questions. Still you people need to understand few of the things about the electrochemical series. Okay. Okay. Electrochemical series ಬಗ್ಗೆ ಇನ್ನೊಂದು ಸ್ವಲ್ಪ ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್ ಮಾಡ್ಕೊಳ್ಳೋಣ. So that is what I will tell you people. What is meaning of an key concepts understand ಮಾಡ್ಕೊಳ್ಳೋಣ. That is standard reduction potential, that is also called as an E-torque. It is going to measure the tendency to gain the electrons. Okay. It is going to tell us about the gain the electron. That is also called as a reduction. Clear? It will tell us about the reduction. Then now ಈಗ ಏನಂದ್ರೆ ಸ್ಟ್ಯಾಂಡರ್ಡ್ ಹೈಡ್ರೋಜನ್ ಎಲೆಕ್ಟ್ರೋಡ್ ಅನ್ನ ರೆಫರ್ ಮಾಡ್ಕೋಬಹುದು. ದಟ್ ಇಸ್ ಆಲ್ಸೋ ಕಾಲ್ಡ್ as 0 ವೋಲ್ಟ್, ರೈಟ್? ಈಗ ಪೊಸಿಷನ್ ಎಲ್ಲಿರುತ್ತೆ, how it's been used. Okay, how it's been used, like it is going to predict the redox reactions. Okay, it's going to predict the redox reactions. Clear? It's going to predict the redox reactions. There is more reactivity, then negative E naught will be there, and it can dispose the ions from less reactivity to the, means negative and the positive ge displace ಮಾಡುತ್ತೆ. Okay, negative and the positive ge displace ಮಾಡುತ್ತೆ. Clear? Then it will even identify the oxidizing and reducing agent also. Okay, predict antu ಮಾಡ್ತು. I don't know how to put a bullet points. ಹಿಂಗೆ ಹಾಕೋಣ. Identifies the oxidizing, ಅಯ್ಯೋ ಆಕ್ಸಿಡೇಷನ್ ಬರ್ದ್ಬಿಟ್ಟೆ, oxidizing or reducing agent. It can even do that work. Done. Clear? And next it will even tell us about how to calculate the cell EMF. It will even tell us about calculation of cell EMF. Means what? Cell EMF andre enu? EMF is equal to E naught cathode minus E naught anode. ಇದನ್ನ ನಾನು ಹೇಳುತ್ತೆ. Clear? This also it will tell us. Then afterwards it will even tell us about the batteries and about the corrosion. It will even tell us about the corrosion ಅಂದ್ರೆ ಗೊತ್ತಿದೆಯಲ್ಲ, ರಸ್ಟಿಂಗ್. ಓಕೆ, ಅದ್ರ ಬಗ್ಗೆನೂ ಹೇಳುತ್ತೆ. Clear? What is the work of electrochemical series? Clear ಆಯ್ತಾ ಎಲ್ಲರಿಗೂ? Now you people solve this question now. ಇದು ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್ ಆಯ್ತಂದ್ರೆ you people can solve this question now. So which application uses the E naught values? Which application uses the E naught values? Come on. It is arrangement. Very good, Shashi. Shashi is answering everything. Hi, Rajesh. It will increase the strong. Yes, correct. Now you people try this question. Which application uses the E naught values? Predicting the redox feasibility, or calculating the molar mass, or determining the boiling point, or measuring the pH? Okay. A. Yes, it predicts the redox reaction. Why it predicts the redox reaction? ಶಶಿ ಇಸ್ ಲೈಕ್ ಒಂದೇ ಸಲ ಎನ ಹಾಕಲ್ಲಪ್ಪ, ನೀ ಇಟ್ಟು ಸಲ ಏನ ಹಾಕಿದ್ದಕ್ಕೆ ಶಶಿ ಇಸ್ ಗೆಟಿಂಗ್ ಲೈಕ್ ನಿಲ್ರಪ್ಪ ನಾನು ಒಂದು ಸ್ವಲ್ಪ ಆನ್ಸರ್ ಮಾಡ್ತೇನೆ ಅಂತ ಹೇಳ್ತಿದ್ದಾಳೆ. ಹಾಯ್ ವಿವೇಕ್. Okay, so there is a tough competition between Shashi and Subhash actually. One will answer and one will be shouting there. Okay, it is a predict in the redox flexibility. Okay, so because E naught value andre it is a standard, it is actually called as what? It's actually called as a standard electrode potential anta karitare idakke. Clear? E naught cell value andre standard electrode potential ಇದೆ ಆಕ್ಚುಲಿ, ರೈಟ್. ಬಟ್ ಇದ ಸ್ಟ್ಯಾಂಡರ್ಡ್ ಎಲೆಕ್ಟ್ರೋಡ್ ಪೊಟೆನ್ಷಿಯಲ್ ಅಲ್ಲಿ ಏನ್ ಆಕ್ಚುಲಿ ನಾವು ಮಾಡ್ತಿದ್ದೇವೆ, ವಾಟ್ ವಿ ಆರ್ ಆಕ್ಟಿಂಗ್, ವಿ ಆರ್ ಕ್ಯಾಲ್ಕುಲೇಟಿಂಗ್ ದ ಆಕ್ಸಿಡೈಸಿಂಗ್ ಅಂಡ್ ರಿಡ್ಯೂಸಿಂಗ್ ಏಜೆಂಟ್ ಅಲ್ಲಿ ಐಡೆಂಟಿಫೈ ಮಾಡುತ್ತೆ, ರೈಟ್. ಸೊ ದಟ್ ಇಸ್ ಸ್ಟ್ಯಾಂಡರ್ಡ್ ಎಲೆಕ್ಟ್ರೋಡ್ ಪೊಟೆನ್ಷಿಯಲ್ ಕೆಲಸ ಏನು, ಟು ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್ ದ ರೆಡಾಕ್ಸ್ ಫಿಸಿಬಿಲಿಟಿ. ರೆಡಾಕ್ಸ್ ಫಿಸಿಬಿಲಿಟಿ ಅಂದ್ರೆ ಏನು, ಡೋಂಟ್ ಗೆಟ್ ಕನ್ಫ್ಯೂಸ್ಡ್ ಇನ್ ಬಿಟ್ವೀನ್ ರೆಡಾಕ್ಸ್ ಫಿಸಿಬಿಲಿಟಿ. ರೆಡಾಕ್ಸ್ ಫಿಸಿಬಿಲಿಟಿ ಮೀನ್ಸ್ ಅಬೌಟ್ ದ or about the reduction. Always healthy competition wins. Let's see how much healthy competition you people have. Okay. Next question, why is Zn used to protect Fe from corrosion? Why is Zn used to protect Fe from corrosion? This is very easy. Electrolytic series anna chennagi nodidre niಮಗೆ ಗೊತ್ತಾಗುತ್ತೆ. See, Shashi is laughing. Healthy winning ಇರುತ್ತಲ್ಲ. Let's see how much healthy winning you people have. First option is Zn is heavier. Second option is Zn has a higher melting point. Third option is Zn has a lower E naught, acts as a sacrificial anode. Then Zn is a non-metal. Zn is a non-metal. Fast. Try ಮಾಡ್ರಿ. ಸಿ ಲಕ್ಷ್ಮೀನು ಬಂದ್ಲಲ್ಲ ಹೆಲ್ದಿ ಕಾಂಪಿಟೇಷನ್ ಅಲ್ಲಿ. That is going to be what? Zn has a lower E naught. It is going to act like an sacrificial anode according to the electrolytical series. Clear? According to the electrolytical series. See, ಈಗ ನೋಡಿ ಒಬ್ಬೊಬ್ಬರು ಬರೇ ಒಂದೇ ಸಲ ಆಪ್ಷನ್ ಹೇಳ್ತಾರೆ. Yes, Subhash won. Next comes the application of electrochemical series. So that is, it is going to predict the flexibility of the redox reaction. It is going to designing the electrochemical cells. So designing of the electrochemical cells andre ಯಾವ್ದು anode ಅನ್ನು ಯೂಸ್ ಮಾಡಬೇಕು, ಯಾವ cathode ಅನ್ನು ಯೂಸ್ ಮಾಡಬೇಕು ಅನ್ನೋದು ಹೇಳುತ್ತೆ. ಆಮೇಲೆ corrosion prevention ಅನ್ನು ಮಾಡುತ್ತೆ. Like in case now you people know, if you are going to take a metal, ನೀವು ಇದರಲ್ಲಿ ಡಿಪ್ ಮಾಡಿ ಯಾವ್ದಾದ್ರು ಸೊಲ್ಯೂಷನ್ ಅಲ್ಲಿ ಡಿಪ್ ಮಾಡಿಟ್ರೆ it might get rust also, right? So it's going to get rusted some other day, right? So ಅದು prevention ಮಾಡುತ್ತೆ. Then metal displacement reaction ಆಗಬಹುದು. So there will be a displacement of the metal also. Okay, ಯಾವ್ದು ಮೆಟಲ್ ಅನ್ನ ಯೂಸ್ ಮಾಡಿದ್ದಾರೆ, ಯಾವಾಗ ನೆಸೆಸಿಟಿ ಇದೆ ಅದರದ್ದು ಮೆಟಲ್ದು, ಸೊ ಅವಾಗ ಅದನ್ನ ಡಿಸ್ಪ್ಲೇಸ್ ಮಾಡಬಹುದು, ಆಯ್ತಾ. ಅಂಡ್ ಸೆಲೆಕ್ಷನ್ ಆಫ್ ಅ ಸುಟೇಬಲ್ ಎಲೆಕ್ಟ್ರೋಡ್ಸ್, ಎಸ್ ಯು ಕ್ಯಾನ್ ಸೆಲೆಕ್ಟ್, ಮೋಸ್ಟ್ ಪ್ರಾಬಬ್ಲಿ ದೇ ವಿಲ್ ಯೂಸ್ ಇಟ್ PT ಓನ್ಲಿ. ಯಾವಾಗಲೂ ಪ್ಲಾಟಿನಮ್ ಅನ್ನ ಯೂಸ್ ಮಾಡೋದು, ಬ್ಲಾಕ್ ಪ್ಲಾಟಿನಮ್, ಬಟ್ you can select it also, depends on that what type of a reaction we are doing it. Next, one more question. Which application uses the E naught values? Which application uses the E naught values? First, E naught values ಯಾವ application ಮೇಲೆ ಆಗುತ್ತೆ? Fast ರೋ, ಇನ್ನ ಒಂದು ಲೆಸನ್ ಇದೆ. BBBB na calculating molar mass hegappa. It's predicting the redox flexibility. Okay. Why Zn is used to Fe corrosion? Zn is heavier. Zn is higher melting point. Zn has a, this also discussed no already. Yes. What does the reaction coefficient represent? One second, guys. Let me see where we are. Okay. Next we'll go, that is conductance of an electrolytic solution. So here what happens is electrolytes is going to dissociate. Electrolyte is going to get dissociated. Okay. Electrolyte, conductance of electrolyte andre eno? Electrolytes are going to dissociate into the ions in solution, allowing the electrical current to pass. Yes, if in case it is going to dissociate the ions, solutionally ions dissociate adva. Solutionally dissociate ions ad bandre electric current anna pass ಮಾಡಬಹುದು easy ಆಗಿ. Electrical current anna pass ಮಾಡಬಹುದು easy ಆಗಿ. Clear? Yes, Sashi, that is also correct, Amma. Okay. Repeated questions there were, so I didn't stop it there. Okay. Next, conductance is a easier with which current flows through the solution. So, it is going to depend on what? Nature of the electrolyte, whether it is going to be a strong or a weak, then concentration of the ions. So what type of ions, what type of concentrated ions you are going to use it, it will depend on that also. Which type of concentrated ions you are going to use it, it will depend on that also. You will have 2 marks question, okay. It is going to depend on the temperature also. It's going to depend on the temperature also. Then solvent viscosity, it's going to depend on the solvent viscosity and the dielectric constant constant. Clear? Next comes the Ohm's law. This is also important, Ohm's law. That is V is equal to IR, and V is going to be the potential difference. I will be the current and R will be the resistance, and it applies the both metallic and electrolytic conductors, and the electrolytes resistance arises due to the collisions and the solvent drag. It is going to do the solvent drag also. Clear? It will do the solvent drag also. Okay. Next, measurement of the conductivity of an ionic solution. That is, conductivity is going to be measured in the Wheatston's bridge type. So that is also got a setup of AC sources to avoid the electrolysis. It is also a alternative sources in use ಮಾಡ್ತಾರೆ because alternative source in use ಮಾಡ್ತಾರೆ. Yes, Subhash, correct. So ಅದರ ಸಲುವಾಗಿ because to avoid the electrolysis ಆಗಬಾರದಂತ EC ಅನ್ನು ಯೂಸ್ ಮಾಡ್ತಾರೆ. Then electrodes are usually a platinum coated with a platinum black. Just now I told you, usually they will use this only, which is actually a platinum black and which will be coated up with the black. Okay, and the solution is placed in the conductivity cell with the known as cell constant. Okay, that is also called as a G, and the conductance G is measured and conductivity K is going to be calculated as K is equal to G into G star. Okay, G into G star. This is how the conductivity cells will be present. So, ee tara conductivity cells, I don't think so it's visible properly. So, conductivity cells ide, platinum PT electrode connected ide eradu side. So, connecting wires and platinum PT electrodes. Done. Okay, we have lots of equivalent conductance and understand ಮಾಡ್ಕೊಳ್ಳೋಣ. That is equivalent conductance K into 1000 C. That is concentration is in the equilibrium. Unit will be S centimeter square per equilibrium. S centimeter square per equilibrium. Clear? So now let us see what type of questions will be asked in this chapter. ಯಾವ type of questions ಕೇಳ್ತಾರ ಅನ್ನೋದು ನೋಡೋಣ. Okay. First question is about write the Nernst equation. We already written the Nernst equation according to that. I have already explained the Nernst equation to you people. Nernst equation ಬಗ್ಗೆ question ಕೇಳ್ತಾರೆ 2 marks ಗೆ. Done. Next is write the Nernst equation for the Daniell cell. According to the Daniell cell you need to write it. Okay. Daniell cell nothing simple. Just they will give the equation. According to that you need to just substitute it. Okay. Log of C and log of means ಏನು ಕೊಟ್ಟಿರ್ತಾರಲ್ಲ reactant side ನಲ್ಲಿ ಅದನ್ನ ಬರ್ಕೋಬಹುದು. Zn ಅಂದ್ರೆ Zn Cu ಅಂದ್ರೆ Cu ಅದನ್ನ ಬರ್ಕೋಬಹುದು ಅಷ್ಟೇ. That's it. Next comes represent the cell in which the following reaction is going to take place. So they have told us to represent the cell where the following reaction is going to take place. Concentrate everyone now here how this is going to be solving. Yes, I have not taught till the first law and all law. I am discussing right now ಏನು ಕಾನ್ಸೆಪ್ಟ್ಸ್ ಕಲಿಸಿದಲ್ಲ ಅದ್ರ ಬಗ್ಗೆ ಯಾವ ಥರ ಕ್ವಶನ್ಸ್ ಕೇಳಿದಾರೆ ಅನ್ನೋದು ಹೇಳ್ತೇನೆ and then we'll go for the first Faraday's law and all. Okay, I'm not running and going anywhere. ಯಾವ ಥರ ಕ್ವಶನ್ ಕೇಳಿದ್ದಾರೆ ಆ ಕಾನ್ಸೆಪ್ಟ್ ಮೇಲೆ ಫಸ್ಟ್ ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್ ಮಾಡ್ಕೊಳ್ಳೋಣ. Nernst equation ಮೇಲೆ ಪ್ರಾಬ್ಲಮ್ ಸಾಲ್ವ್ ಮಾಡಿಲ್ಲಲ್ಲ ನಾವು ಅದಕ್ಕೆ. ಓಕೆ, we'll solve then afterwards Shashi will go for the first law. Okay, I have that also, don't worry. So represent the cell in which the following reaction is going to take place. Mg plus 2g is going to form what? Mg plus 2 and 2g. Clear? Our equation avare kottidare. Done. Our equation anna kottidare. Clear? They have told us to calculate its E naught cell if E naught cell is going to be 3.17 volt. Okay. E naught cell value kottidare illi. E naught cell value kottidare. 3.17 volt. The cell can be written as Mg. So Mg andre enappa? Cathode, phase boundary, then afterwards cathode electrolyte, and then anode electrolyte, then the cathode electrolyte, then the cathode. Done? That is clear. Then they have told us to calculate the E cell. Okay, E cell anna calculate ಮಾಡ್ಲಿಕ್ಕೆ ಹೇಳಿದ್ದಾರೆ. So we know already the formula of E cell. What is the formula of E cell? E cell is equal to E naught cell minus 2.303 RT divided by 2F. Why we are going to take it as a 2F? Why? Because they have only given us the N value, that is going to be 2, 2, 2, 2, 2. That is what we have substituted here. So log of Mg plus 2 divided by Mg plus 2 divided by Ag plus. Okay, Ag plus 2. Done. Now you people need to just substitute the values here. Okay, some tips of lab exam. Yes, I'll tell Amma. I'll tell lab exam also tips. So by the way, when is your lab exams? When you people have a lab exams? So that is E naught cell value in kottidare 3.717 kottidare. Just substitute it. 3.17 anna substitute ಮಾಡಿ. Done. So this value already we know. Idar value already ಗೊತ್ತಿದೆ ನಮಗೆ. Right? So that is what we are going to write it. That will be what? 0.059 divided by 2 log of ಅದ್ರದ್ದು value ಕೊಟ್ಟಿದ್ದಾರೆ. That is 0. This is the value of Mg plus 2 and this is the value for Ag plus 2. Clear? So adradu ella substitute ಮಾಡ್ಕೊಳ್ಳೋಣ. 0.130 divided by 0.0001. Done. 3.17 minus, so ಎರಡತ್ರನ್ನು ಡಿವೈಡ್ ಮಾಡಿ ಫಾಸ್ಟ್ ಆಗಿ ಆನ್ಸರ್ ಹೇಳಬೇಕು. ನನಗೆ 0.21 ಬರುತ್ತೆ ಆಕ್ಚುಲಿ. ಅನ್ಕಾಸ್ ನಿಮ್ಮದು ಬರ್ತಿಲ್ಲ ಅಂದರೆ ಇನ್ನೊಂದ್ಸಲ ನಾವು ಚೆಕ್ ಮಾಡ್ಕೊಳ್ಳೋಣ. You people can tell me how it is going to be coming. ಈಗ you people know how to find the antilog. How to find the antilog? How to find the antilog, you people know? Antilog ಹೇಗೆ ಫೈಂಡ್ ಮಾಡೋದು? So you know already the formula, right? Y is equal to antilog B. How to calculate the log values? I'll tell you people how to calculate the log values, but you people need to know one more thing here. See, ನಿಮಗೆ ಇಲ್ಲಿ 1 log ದಿಂದ you should know the value of log 1 to log 10. Okay, ನಿಮಗೆ ಯಾವಾಗ log 1 to log 10 ವ್ಯಾಲ್ಯೂ ಗೊತ್ತಾಗುತ್ತಲ್ಲ ಅವಾಗಟ್ಟೆ ಈಸಿ ಆಗುತ್ತೆ ನಮಗೆ ಫೈಂಡ್ ಮಾಡಲಿಕ್ಕೆ. ಓಕೆ, now what is actually how to find the antilog is you are going to reverse the logarithm process. Okay, if in case you have a log b, like log b or else like general like ತಗೊಳ್ಳೋಣ. Okay, let us consider as generally log b ನಕ್ಕ y this is equal to x anta generally ತಗೊಳ್ಳೋಣ. Okay, we need to find this. Then y it will be what? Y is equal to antilog of bx. Okay, ಇಲ್ಲಿ antilog ನಲ್ಲಿ ಏನಾಗುತ್ತೆ? Y is equal to antilog of by. Okay, antilog of bx. ತಿಳಿತಿದೆನಾ? Okay, sorry, x ಬರುತ್ತೆ ಇಲ್ಲಿ. Clear? Antilog of bx anta find ಮಾಡಬೇಕು. Done. So now you can calculate it easily in the form of like anything, like anything you take. Base ಏನಿದೆ ಯಾವುದು ತಗೊಳ್ಳೋಣ, log n ಇಲ್ಲದ್ರೆ log 2 ಏನು ತಗೊಳ್ಳೋಣ. Okay, let us take one simple example. ಇಲ್ಲೇ ಕೇಳೋಣ, ನೋಡೋಣ how it's been find. ಇಲ್ಲೇ ಮಾಡೋಣ first ದ್ದು. So log of 0.130 divided by 0.00001. Tell me fast. Let me check it in the calculator. So na calculator nalli check ಮಾಡ್ತಿದ್ದೇನೆ. Don't sit and new answers ಹೇಳಿ ನಂಗೆ ಫಾಸ್ಟ್ ಆಗಿ ಆನ್ಸರ್ಸ್ ಹೇಳಿ ನೋಡೋಣ. ಬುಕ್ ನೋಡ್ಕೊಂಡಿಲ್ಲಮ್ಮ, ಬುಕ್ ನೋಡ್ಕೊಂಡು ಏನು ಮಾಡೋದು ನೆಸೆಸಿಟಿ ಇಲ್ಲ. ಯು ಕ್ಯಾನ್ ಡೂ ಓನ್ಲಿ ಒನ್ ಥಿಂಗ್, ಯು ಕ್ಯಾನ್ ಈಸಿಲಿ ಫೈಂಡ್ ಇಟ್ ವಿತ್ ದ ಹೆಲ್ಪ್ ಆಫ್ ದ್ಯಾಟ್ ಆಲ್ಸೋ. log 1 to log 10 ಬ್ಯಾಟ್ ಮಾಡ್ಕೊಂಡು ಇಟ್ಕೋರಪ್ಪ, ಬಿಕಾಸ್ ಎಲ್ಲ ಥರ ಬುಕ್ ಕೊಡಲ್ಲಲ್ಲ ನಿಮಗೆ. ಡಿವೈಡೆಡ್ ಬೈ 0.0001 1300 ಆಗುತ್ತೆ. ದಟ್ ವಿಲ್ ಬಿ ಹೌ ಮಚ್? ಓ ಸಾರಿ, ದಟ್ ಇಸ್ ಲಾಗ್ ಆಫ್ 1.3 ಅನ್ನ ಅಂತ ಫೈಂಡ್ ಮಾಡ್ಬೇಕು ನಾವು ಆ್ಯಕ್ಚುಲಿ. ಓಕೆ, okay, like this you should find it. Now you people just divide it. ಹೇಗೆ ಡಿವೈಡ್ ಮಾಡೋದು? ಡಿವೈಡ್ ಮಾಡ್ಕೋಬೇಕು. ಲಾಗ್ 1 ಮತ್ತು ಲಾಗ್ 0.3 ಅಂತ ಡಿವೈಡ್ ಮಾಡ್ಕೋಬೇಕು ಅದನ್ನು. ಓಕೆ, ಪಾರ್ಟ್ಸ್ ಮಾಡ್ಕೋಬೇಕು ಅದರದ್ದು. ದೆನ್ ಅಗೇನ್ ಯು ಯೂಸ್ ದ ನಾರ್ಮಲ್ ಫಾರ್ಮುಲಾ. ಓಕೆ, ನಾರ್ಮಲ್ ಫಾರ್ಮುಲಾನ ಯೂಸ್ ಮಾಡಿಬಿಡಿ ಅಷ್ಟೇ. log value calculate ಮಾಡ್ಲಿಕ್ಕೆ ಬರಲ್ಲ. log value people need to see the value in your log book and then you need to write it. ಅದಕ್ಕೆ ಹೇಳಿದ್ನಪ್ಪ ನಾನು, ಇಲ್ಲಿ ಅದನ್ನೇ ಹೇಳಿದ್ನಲ್ಲ, ಇಲ್ಲಿ ನೋಡಿ ಅದನ್ನೇ ಹೇಳ್ದಲ್ಲ ನಾನೀಗ. ಸಿ log 1 to log value you need to know the values of this. You need to have a value idea. ಏನಿದೆ log 1 ಮತ್ತು log 10 ತನಕ ಏನು ವ್ಯಾಲ್ಯೂ ಇದೆ ಅಲ್ಲ, ಅದು ಲಾಗ್ ನೀವು ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್ ಮಾಡ್ಕೋಬೇಕು ಫಸ್ಟ್. ಓಕೆ, ಅದನ್ನು ಜಸ್ಟ್ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡ್ಕೊತ ಹೋಗೋದು ಈ ಜನರಲ್ ಫಾರ್ಮುಲಾದಲ್ಲಿ. ಓಕೆ, ಆಂಟಿಲಾಗ್ನಲ್ಲಿ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡ್ಕೊತ ಹೋಗೋದು ಅಷ್ಟೇ. ಥೀಟಾ. Okay, this is one problem they have asked. Calculate the EMF of the cell in which in which the following reaction is going to take place: Ni2G, Ag, and then so all values you just need to substitute. Same other, there are lots of problems they have asked about the equilibrium constant also they have asked it. So equilibrium constant, just now we have found the formula for the equilibrium constant also. Yes, perfect, Shashi. Shashi has done one problem. See the Shashi's message. She has done it already one. Kirita Largo, calculate the equilibrium constant of the reaction, that is Cu plus 2Ag plus, and then Cu plus and 2Ag, that is E naught cell will be what? 0.46 volt kottidare. So just you need to substitute it in the equilibrium constant. Okay. So idon standard EMF value nu kottidare. You can find this also, same problem ne 2 sala helidare. Next, standard electrode potential about Daniel cell is being discussed. Iga nano, let's discuss about. Wait 1 second, guys. We need to discuss about Faraday's law, right? Yes, we didn't discuss about the Coherell's law, that is also independent migration of the ions. So we'll discuss about this also today. So because we had skipped this thing, means ಇದನ್ನ ಮಾಡಿಲ್ಲ, ಡೀಟೇಲ್ ಆಗಿ ಕಲ್ತಿಲ್ಲ. ಓಕೆ, ದ ಲಾ ಆಫ್ ಲಿಮಿಟಿಂಗ್ ಮೋಲಾರ್ ಕಂಡಕ್ಟಿವಿಟಿ ಆಫ್ ಎನ್ electrolyte can be represented by the sum of the individual contribution of an anion and an electrode. Okay, it's going to be what? It's going to be a limited contribution of anion and a cation of the electrolyte. Anion and the cation of the electrolyte. Clear? So Coherell's law andre eno, it is going to be dependent on the migration of the ions. Okay, it's going to be dependent on the migration of the ions, that is of contribution of anion and a cation electrolyte. Anion and a cation electrolyte. Clear? If in case lambda naught Na plus and lambda naught Cl minus are limiting molar conductivity of a sodium and chloride ions respectively, then limiting molar conductivity of sodium chloride is going to be given by what? Equation. Clear? ಇದು ಒಂದು 2 marks ಕೇಳಬಹುದು. Not she, he. Yes, ma'am, it is an important question. Yes, important question. Yes, we had skipped about the Faraday's law, no? Ignore. First law andre enu? First law means the amount of a chemical reactions which is going to occur at any electrode. It's going to occur at any electrode during the electrolysis by the current is. When the current is actually proportional to. When the current is actually proportional to. Current is actually proportional to the quality of the electricity passed. Electricity ಎಷ್ಟನ್ನ pass ಆಗಿದೆ ಅದರ ಮೇಲೆ depend ಆಗುತ್ತೆ. How much it is passed. How much passed. Clear? How many Faradays of electricity is been required for the reduction? There is 1 mole of Ag plus, 1 mole of Mg plus 2 and 1 mole of Al plus 3. According to that you can calculate it. Okay. Then lead storage battery or lead acid battery also is important. Okay. These are the few important questions which actually been going to ask in the chemical kinetics. Okay. Sorry, chemical kinetics anta electrochemistry. So ಈಗ start ಮಾಡೋಣ chemical kinetics. Because chemical kinetics jaldi ಮುಗಿಯುತ್ತೆ. We can finish the chemical kinetics. Full name is Shashikant. Oh, ನಾನು ಅವಾಗಿಂದ ಹುಡುಗಿ ಮಾಡಿದ್ದೆ. ನಾನು ಅವಾಗಿಂದ ನೀ ಹುಡುಗಿ ಅಂತ ತಿಳ್ಕೊಂಡ್ಬಿಟ್ಟಿದ್ದೆ. I was thinking you are a boy. You are a girl ಯಾಕರಿ. Oh, so sorry pa. So sorry. Very bad. My bad actually, not very bad. My bad actually. Okay, then let's start with the chemical kinetics. Let's not waste time. Have you mature this time, ma'am? Have you mature this time, ma'am? What is that? Lead storage battery didn't discuss. I have discussed only one question about lead battery. Okay, lead battery discussion madidene question though. Okay, let's start with the chemical kinetics. So chemical kinetics is the first thing you should know is about the chemical kinetics is rate of the chemical reaction. That is the rate of the reaction in which the, one second, do one thing. So rate of the chemical reaction, how it is going to be described. Hey, describe madbodu rate of the reaction anna. So rate of the reaction is also be described as change in the concentration of any one reactant or a product. Okay, any one reactant or a product per unit time. Okay, per unit time. Change in any, okay, means the change. Okay, change in any concentration of reactant or product. Okay, reactant illadre product per unit, reactant or product by per unit time is actually called as what? Rate of reaction. Adokke enanta karitare? Rate of reaction anta karitare. Clear? Iga next, rate is actually formula comes what? Decrease in the concentration of the reactant. So rate anna hege define madbodu? That is decrease in rate reaction. Okay, decrease in the, so it is going to be decrease in the concentration of the reactant divided by, okay, divided by time taken. How much time it is taken actually for that. Okay, time taken. Time taken. Clear? So that is increase in the concentration of the product divided by time taken. So that also can be told as what? Rate is equal to increase in concentration of product, okay, divided by time taken, divided by time taken. Clear? Divided by time taken. Clear? Everyone understanding? Nilrappa neer kodiyona ಸ್ವಲ್ಪ. Very good, Shashi, very good. Okay, now what we are going to do, we are going to consider now. Okay, we will consider few things. We will consider the few things. So consider the hypothetical reaction now one. Okay, let us consider one hypothetical reaction. Consider hypothetical reaction one, consider ಮಾಡ್ಕೊಳ್ಳೋಣ. That is what? A gives us B, means any of the reactant is giving us the product anta ತಿಳ್ಕೊಳ್ಳೋಣ. Okay, that time how the rate will be? Rate will be how can you define the rate at that time? That is going to be rate is equal to delta A divided by how much the time it has been taken. That is called as delta T plus delta B and delta T. Clear? So according to what? Consideration of the hypothetical reaction. According to the consideration of hypothetical reaction. Clear? Now let us consider average and instantaneous rate of reaction. Idu hypothetically aitu. Okay. Hypothetically aitu. Now we'll consider the things on the basis of average and instantaneous rate of reaction. In case average and instantaneous, am I correct? Instantaneous, S-T-A-N-T-A-N-E ಬರಬೇಕಲ್ಲಪ್ಪ. Instantaneous, okay, average and instantaneous rate of reaction. Okay, ಆ ಟೈಮ್ದಲ್ಲಿ ಏನಾಗುತ್ತೆ? At that time, what is gonna happen? So what is going to happen at instantaneous, at the average and the instantaneous rate of reaction? The rate of change in the concentration at any reactant or product is going to give by an interval of time. Okay, it's going to be given by an interval of a time. Okay, ಇಲ್ಲಿ ಬರೆದ್ಬಿಡೋಣ. Rate of anything, rate of change in concentration reactant or a product. Okay, reactant or a product, reactant or a product for a given interval of time. Okay, for a given interval of time. Okay, that is known as what? Average rate of reaction. Clear? If in case we can take this example also as like R is giving us the product, means reactant is actually giving us the product anta tilkolona. So what will be the reactive? Okay, what will be the RAV? ಏನಿರುತ್ತೆ RAV? Means average instantaneous reaction ಏನಾಗುತ್ತೆ? Average instantaneous reaction will be what? I2 okay, average instantaneous reaction will be what? R2 minus R1 divided by T2 minus T1. Right? R2 minus R1 divided by T2 minus T1. Sorry, we should take T2 minus T1. Okay, that is time. No, time togotidavalla, temperature togotilla adukke. Okay, that also can be written as delta R divided by delta T. Em barkobodu idana? Delta R matte delta T anta ಬರ್ಕೋಬಹುದು. ಕ್ಲಿಯರಾ? ಮ್ಯಾಮ್ ಮೈನಸ್ ಮೈನಸ್. ಓಕೆ ಮ್ಯಾಮ್. ಎಸ್. It will be minus. I forgot to write the minus. Thank you so much for reminding me. Okay, thank you so much for reminding. Clear? So for that we have a graph also. So this is the graph how it's going to work according to the time. Hey, increase with the temperature. Concentration of the reactant versus time. Concentration of the reactant versus time, which is not visible for you people. I'm so sorry. Which is not visible clearly for you people. I can see it. Can't tilva. It's okay. It's there in your NCERT book. You can just refer there. Okay. R2 and R1 ಏನು ಕನ್ಸಿಡರ್ ಮಾಡ್ಕೊಳ್ಳೋದು ಅಂತ ಗೊತ್ತಾಗುತ್ತೆ ಅಷ್ಟೇ. Okay. Now let us move for main important thing, that is factors which are influencing the rate of the reaction. Which are the factors which are actually influencing the rate of the reaction? ಯಾವ್ದಪ್ಪ reaction factors ಇದೆ, ಯಾವ್ದು influence ಮಾಡುತ್ತೆ, which is going to influence the rate of the reaction. Okay, which will influence the rate of the reaction. First one is going to be the concentration. So concentration the kelsa enu, what will be the work of the concentration? That is rate of the reaction is actually directly proportional to. So concentration the kelsa enu, What is the work of the concentration? Concentration the ಕೆಲಸ ಏನು ಮಾಡುತ್ತೆ? It will work as has. It is going to work as how? The rate of the reaction is directly proportional to, okay? Rate of reaction is directly proportional to. It is going to be directly proportional to the concentration of the reactant. ಯಾವ ತರ concentration ಅನ್ನು ಯೂಸ್ ಮಾಡಿದೇವಲ್ಲ, that concentration of a concentration of the reactant, okay? Now, according to that concentration of the reactant is going to start decreasing, or that of the products is going to increase. Means, our concentration of the reactant enaguttalla, this concentration of reactant will decrease. Means, reactant will decrease, then obviously, okay, obviously ಏನಾಗುತ್ತೆ? obviously ಏನಾಗುತ್ತೆ ಇಲ್ಲಿ? Product increase ಆಕೊಂತ ಹೋಗುತ್ತಲ್ಲ, product will start increasing, right? This is due to the course of the time, and the rate of the reaction also will decrease. Rate of the reaction will also decrease. So product will start increasing. Product will start increasing, right? Product start ಆಗ್ತದೆ increase ಆಗ್ಲಿಕ್ಕೆ, because of the reactant is actually getting decreased, right? Reaction ಅಕಸ್ಮಾತ್ concentration of the reactant decrease ಆಕೋತ ಹೋದ್ರೆ, product increase ಆಕೋತ ಹೋದ್ರೆ, it is going to, in the course of the time ನಲ್ಲಿ, okay? On the course of the time, on the course of the time, rate of the reaction is also starts decreasing. ಅದರ ಸಲುವಾಗಿ rate of the reaction ಅನ್ನು decrease ಆಕೊಂತ ಹೋಗುತ್ತೆ. It will actually decrease. Clear? It will start decreasing. Clear? It will start decreasing. ತಿಳಿತಾ? Next comes the, so what does actually the temperature is doing? Okay, temperature the ಕೆಲಸ ಏನು? Temperature ಏನು ಮಾಡ್ತಿದೆ ಅನ್ನೋದು ನೋಡೋಣ. If you study 3 model question papers, then you can pass ಅಪ್ಪ. ಬರೇ ಪಾಸ್ ಅಷ್ಟೇ ಆಗ್ಬೋದು. ಅಕಸ್ಮಾತ್ ನೀ ಬರೇ model question papers ಅನ್ನ ನೋಡ್ದಂದ್ರೆ you can just pass, okay? So what happens with the temperature? Rate of the reaction is going to increase. The rate of the reaction is going to increase, okay? Rate of the reaction is going to increase. Rate of the, it's going to increase with increase in the temperature. Rate of the reaction increase agutte if you are, okay? If you are increasing the temperature. If you are increasing the temperature, rate of the reaction also will increase, okay? Usually it will become double also, okay? For 10 degree rise of the temperature it will be. Usually yes. Clear everyone? ತಿಳಿತಿದೆನಾ ಎಲ್ಲರಿಗೂ? ಕಾನ್ಸಂಟ್ರೇಷನ್ ಬಗ್ಗೆ ತಿಳಿತಾ? ಟೆಂಪರೇಚರ್ ಬಗ್ಗೆ ತಿಳಿತಾ? Next it is going to depend on what? Temperature ಆಯ್ತು, concentration ಆಯ್ತು, right? Next it is going to depend on, I'm live, no? Okay. Next it is going to depend on the catalyst. Next ಎದ್ರ ಮೇಲೆ ಡಿಪೆಂಡ್ ಆಗುತ್ತದು? It's going to depend on the Catalyst. So the catalyst is kelsa ಏನಪ್ಪ? What is the work of the catalyst? Catalyst ಏನ್ ಕೆಲಸ ಮಾಡುತ್ತೆ? It generally increases the speed of the reaction. Okay. ಏನ್ ಮಾಡುತ್ತದೆ? It's going to just speed of the reaction increase ಮಾಡುತ್ತೆ. Speed of the reaction. Generally, it will increase the speed of the reaction by lowering the energy barrier. By lowering the energy barrier, that is also called as an activation energy. Okay. By lowering the energy barrier, that is okay, that is also called as an activation energy. Clear? ತಿಳಿತ್ರೋ ಎಲ್ಲರಿಗೂ? Yes, next comes the fourth one. Next comes the fourth one, that is also surface area. Okay, it depends on the surface area. ಈಗ surface area ಏನು ಮಾಡುತ್ತೆ actually? What is the work of the surface area? ಏನು ಮಾಡುತ್ತೆ surface area? That is, the surface area of the reactant is going to be greater the surface area. Means ಏನು ಅಕಸ್ಮಾತ್ surface area of the reactant is greater. Okay, ಅಕಸ್ಮಾತ್ ಆಗಿ surface area is greater. That is also called as what? That is also called as a smaller particle size. Okay, smaller particle size ಅಂತಾನು ಕರೀತಾರೆ ಅದಕ್ಕೆ. Clear? ಅಕಸ್ಮಾತ್ ಆಗಿ smaller particle size ಆಗುತ್ತೆ, that time the faster will be the reaction. ಏನಾಗುತ್ತೆ ಅವಾಗ? Faster will be the reaction. Faster will be the reaction. Oh my god. Clear? Catalyst ತಿಳಿತು, surface area ತಿಳಿತು. Next comes the nature of the reactant. Next comes what? Nature of the reactant. Okay. ಈಗ nature of the reactant ನಲ್ಲಿ actually ಏನಾಗ್ತಿದೆ? What is actually happening in the nature of the reactant? Here the reactant different means ಯಾವ್ಯಾವ different reactants ಅನ್ನ ಯೂಸ್ ಮಾಡ್ತೇವಲ್ಲ, that will undergo the similar kind of reaction. Means different reactants will undergo the similar. Okay. ಯಾವುದು ತಗೊಳ್ಳಿ ನೀವು. Okay, any different reactant you take it. Okay, any different reactant, it will undergo. Okay, it will undergo what? It will undergo the kind of a reaction. Means similar kind of reaction ನಲ್ಲಿ undergo ಹೋಗುತ್ತೆ. Different rates, because the energy factor is going to be involving there. Okay, different energy levels will be always be involving. Understanding? Yes, activation energy amma. I'll tell you what is the meaning of an activation energy. Okay, different reactants will undergo the similar kind of a reaction with the different rates. Okay, and different reactant will undergo different rates. Okay, in different rates. Done? In a different rates, because of the energy factor which is going to be involved. Okay, because of the energy. Done? Last one. Okay, last one, that is pressure of the light. Okay, pressure of the light. Next comes the pressure of the light. So, pressure of the light, how it is going to depend? That is, light will provide the necessary activation energy for the photochemical reaction. Okay. Actually, light will give the activation energy for the photochemical. For what it will give? It will give for the photochemical reaction purpose. It is going to give us. Clear? Photochemical reactions alvagadu ಕೊಡ್ತೋ ಇರುತ್ತೆ ಕೊಡ್ಕೋತಿರುತ್ತದೆ ಯಾವಾಗಲೂ. ಓಕೆ, ಮೀನ್ಸ್ ನೀವು ತಿಳ್ಕೊಬೇಡಿ ರಿಯಾಕ್ಷನ್ ಯಾವುದಾದ್ರೂ ಆಗ್ತಿದ್ರೆ ಡೋಂಟ್ ಥಿಂಕ್ ಇಟ್ ಲೈಕ್ ದ ರಿಯಾಕ್ಷನ್ಸ್ ಆರ್ ನಾಟ್ ಹ್ಯಾಪನಿಂಗ್ ಓನ್ಲಿ. ಓಕೆ, how to download organic lecture notes amma? How to download means it will be there in the description amma. You can just directly download them. Okay, Sita. Okay, this is all about that. Now next comes, okay, sorry, okay, yes, rate expression and rate constant. Okay, let us learn about the rate expression and the rate constant. So how to understand about the rate reaction? How you are going to understand about the rate of the reaction? Okay, one ನಿಮಿಷ guys. ಈಗ ರೇಟ್ ಎಕ್ಸ್ಪ್ರೆಷನ್ ಮತ್ತೆ ರೇಟ್ ಕಾನ್ಸ್ಟೆಂಟ್ ಅನ್ನ ಹೇಗೆ ತಗೊಳ್ಳೋದು? ಓಕೆ, ರೇಟ್ ಕಾನ್ಸ್ಟೆಂಟ್ ಅನ್ನ ಹೇಗೆ ಎಕ್ಸ್ಪ್ರೆಸ್ ಮಾಡೋದು? ಹೌ ಟು ಎಕ್ಸ್ಪ್ರೆಸ್ ದ ರೇಟ್ ಕಾನ್ಸ್ಟೆಂಟ್ ಅಂಡ್ ಹೌ ಟು ಎಕ್ಸ್ಪ್ರೆಸ್ ದ ರೇಟ್ ಎಕ್ಸ್ಪ್ರೆಷನ್. ಓಕೆ, how to understand this thing? Main thing you people are going to under the reaction, what you are going to understand? AA plus, you know already this reaction, right? BB, which will give us the product CC plus DD, right? Done. So in this, rate is going to be directly proportional to AX and BY, right? Rate is directly proportional to what? It's going to be proportional, right? Sorry. Done. Now in this, where the exponents x and y going to be considered as equal to the stereochrometric coefficient, okay? X and y will be what? It will be stereochrometric coefficient. Done. Now rate is also equal to rate in case in differentiation madidra, when you people will differentiate the rate, that is d of, okay, if you are going to differentiate the rate, d of r is equal to rate constant divided by dt. Okay, divided by dt, you can take it, or else you can also take it in this form also, means idana constant ananu tagobodu. Okay, you can take it in this constant also. Clear? Where k is a proportionality constant and rate constant, and this equation is called as rate law or rate expression. ಇದಕ್ಕೆ ಏನು ಕರೀತಾರೆ? Rate law ಅಲ್ಲದ್ರೆ rate expression ಅಂತ ಕರೀತಾರೆ. So here k will actually called as what? Rate constant. Rate constant ಅಂತ ಕರೀತಾರೆ. Done? Okay. Next comes the order of the reaction. Let us understand about the order of the reaction now. So, in order of the reaction, I'll understand what you people need to understand the order of the reaction is we have actually first order, second order and third order. Okay, sorry, only second order first order and second order, and you people have here half order also. Okay, you people even have a half order reaction. Derivations is value of the rate of the depends on the temperature, it depends on the concentration of the reactant. Yes, correct. So, the order of the reaction is the sum of the exponents, that is also called as a power, to which the molar concentrations are raised in the rate law. So, order of the reaction is going to be what? Definition enagutte? What will be the definition? What will be the definition of it? The sum of, okay? The sum of exponents, or it is also called as xy. xy togondidwala adu, okay? Exponents the sum of powers, that is xy, the sum of powers, that is also called as an xy, which is a molar concentration, which are going to be a exponents or a power to which whatever the molar concentration we are going to take it are going to be raised in the rate law. So, this molar concentration which we are going to take it, adnu raise marteve. We are going to raise it. So, we are going to raise it with what? We are going to raise it with the rate law. We are going to raise it with the rate law. So, ಈಗ rate law ಏನಿದೆ pa, what is actually the rate law? You already know the rate law already. ಈಗ last previous line ಬರ್ದಿದ್ದೆಲ್ಲ R is equal to what? K andre proportionality constant. Okay. A of x and B of y. We are doing exponents. So, these are actually both are called to be exponents. Clear? So, where A and B are going to be what? A and B are going to be what? And what will be the SI unit actually? Moles per liter will be the SI unit. Okay, this much you people understand. It's more than enough of the order of the reaction. So, nanu derivation anna direct question I'll explain martene. Okay, I'll explain you people directly the question directly. Derivation anna question I'll explain martene. Clear? So, these are actually the reactions and the unit of the rate constant, like about the zero order, first order and second order. Okay, zero order, first order and second order. That is zero order reaction, first order reaction and second order reaction. See, iga derivatives heng barutte anno torstene nimage. So, don't get confused. It's very easy. Derivatives full easy ag nimage nan heltene. Second, let me open. I think ide. Order of the reaction of first order, second order. So, this is the zero order reaction. Okay, zero order reaction anna hege explain hege solve madbekadu ಹೇಳ್ತೀನಿ ಕೇಳಿ. ಈಗ ನಮಗೆ already ಗೊತ್ತಿದೆ, right? We already know the rate is equal to k of a of x and b of y, right? ಈಗ x y exponents ಇದೆ, to both are going to be the exponents which we are going to add it and find it total one, right? ಈಗ ಅಕಸ್ಮಾತ್ ಆಗಿ zero order reaction ಅಂತ ಕೇಳಿದ್ರಪ್ಪ, okay? If they have asked about the zero order reaction, r exponent ಏನಾಗುತ್ತೆ, exponent will be 0. So first ನೀವು differentiate ಮಾಡ್ತೀರಾ, ಆಮೇಲೆ integration ಮಾಡುತ್ತೀರಾ. So ಈ derivation ನಲ್ಲಿ ಒಂದು derivation fixed. From this chapter, one derivation is fixed. So, ಅದಕ್ಕೆ perfect ಮಾಡ್ಕೊಳ್ಳಿ, ಇದನ್ನ understand ಮಾಡ್ಕೊಳ್ಳಿ. If you are not understanding, ask me. ತಿಳಿತಿಲ್ಲ ಅಂದ್ರೆ ಕೇಳ್ರಪ್ಪ. You, ma'am, derivations are easy. Very much easy there. Very much easy. Aarti is asking me some question. Wait. Ma'am, what is the general equation for the calculating the rate order reaction? Can you write, madam, please? Aarti amma. ಬರ್ದೆ ಅಲ್ಲಮ್ಮ ಜನರಲ್ ಇಕ್ವೇಶನ್ ಜಸ್ಟ್ ನಾವು ಈಗ ಜಸ್ಟ್ ಕಲಿಸ್ದೆ ಅಲ್ಲಮ್ಮ, ರೇಟ್ ಇಸ್ ಈಕ್ವಲ್ ಟು ಕೆ ಆಫ್ ಎ ಆಫ್ ಎಕ್ಸ್ ಅಂಡ್ ಬಿ ಆಫ್ ವೈ, ದಟ್ ಇಸ್ ದ ಜನರಲ್ ಇಕ್ವೇಶನ್. ಅದ್ರ ಮೇಲೆ ನೀವು ನೆಕ್ಸ್ಟ್ ಮಾಡೋದು. ಈಗ ಆರ್ ಇಸ್ ಈಕ್ವಲ್ ಟು ಎ ಆಫ್ ಎ ಅಂದ್ರೆ ಏನು, ಎರಡು ರಿಯಾಕ್ಟೆಂಟ್ ತಗೊಂಡಿದ್ದೇವೆ, ಎ ಮತ್ತು ಬಿ. ಎ ಇಸ್ ಕಟಿಂಗ್ ಕನ್ವರ್ಟೆಡ್ ಟು ಪ್ರಾಡಕ್ಟ್, ಎ ಅಂದ್ರೆ ರಿಯಾಕ್ಟೆಂಟ್, ಬಿ ಅಂದ್ರೆ ಪ್ರಾಡಕ್ಟ್, ರೈಟ್? ಈಗ ನಾವಿಲ್ಲಿ ಝೀರೋ ಆರ್ಡರ್ ರಿಯಾಕ್ಷನ್ ಫೈಂಡ್ ಮಾಡ್ತಿದ್ದೇವೆ ಅಂದ್ರೆ ಆರ್ ವಿಲ್ ಬಿ ಝೀರೋ, ಓಕೆ? ಆರ್ ವಿಲ್ ಬಿ ಝೀರೋ, ಎಕ್ಸ್ಪೋನೆಂಟ್ ಝೀರೋ ಇದೆ, ಬಿಕಾಸ್ ನಾವು ಝೀರೋತ್ ಆರ್ಡರ್ ರಿಯಾಕ್ಷನ್ ಫೈಂಡ್ ಮಾಡ್ತಿದ್ದೇವೆ. ವಿ ಹ್ಯಾವ್ ಝೀರೋತ್ ಆರ್ಡರ್, ಹಾಫ್ ಆರ್ಡರ್, ಫಸ್ಟ್ ಆರ್ಡರ್, ಸೆಕೆಂಡ್ ಆರ್ಡರ್. ಕ್ಲಿಯರ್? ಈಗ ನಾವು ಝೀರೋತ್ ಆರ್ಡರ್ ನ ಫೈಂಡ್ ಮಾಡ್ತಿದ್ದೇವೆ. ಕ್ಲಿಯರಾ? ರಿಪ್ಲೈ ಮಾಡಿದೆ ಆರ್ತಿ? Okay, now concentrate. When we are going to take it as a 0 minus, just we are going to differentiate it now. First we will differentiate it. Okay, ಹೇಗೆ differentiate ಮಾಡ್ತೇವೆ? K is equal to R naught. If you want, K is equal to R naught. Clear? Nilri, 1 second. Okay, first ಇದನ್ನ ಡಿಫ್ರೆನ್ಶಿಯೇಟ್ ಮಾಡೋದು. K of R naught ಏನಿದೆ ಅಲ್ಲ ಅದನ್ನ ಡಿಫ್ರೆನ್ಶಿಯೇಟ್ ಮಾಡೋದು. So D of R and D of dt. Okay, K of R naught. Okay, in case ಬೇಕಂದ್ರೆ so of zero order. ಒಂದೇ ಮಾಡೋದು ನಾನು zero order. First order ಎಲ್ಲ ನೀವೇ ಮಾಡ್ಕೋಬೇಕು. Okay, everything will be same only. Everything will be same only. Just little bit changes will be there. Okay, ಸ್ವಲ್ಪ changes ಅಷ್ಟೇ ಇರೋದು. So don't think like it will be too much difference will be there in both the things. Okay, rate is equal to what? K of R naught anta gottide, right? We know already that is rate is equal to, let's not take it as a rate. Okay, it's okay. Rate is equal to R of naught. Okay, R of naught anta tilkondvi, right? Rate is equal to K of R naught. Done. Okay, I didn't write the K only. ಈಗ ಡಿಫ್ರೆನ್ಶಿಯೇಟ್ ಮಾಡೋದು ಇದನ್ನ. ಓಕೆ, ಲೆಟ್ಸ್ ಡಿಫ್ರೆನ್ಶಿಯೇಟ್, ದಟ್ ಇಸ್ ಮೈನಸ್ ಡಿ ಆಫ್ ಆರ್ ಡಿವೈಡೆಡ್ ಬೈ ಡಿ ಟಿ. ಸಿ ಡಿಫ್ರೆನ್ಶಿಯೇಟ್ ಮಾಡಿದ್ರೆ ಡಿ ಆಫ್ ಆರ್, ಆರ್ ಅನ್ನ ಡಿಫ್ರೆನ್ಶಿಯೇಟ್ ಮಾಡ್ತಿದ್ದೇವೆ ನಾವು, ರೈಟ್? ಡಿ ಟಿ is equal to, what will be the is equal to answer? That will be K of R naught, right? Because ನಾವು ಅದನ್ನೇ ಫೈಂಡ್ ಮಾಡೋದು ಅದಕ್ಕೆ. Done. ತಿಳಿತಾ ಇಲ್ಲಿ ತನಕ? Next step what we are going to do when we differentiate it, that is minus d of R divided by dt divided by dt is equal to K. Okay, it is equal to K, right? So now when you are going to d of R means now actually K dt ಅನ್ನ find ಮಾಡಬೇಕು. This what you people will do, you know, ಇದನ್ನ ಏನು ಮಾಡಬೇಕಂದ್ರೆ ಇಲ್ಲಿ ತಗೊಂಡ್ಬಿಡಬೇಕು. Okay, minus dr is equal to K of dt. Okay, sorry, ulta pulta barbette. So that will be what? Yes, K of dt only. K of dt. Then minus agutte, right? Minus K of dt. Now we are going to integrate both the sides. Now next in ಮಾಡ್ತೇವೆ ನಾವು, we are going to integrate so in case now integrate ಮಾಡಿದ್ವಿ both the sides. If you are going to integrate both the sides, integration of d of r, okay, integration of d of r is equal to, integration of d of r is equal to minus k integration of dt. Okay, minus k integration of dt. Then now r is equal to minus kt plus l, right? After integrating, okay, after integration minus dr ಏನಾಗುತ್ತೆ ಇಲ್ಲಿ? What will be that? Minus r agutte, right? And is equal to, okay, minus r agutte and minus k antu hage uliyutte. Minus k will be like that only. Integration of dt will be what? Minus kt but constant plus constant. Clear? So let us consider this equation has a 1. Okay, let us consider this equation has a 1 for us. Done. Now whenever t is going to be 0 and r is going to be r naught. Okay, ಇಲ್ಲಿ ಏನು consideration ಮಾಡ್ಕೊಳ್ಳೋದು? When is t is going to be and r is going to be r naught. Clear? Let us substitute t is going to be 0 and r is going to be the r naught. Okay, so r naught ಏನಾಗುತ್ತೆ? Minus k of 0. Okay, minus r is equal to minus k of 0 plus l. Am I correct? Right? Minus r is equal to ಏನಾಗುತ್ತೆ? Minus k of 0 plus l, right? L is equal to ಏನಾಗುತ್ತೆ ಈಗ? What will be the L value? Means ಏನಾದ್ರು constant ತಗೊಂಡು 1 value, L value ಏನು constant ತಗೊಂಡಿದ್ದೀವಿ? Constant ತಗೊಂಡಿದ್ದೀವಲ್ಲ ಅದು. So L will be what? R naught ಆಗುತ್ತೆ, right? Sorry guys, I didn't write the R naught value only here. Okay, L will be R naught. L is equal to R naught. Done. L is equal to R naught. Oh, ಯಾವ್ದಪ್ಪ ಡೋಲಕ್ಪುರ? What is that? Minus should not be there. Where minus should not be there, pa? L miss madne nanu minus anna. Did I miss somewhere minus? Correct, it is no. So ಈಗ ಅದನ್ನ substitute ಮಾಡೋದು, I value ನ substitute ಮಾಡೋದು, that is r naught ಅಂತ. ಏನಾಗುತ್ತೆ? R is equal to, later substitute this thing in this. So what will be that? Minus r is equal to minus kt plus r naught. Okay, minus kt plus r naught. L ಏನು ಮಿಸ್ ಮಾಡಿದ್ನ ನಾನು? So for that purpose kt is equal to what? kt is equal to ಏನಾಗುತ್ತೆ? kt ಇಲ್ಲಿ ಮೈನಸ್ ಇದೆ ಅಲ್ಲ, ಈ ಕಡೆ ಪ್ಲಸ್ ತಗೊಂಡ್ಬರೋದು ಅಷ್ಟೇ. r naught ಮೈನಸ್ ಇದ್ದು ಪ್ಲಸ್ ಆಗುತ್ತೆ r. ಕ್ಲಿಯರಾ? kt is equal to r naught minus r ಆಗುತ್ತೆ. Oh sorry. Am I correct guys? Yes. Okay, ಇಲ್ಲಿ ಮೈನಸ್ ಬರಲ್ಲ ಅಂದ್ರಲ್ಲ ನೀವು. Okay, yeah, minus will not come here. I have written everywhere minus minus, no? Wait. Yes. So integration minus k ಇದೆಲ್ಲ. Yes. Integrate ಮಾಡಿದೆನಲ್ಲ. Yes. K r minus ಬರಲ್ಲ. Correct. Very good. So k is equal to what? K is equal to r naught minus r divided by t. So k is equal to what? K is equal to r naught minus r divided by t. Subhash is in full class mode. He has seen it. You wrote minus r. Yes. Very good, Subhash. It came at the left side. We should not write. Yes, yes, Shubha, very good, very good. Thank you for telling, Shubha. Yes, thank you, thank you. Huh? Okay, okay, done, 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 done. Now, next thing we'll go for next thing now. So, ಅದೇ ತರ same you are going to find with the integration of this also. R ಜಾಗದಲ್ಲಿ ಇಲ್ಲಿ exponent ಏನು ಹಾಕೋದು 1 ಹಾಕೋದು because they are asking us about the first order reaction. Okay, ಅವ್ರು ಏನು ಕೇಳ್ತಿದ್ದಾರೆ first order reaction ಅನ್ನ ಹಾಕ್ಬಿಡೋದು. That's it. Okay, that's it. About the first order reaction is clear everyone. ತಿಳಿತ್ರಲ್ಲ first order reaction. ಈಗ let's go back where we were actually. Temperature ಆಯಿತು ಎಲ್ಲ ಆಯಿತು, order of the reaction is done, then molecularity of the reaction integration ಆಯಿತು zero orderದು, then first order is also done, temperature dependence. Okay, we have now temperature dependence ಒಂದು ಸ್ವಲ್ಪ ಉಳಿದಿದೆ, collision theory ಎಷ್ಟು ಉಳಿದಿದೆ, calculation of activation energy ಉಳಿದಿದೆ ಅಲ್ಲ, even that is pending guys. First order, second order, ellarge tilitalla. So let's go for the temperature dependence. Okay, let's go for the temperature dependence now. How it's going to happen with the temperature dependence of the rate of the reaction. Okay, temperature dependence of rate of reaction. How it's going to work. So, for any chemical reaction, okay, the temperature now rise maridvi. In case now 10 degrees Celsius temperature and rise markont hodvapa, okay. Any of the chemical reaction temperature and jasti markont hodvi about 10 degrees Celsius. 10 degrees Celsius in the increase markont hogtive. Next again 10 degrees Celsius. Next one again 10 degrees Celsius. Adra increase markont. Nearly it will be double. Okay, nearly enagutte completely double agutte, right? Temperature increase markont hodre 10 degrees Celsius in the nearly it will become the double, right? So for that ratio, okay, for that ratio rate constant of almost 308 Kelvin, okay, to that it will be 298 Kelvin, right? So that temperature coefficient of the reaction, that is actually called as what? Coefficient reaction. Clear? Tirita? Yes, Shubham. Thank you for telling. Papa, now ಆಗಿಂದ ಹೇಳ್ತಿದ್ದೆ ನಾನು ಮೈನಸ್ ನೋಡಿರಲಿಲ್ಲ. Okay, it's okay. Sorry, huh? So what happens? The ratio of the rate constant, okay? The ratio of the ratio of the rate constant at 308 Kelvin and 298 Kelvin, okay, to that of the 298 Kelvin, okay, to that of a 298 Kelvin, it is going to be called as coefficient. It is also called as temperature coefficient reaction. Is called temperature coefficient rate of reaction. Okay, temperature coefficient of the reaction. Okay, done. ನಾವೀಗ ಇದರಲ್ಲಿ ಅರೆನೆಸ್ ಇಕ್ವೇಶನ್ ಅಂತ ಒಂದು ಕಲಿತೇವೆ. ಓಕೆ, ವಿ ವಿಲ್ ಲರ್ನ್ ಅಬೌಟ್ ದ ಅರೆನೆಸ್ ಇಕ್ವೇಶನ್ ಹಿಯರ್. K is equal to activation energy. ಅರೆನಿಸಮ್ ಅಂತ ಇಕ್ವೇಶನ್ ಅನ್ನು ಕರಿಬಹುದು. ಅದಕ್ಕೆ ನನಗೆ ಗೊತ್ತಿಲ್ಲಪ್ಪ, ನೀವು ಹೇಗೆ ಪ್ರೊನೌನ್ಸ್ ಮಾಡ್ತೀರಾ ಮಾಡಿ. ಓಕೆ, ಇಲ್ಲಿ ಏನಿರುತ್ತೆ, ಕೆ ಇಸ್ ಆಕ್ಚುಲಿ ಈಕ್ವಲ್ ಟು ಎ ಆಫ್ ಇ ಮೈನಸ್ ಇ ನಾಟ್. ಓಕೆ, ಕೆ ಇಸ್ ಈಕ್ವಲ್ ಟು, ಓಕೆ, ಕೆ ಇಸ್ ಈಕ್ವಲ್ ಟು ಎ ಆಫ್ ಎ ಅಂದರೆ ಕೋಯಿಫಿಷಿಯಂಟ್ ಇರುತ್ತೆ ಅದಕ್ಕೆ. ಓಕೆ, ಎ ಇಸ್ ಈಕ್ವಲ್ ಟು ಮೈನಸ್ ಇ ನಾಟ್ ಡಿವೈಡೆಡ್ ಬೈ ಆರ್ ಟಿ, minus E naught divided by RT. So effect of the catalyst on the rate of reaction is going to be how? So the catalyst will be the substances where it will be the increase of the rate of the reaction is going to happen. There will be an increase in the rate of the reaction. Slowly, when the rate of the reaction is going to increase, that time it will undergo the permanent chemical change. Okay, slowly our rate of the reaction will increase. No, that time it will permanently change the chemical change permanently ಆಗ್ಬಿಡುತ್ತೆ. ಕ್ಲಿಯರ್? ಸೊ ಯಾವಾಗ ಆಗುತ್ತೆ ಪರ್ಮನೆಂಟ್ಲಿ ಅನ್ನೋದು ಹೇಳ್ತೇನೆ ನೋಡಿ. ಕೆ ಇಸ್ ಈಕ್ವಲ್ ಟು ಎ ಆಫ್ ಇ ಮೈನಸ್ ಇ ನಾಟ್ ಆರ್ ಟಿ ಅಲ್ಲಿ ಇಫ್ ಇನ್ ಕೇಸ್ ಎಫೆಕ್ಟ್ ಆಫ್ ದ ಕ್ಯಾಟಲಿಸ್ಟ್, ಇಫ್ ಇನ್ ಕೇಸ್ ಎಫೆಕ್ಟ್ ಆಫ್ ದ ಕ್ಯಾಟಲಿಸ್ಟ್ because catalyst ಬಹಳ ಇಂಪಾರ್ಟೆಂಟ್ ಪಾರ್ಟ್ ತಗೊಳುತ್ತೆ. ಓಕೆ, catalyst will play a very important role in everywhere, especially in the chemical kinetics, because catalyst ಇಂದಾನೇ ಯಾವ ಥರ ರೇಟ್ ಆಫ್ ದ ರಿಯಾಕ್ಷನ್ ಆಗುತ್ತೆ ಅನ್ನೋದು ಗೊತ್ತಾಗುತ್ತೆ. ನೀವು ಇವಾಗಿನ catalyst ಕೆಲಸ ಏನು, ಸ್ಪೀಡ್ ಮಾಡುತ್ತೆ, ಒಂದೊಂದ್ಸಲ ಸ್ಲೋ ಮಾಡುತ್ತೆ ಅಂತ ಅಷ್ಟೇ ಗೊತ್ತಿದೆ. ಬಟ್ ಅದು ಆ್ಯಕ್ಚುಲಿ ಸ್ಪೀಡ್ ಮಾಡೋದು, ಸ್ಲೋ ಮಾಡೋದು, ರಿಯಾಕ್ಷನು ಅವೆಲ್ಲ ಎದ್ರ ಮೇಲೆ ಡಿಪೆಂಡ್ ಆಗಿದೆ? ರೇಟ್ ಮೇಲೆ ಡಿಪೆಂಡ್ ಇದೆ. ಓಕೆ, ಇಟ್ಸ್ ಆಲ್ ಡಿಪೆಂಡೆಡ್ ಆನ್ ದ ರೇಟ್. Clear? So for that purpose only, effect of the catalyst on the rate of the reaction is going to be on the rate of the reaction ಮೇಲೆ ಡಿಪೆಂಡ್ ಆಗಿರುತ್ತೆ. ಹೇಗಪ್ಪ ಡಿಪೆಂಡ್ ಆಗುತ್ತೆ? That is like this is a substance. Okay, it will increase the rate of the reaction, the substances, any substances which is there, that will be increased the rate of the reaction without itself undergoing, okay, without itself undergoing a permanent chemical change. Clear? Without undergoing any permanent chemical change. Clear everyone? Tilita? So now catalyst is going to provide us the alternative pathway for the reaction mechanism also. Okay, that is the catalyst does not alter any Gibbs of energy. First thing is okay, it will not alter the any Gibbs energy and alter ಮಾಡಲ್ಲ ಅದು. Okay, that is delta G and delta H of the reaction will be same itself. Okay, so this catalyst is going to be the spontaneous reaction but does not go catalysis on non-spontaneous reaction. So this catalyst is going to be the reaction, spontaneous reaction irutte, but it will not go under the non-spontaneous reaction. It will not go under the non-spontaneous reaction. It will not go under the non-spontaneous reaction. Clear? Okay, clear till here everyone? Tilita? So this is how the reaction will be. Idi hange agatki nodili. The reactants, whenever the reaction path with catalyst is going to be used, reaction path without the catalyst, how it's going to happen. But the energy of the activation of with catalyst ana hege reaction form agutte. Okay, with the energy of the activation and with the energy of the reaction of the without catalyst ಹೇಗೆ ಫಾರ್ಮ್ ಆಗುತ್ತೆ ಮತ್ತೆ ಎನರ್ಜಿ ಆಫ್ ಆಕ್ಟಿವೇಶನ್ ಎನರ್ಜಿಯಿಂದ ಹೇಗೆ ಫಾರ್ಮ್ ಆಗುತ್ತೆ ಮೀನ್ಸ್ ಒಂದ್ಸಲ ಗ್ರಾಫ್ ನೋಡ್ಕೊಂಡ್ಬಿಟ್ರೆ ನಿಮಗೆ ಈಸಿ ಆಗುತ್ತೆ ಹೌ ಆಕ್ಚುಲಿ ಇಟ್ಸ್ ಬೀನ್ ಹ್ಯಾಪನಿಂಗ್. ಓಕೆ, ನಿಮಗೊಂದು ಐಡಿಯಾ ಗೊತ್ತಾಗುತ್ತೆ. ಡನ್. ಸೊ ದಿಸ್ ಇಸ್ ದ ನೆಕ್ಸ್ಟ್ ಕಮ್ಸ್ ದ ಕ್ಯಾಲ್ಕುಲೇಷನ್ ಆಫ್ ಇಟ್. ಸೊ ದಟ್ ಈಸ್ Arrhenius equation, same everything, it will be same itself. So this is how the calculation is. Next comes the collision theory of chemical reaction. Okay, let me see how much is remaining still. Okay, our last topic, that is going to be the collision theory of chemical reactions. Collision theory of chemical reactions. So in collision theory of chemical reactions, what we are going to learn? Reaction is going to occur when the molecules will collide with. So yavaga molecules collide agutte. Whenever the molecules are colliding with appropriate orientation and sufficient energy, not all the molecular collision will result to the successful formation of the product. Yes. So yavyad collision aguttalla, ella collision anna ಸರಿಯಾಗಿ ಪರ್ಫೆಕ್ಟ್ ಪ್ರಾಡಕ್ಟ್ ಅನ್ನ ಫಾರ್ಮ್ ಮಾಡಲ್ಲ. ಇಟ್ ವೋಂಟ್ ಪ್ರೊಡ್ಯೂಸ್ ಎನಿ ಪರ್ಫೆಕ್ಟ್ ಫಾರ್ಮುಲಾ. ಓಕೆ, ಪರ್ಫೆಕ್ಟ್ ಅನ್ನ ಫಾರ್ಮ್ ಮಾಡಲ್ಲ. ಕ್ಲಿಯರ್? ಓಕೆ, ಫ್ರಾಕ್ಷನ್ ಆಫ್ ದ ಮಾಲಿಕ್ಯೂಲ್ಸ್. Then next, for any successful collision, particles must collide with the sufficient energy. So sufficient energy and the collide ಮಾಡಬೇಕು ಅಂದ್ರೆ particular product ಅನ್ನ ನಾವು find ಮಾಡಬಹುದು easy ಆಗಿ. Clear? Next one is they need to have a correct alignment and collision geometry also. Correct alignment should be present. Correct alignment should be present, and to keep the EA as low as possible. Means activation energy ಅನ್ನ ಎಷ್ಟು ಕಡಿಮೆ ಇರುತ್ತೆ ಅಷ್ಟು ಪಾಸಿಬಿಲಿಟಿ ಆಗಿ ಕಡಿಮೆ ಇಟ್ಕೋಬಹುದು. ಕ್ಲಿಯರ್? ಕ್ಲಿಯರ್? Ma'am, tan ಆಯ್ತು. How many hours still? How many hours ಇಲ್ಲಮ್ಮ? Just 10-15 minutes it will be done. Okay. Next, to account for the efficient collision, another factor P is called as an orientation factor. It is also called as an orientation factor, or also a static factor, or probability factor is being introduced. That is K is equal to P of ZAB minus E of E naught. Means ನಮಗೆ activation energy already ಗೊತ್ತಿದೆ. ಆ activation energy ಗೆ just P ಅಂತ ಹಾಕಬೇಕು. Orientated potential energy ನ ಹಾಕಬೇಕು ಅಷ್ಟೇ. We are commenting, you are not responding. Proper orientation. ಮಮ್ಮ ಈಗ ಜಸ್ಟ್ ಹೇಳದೇ ಇಲ್ಲಮ್ಮ, 10 ನಿಮಿಷ ಮುಗಿಸ್ತೇನೆ. ಎಷ್ಟು ಸಲ ವದ್ರಿ ಹೇಳೋದು? We are commenting. Okay, ಶಶಿ ಹೇಳಮ್ಮ, ಹೇಳು. ಮತ್ತೇನು ಕಮೆಂಟ್ ಹಾಕಿದೀಯಾ? ನಾನು ಏನು ಕಮೆಂಟ್ ಹಾಕಿದೀಯಾ ಅದನ್ನು ನೋಡಿ ಹೇಳಿದೆ ಆಲ್ರೆಡಿ. Okay, ZAB is going to be represented as what? Collision frequency of the reactant A and B. Okay, A and B. Clear? So this is how the reaction will be there. Okay, how the reaction will be there. Clear? No products will be formed if it is a no improper orientation. See, ಇಲ್ಲಿ ಅಕಸ್ಮಾತ್ ಓರಿಯಂಟೇಷನ್ ಪ್ರಾಪರ್ ಆಗಿ ಇದ್ದಿರಲಿಲ್ಲ ಅಂದ್ರೆ ಪ್ರಾಡಕ್ಟ್ ಫಾರ್ಮ್ ಆಗಲ್ಲ. ಸೊ ದ ಓರಿಯಂಟೇಷನ್ ಶುಡ್ ಬಿ ಪ್ರಾಪರ್. ಓರಿಯಂಟೇಷನ್ ಪ್ರಾಪರ್ ಆಗಿ ಅರೇಂಜ್ಮೆಂಟ್ ಆಗಿರಲಿಲ್ಲ, ದೆನ್ ದ್ಯಾಟ್ ZAB ಬ್ಲ ಆಗ್ತಿದೆ ನತ್ತೆ. So this ZAB ಏನಿದೆಯಲ್ಲ, that should be perfect. If that is perfect, then only we are going to get the product easily. ಅಂದ್ರನೆ ಪ್ರಾಡಕ್ಟ್ ಈಸಿಯಾಗಿ ಸಿಗುತ್ತೆ. ಕ್ಲಿಯರ್? ತಿಳಿತಮ್ಮ ಶಶಿಕಾ? Again I'm telling it like a girl. Sorry, you are a boy, no? ತಿಳಿತಪ್ಪ? Threshold energy ಬಿಟ್ನ ನಾನು. I have let threshold energy. I don't know. Let's see. So few questions we'll see it. Chemical kinetics ಮೇಲೆ ಯಾವ ತರ ಕ್ವಶನ್ಸ್ ಕೇಳ್ತಾರೆ ಅನ್ನೋದು ನಾನು ಸ್ವಲ್ಪ ಹೇಳ್ತೇನೆ. First is explain the two factors affecting the rate of the reaction. So nature of the reactant ಮೇಲೆ I have already explained this thing properly. So ನಿಮಗೆ ಬೇಕಂದ್ರೆ notes refer ಮಾಡ್ಕೋಬಹುದು. That is nature of the reactant to, concentration of the reactant to, temperature ಮೇಲೆ ಡಿಪೆಂಡ್ ಆಗುತ್ತೆ, and presence of the catalyst ಮೇಲೆನೂ ಡಿಪೆಂಡ್ ಆಗುತ್ತೆ. ಎಸ್ ಶಶಿ, ನನಗೆ ಗೊತ್ತಪ್ಪ, ನಿನಗೆ ನಾವು ಅವಾಗಿಂದ ಶೀಶಿ ಅಂತ ಕರಿತಿದ್ದೇನೆ. ಸಾರಿ, ಶೀಶಿ ಕರೆಯಲ್ಲ. ಓಕೆ, ನೆಕ್ಸ್ಟ್ ಕಮ್ಸ್ ದ ರೇಟ್ ಲಾ ಎಕ್ಸ್ಪ್ರೆಷನ್ ಅಂಡ್ ರೈಟ್ ಇಟ್ಸ್ ಮ್ಯಾಥಮೆಟಿಕಲ್ ಫಾರ್ಮ್. ಓಕೆ, ನೆಕ್ಸ್ಟ್ ಡಿಫೈನ್ ಆರ್ಡರ್ ಆಫ್ ದ ರಿಯಾಕ್ಷನ್. 0 ಫಸ್ಟ್ ಆರ್ಡರ್ ಎಲ್ಲ ಹೇಳಿದೆ ನಾನು, ಆಲ್ರೆಡಿ ಡಿಸ್ಕಸ್ ಆಗಿದೆ. Next. Yes, there are an integrated rate constant first order reaction in which the reaction is occurred gas phase dalli helde. Derive half period. See, ಇಲ್ಲಿ ನೋಡಿ. So ಈಗ first order second order 0 order ಗೊತ್ತಾತಲ್ಲ, ಇಲ್ಲಿ ಏನು ಮಾಡುತ್ತೆ, you are just going to take T is equal to half. Okay, ಇಲ್ಲಿ ಸ್ವಲ್ಪ ಡಿಫರೆನ್ಸ್ ಬರುತ್ತೆ half ನಲ್ಲಿ. T is equal to T half ತಗೋತಾರ, R is equal to R naught by divided by 2. ಅಲ್ಲಿ T is equal to 0 ತಗೋತಿದ್ದಾರೆ. ಓಕೆ, ಅಲ್ಲಿ ಇಂಟಿಗ್ರೇಟ್ ಮಾಡೋ ಟೈಮ್ದಲ್ಲಿ ಫಸ್ಟ್ ಆರ್ಡರ್ ಸೆಕೆಂಡ್ ಆರ್ಡರ್ ನಲ್ಲಿ T is equal to 0, R is equal to R naught ತಗೋತಿದ್ದೀರಾ. ಇಲ್ಲಿ ಏನು ಮಾಡ್ತೀರಾ, T is equal to T half ತಗೊಳ್ಳೋದು, R is equal to R naught divided by 2 ಅಂತ ತಗೊಳ್ಳಿ. ಕ್ಲಿಯರ್? ಇನಫ್, ಅಷ್ಟೇ ಸಾಕು. Yes, difference between order and molecularility is also very different, important. Okay, nanu gottilla adi elli hoytu question. Yes, but difference between of the order and molecularility is very important. So this is a graphical represent of a catalyst of a rate of the reaction. Andre ondsala kelidru model question paper nalli actually kelidru idನ್ನ question ಅನ್ನು. Okay, yes, difference between, yes, very good Shashi, reminded me very well. So ಏನು order ಮತ್ತೆ molecularity difference ಅನ್ನು ಕೇಳ್ತಾರೆ, please do that also. ಕಂಪಲ್ಸರಿ ಡ್ರಾ ದ ಗ್ರಾಫ್ ಆರ್ ನೋ. ಇದು ನಿಮಗೆ ಅಕಸ್ಮಾತ್ ನಿಮಗೆ ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್ ಆಗಿತ್ತಂದ್ರೆ ಗ್ರಾಫ್ ತೆಗೆದ್ರೆ ಇಟ್ಸ್ ಲೈಕ್ ಹೇಗೆ ಹೇಳ, ನಿಮಗೆ ಗ್ರಾಫ್ ತೆಗೆದ್ರೆ ಬೆನಿಫಿಟ್ ಇದೆ. ಓಕೆ, ಬೆನಿಫಿಟ್ ಇದೆ. ಪೇಪರ್ ಯಾರು ಚೆಕ್ ಮಾಡ್ತಿರ್ತಾರಲ್ಲ, ಗ್ರಾಫಿಂದ ಒಂದು ಸ್ವಲ್ಪ ಫಸ್ಟ್ ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್ ಆಗುತ್ತೆ ಈಸಿಯಾಗೆಲ್ಲ. ಸೊ ಅದ್ರ ಸಲುವಾಗಿ ಗ್ರಾಫ್ ತೆಗಿಯೋದು ನೆಸೆಸಿಟಿ ಇದೆ ಅಂತ ಅನಿಸುತ್ತೆ ನನಗೆ. ಸೊ ಇಟ್ಸ್ ಬೆಟರ್ ಇಫ್ ಪೀಪಲ್ ವಿಲ್ ಡ್ರಾ ದ ಗ್ರಾಫ್, ದೆನ್ ಇಟ್ ವಿಲ್ ಬಿ ಗುಡ್ ಟು ಯು. ಓಕೆ, ಇಫ್ ಯು ಪೀಪಲ್ ವಿಲ್ ಡ್ರಾ ಇಟ್, ದೆನ್ ಇಟ್ ವಿಲ್ ಬಿ ಗುಡ್ ಟು ಯು ಪೀಪಲ್. ಡ್ರಾ ಮಾಡ್ರಪ್ಪ, ಏನಾಗೋದಿದೆ, ಭಾಳ ಆದ್ರೆ ಏನಾಗೋದಿದೆ, ಏನೂ ಆಗಲ್ಲ. ಓಕೆ, ನಥಿಂಗ್ ಮಚ್ ವಿಲ್ ಹ್ಯಾಪನ್ if you people draw. Zero first order reaction. Okay, I skip zero first order reaction. I'll explain it next class. Okay. Okay, anything doubt? Please first tell me any doubt you people have in this. So already now no preparatory exam ge chemistry in the most 10 top named reactions ಅಂತ just video ಬಂದಿರಬೇಕು, ಇಲ್ಲಿ ನೋಡಿರ್ಬೇಕು ನೀವು. ಸೊ ದಟ್ 10 ಟಾಪ್ ನೇಮ್ಡ್ ರಿಯಾಕ್ಷನ್ಸ್ ಅನ್ನ ಚೆನ್ನಾಗಿ ಕುಂತು ಓದಿ, ಬಿಕಾಸ್ ಆ 10ರಲ್ಲಿ ಒಂದು 6 ಅಂತೂ 100% ಬೀಳುತ್ತೆ, ಆಯ್ತಾ. ಸೊ ಒಂದು 5ರಿಂದ 6 ನೇಮ್ಡ್ ರಿಯಾಕ್ಷನ್ಸ್ ಬಿದ್ದೇ ಬೀಳುತ್ತೆ. ಸ್ಟಡಿ ದೋಸ್ ಥಿಂಗ್ಸ್ ಆಲ್ಸೋ. ಕ್ಲಿಯರ್? Game over. Yes, Subhash, game is over mine today. So game is done now. So please sit and study those questions also properly. 100 questions ಅಂತ ಇದೆಯಲ್ಲ, ಆ 100 questions ಅನ್ನು ಕುಂತು ಓದಿ. ಒನ್ ಶಾರ್ಟ್ಸ್ ಟೈಮ್ ಸಿಕ್ಕರೆ ಒನ್ ಶಾರ್ಟ್ಸ್ ಅನ್ನು ಕುಂತು ಓದಿ. ಓಕೆ ಮ್ಯಾಮ್, ಆಲ್ ರಿಯಾಕ್ಷನ್ ಇನ್ ಒನ್ ಪೇಜ್. ಆಲ್ ರಿಯಾಕ್ಷನ್ ಇನ್ ಒನ್ ಪೇಜ್ ಆಲ್ರೆಡಿ ಬರೆದು ಕೊಟ್ಟಿದ್ದೇನಪ್ಪ. ಐ ಹ್ಯಾವ್ ಡನ್ ದ ವಿಡಿಯೋ ಓನ್ಲಿ. ಗೋ ಆ್ಯಂಡ್ ಚೆಕ್ ದಟ್ PDF. I will share it. I'll tell them to upload the PDF also tomorrow itself. PDF upload ಆಗಲಿಲ್ಲ ಅಂದ್ರೆ ಫಟ ಸ್ಕ್ರೀನ್ಶಾಟ್ ತಕ್ಕೊಂಡ್ಬಿಡೋದು. ಓಕೆ ಮ್ಯಾಮ್, ಕ್ರಿಟಿಕಲ್ ಎಫೆಕ್ಟಿವ್ ಕೊಲಿಷನ್ ಅಕಾರ್ಡಿಂಗ್ ಟು ದ ಕೊಲಿಷನ್ ಥಿಯರಿ ಮಾಡಿ, ಅದನ್ನು ಮಾಡಿ. ಓಕೆ, ಕ್ಲಿಯರ್ ಎವ್ರಿ ಒನ್? ಡನ್. ಮೋಸ್ಟ್ ಇಂಪಾರ್ಟೆಂಟ್ 10 ಇಂಪಾರ್ಟೆಂಟ್ ನೇಮ್ಡ್ ರಿಯಾಕ್ಷನ್ಸ್ ವಿಡಿಯೋ ಹಾಕಿದ್ದೇನೆ ಆಲ್ರೆಡಿ. ಇನ್ 2 ದಿನದಲ್ಲಿ ನಿಮಗೆ ಟಾಪ್ 5 ನ್ಯೂಮರಿಕಲ್ ಪ್ರಾಬ್ಲಮ್ಸ್ ಫ್ರಮ್ ದ ಸೊಲ್ಯೂಷನ್, ಎಲೆಕ್ಟ್ರೋಕೆಮಿಸ್ಟ್ರಿ ಅಂಡ್ ಕೆಮಿಕಲ್ ಕೈನೆಟಿಕ್ಸ್ ಸಿಗುತ್ತೆ. Clear? And most important, give reasons from the D and F block elements also video. I'll upload it. Okay, ಅದ್ರದ್ದು ಒಂದು ಅಪ್ಲೋಡ್ ಮಾಡ್ತೀನಿ. D and F block elements ಇಂದ ಯಾವ ಥರ give reasons ಕೇಳ್ತಾರೆ ಅನ್ನೋದು. So those also top 5 I will do it. So you can just check those videos before you, means ಎಲ್ಲ ಓದಿದ ತಕ್ಷಣ ಒಂದ್ಸಲ ಚೆಕ್ ಮಾಡಿಬಿಟ್ರೆ ನಿಮಗೆ ಈಸಿ ಆಗುತ್ತೆ. ಓಕೆ, ಓಕೆ, I'll tell biology sir to upload ಅಪ್ಪ. Depended on the orientation and threshold energy. Threshold energy ಹೇಳಿದೆಲ್ಲಪ್ಪ. Threshold energy I have told it. Done? Okay then guys, see you everyone. Bye bye. Good night. I should go home.